Hi guys and girls all over the world, welcome to the Cloud First. This is the first actually, indeed this is the Cloud Native European Conference and you won't be sorry to be here today. This is made by developers and for developers. We're so happy to have you here. Let me introduce myself real quick and know that this event is en français et en anglais, in English and in French. I'm Charline, I'm a Dev PMM, Developer Relations at Microsoft. Je suis Charline, Developer Relations chez Microsoft. Ravie de vous voir nombreuses et nombreux. Et je ne suis pas toute seule dans cette histoire. Adrien, camarade.
Salut Charline, moi je suis Adrien. Hi everyone, I'm Adrien. I'm come from Belgium and I'm a Microsoft MVP and finally I have my own company. I'm freelance in Belgium. And I'm not alone. With Charline, we have also Philippe. Hi Philippe.
Hi guys, hi girls. I'm Philippe. I'm from Strasbourg, France. So je suis bien français et je viens de Strasbourg. And I'm a passionate developer, passionate by cloud native architectures and development. With all my teammates, we worked really hard to provide you that amazing event. So we are really happy to be here with you. Ça va être une journée très très bien remplie. So let's start over with a little story on how do you cook a little recipe, how do you cook a great tech conference. So this is basically the recipe we took for building the TheCloudFirst. So we are a six-pack of developers, a six-pack of friends, grown locally and grain-free. And we are all passionate and we have one common passion, which is development and architecture, and especially cloud native solutions. And we shared one dream that we nurtured for years as we are strongly working with communities. And we have that dreams to build our own conference, really the conference we dream about. So the instruction for that recipe is that you have to mix all your ingredients and make them emulsify until you have a real good conference project. And once you have your team, your developer and your project, take the best speakers from all around the world all together and bring them at the same place, same day to give the best experience possible to everyone. And with all of that, you need to add a lot of sweet toppings with all of our friendly partners and also sponsors to make that happen. And today we are at the end of that recipe, and we just need to share the result with you and give you a piece of that, and hope you will enjoy that.
Mais merci Philippe, pardon. Mais cet événement, il est organisé sur une plateforme qu'on va vous présenter juste à l'instant, qui a pour but de centraliser tout le monde, qui est le live TV portal qu'on a mis à votre disposition avec les 3 tracks en français et en anglais. Et on a également mis en place un Discord pour que toute la journée, vous puissiez échanger vos impressions, mais aussi vos expériences tout au long de la journée. Toutes les plannings, toutes les sessions sont disponibles directement sur le site web et seront disponibles en replay par après. Par contre, il y a un truc qui est important pour nous et qui nous tient beaucoup à cœur, c'est que l'événement est suivi par un code of conduct. C'est-à-dire qu'on s'est engagé envers les speakers, on s'est engagé envers nous-mêmes à respecter quelques règles qui se trouvent sur le site web. On va mettre le lien dans les différents canaux Discord. Et on va vous demander de prendre un petit temps pour lire ce qui est le contenu de ce Code of Conduct afin de s'assurer que tout le monde puisse passer un événement dans les meilleures conditions et que tout le monde soit respecté comme il se doit. Vous pouvez tous nous suivre et partager vos feedbacks sur les réseaux sociaux, sur Twitter, TheCloudFirst.io, sur LinkedIn, TheCloudFirst, et sur Facebook, TheCloudFirst.io. Et toute cette journée, nous allons vous demander de partager avec nous vos feedbacks sur le hashtag TF2020.
TCF 21.
TCF 2021.
TCF21. That's the hashtag you want to remember. All right. So you see, it was a very, very yummy recipe that Philippe has going on. So what's the plan? Let's take a look at the menu now. Track 1. Track 1 will definitely be the best because I'll be hosting it. No, seriously, they're all fun. They're all amazing, but track one will be in English. So why do you want to be there? You want to be there because you're going to hear about quantum computing, about serverless, about data lake, cloud migration, governance and DevOps, migrating a monolith to cloud native, and IAM and Canary releases. So you want to be there. We have wonderful speakers that are just waiting for you. And see, there's the end with a little question mark there. There's a little surprise for you. Let's see track 2 then.
Yeah, I will be your host for the track 2, which will also be in English. And also on this track, even if I will hosting it and not Charlene, it will also be an amazing track, and you will have, as you can see, a really, really huge amount of very, very interesting conference. We'll talk about first, what does cloud native mean anyway? Because that's the topic of the conference, right? So we just want to take a look at that. We'll talk about reactive architectures, cloud data warehouse. We'll talk about IoT stories. We'll talk about also best practices, multi-cloud clusters, cloud and pipelines, security. We'll talk about production strategy. And also we'll have, you can see at noon 20 that we'll have in each track some lightning talks. You can see it, but the lightning in front of it. So short formats, only 20 minutes with some different topics. And in our track, we'll have Women in Tech, Ed in the Cloud, Hard in the Community with Holly Lehman and Isidora Katanich that will share their experience on the community. When you are a woman in tech, it will be really interesting. So be sure to be there. And it's just before the break, so I will have I think you will be fully plenty at the end of the day. And so to finish, I will take you to the track 3 with Adrien.
Alors, la track 3, c'est la meilleure track parce que c'est en français déjà. Il semblerait que la France a gagné la Coupe du Monde de football. J'ai du mal à le croire, mais c'est une autre histoire. Et donc, pourquoi est-ce que c'est la meilleure? Ben, simplement parce qu'on a les meilleurs speakers, pas comme les autres tracks, la 1 et la 2, il faut être honnête. Et donc, par rapport à ça, on va parler de FinOps avec un impact environnemental. C'est important aujourd'hui d'avoir une vision sur comment réduire nos coûts au niveau de l'impact environnemental, mais aussi tout ce qui est microservices dans un contexte serverless. On passera ensuite à une application dans le cloud, comment attirer notre attention sur 10 points et conseils importants pour pouvoir mettre ça en place. Les distributed applications, donc c'est important aujourd'hui d'avoir une vision là-dessus et comment faire ça grâce à Stéphane Eikens. Le Lightning Talk, juste avant de midi, parce que là, on vient de terminer une bip, il y aura un gros mot à ce moment-là, de matinée. Et là, dans cette matinée, on va se terminer par un petit kata d'architecture qui est présenté par Alexandre, qui va nous revenir parce qu'il a déjà fait une bonne conférence. Ensuite, on s'arrête pour le break. Il est temps de boire des bières. Non, en France, on n'en boit pas. On boit du vin chaud ou peu importe. Et après, on part sur un après-midi mais de folie avec Laurent Bugnon qui commence par déplacer vos data from the on-premise to the cloud. On va parler d'un peu d'AWS avec comment gérer ses comptes, sa gestion de compte as code, les design patterns pour la résilience de la disponibilité. On va continuer ensuite pour un cache à jour pour toujours. Et enfin, on va terminer, et encore, c'est pas vraiment la fin, sur l'industrie 4.0 avec des retours concrets, un retour d'expérience par Vincent qui est un super speaker et il attendra à partir de 16h35 votre visite pour poser plein de questions sur son Rex. Et c'est la fin. Non, c'est pas la fin. Philippe, qu'est-ce que tu en dis?
Yeah, sure. It's not the end, but all along the day, just before we talk about the surprise for the end of the day, all along the day, be sure to share your experience and or everything you can live in that conference on Twitter. Each tweet will be another chance to win your sticker pack. We'll have 10 collector sticker packs that will be drawn during the day for happy winners that will receive their own stickers from the conference at home.
And also, if we want to do another CloudFirst, we need to get your feedback. Did you like the session you just saw? How did you love it? Did you think that something could have been changed? We need to have your feedback to make sure that the second edition would be as good as the one you'll be following today. And also take a chance.
Yeah, that's really important to us.
It is.
And also to finish the surprise, as one day is not enough. We planned for you to have the possibility to take free workshop with other top speakers that will take place tomorrow. So you will be able to book your seat until tonight to take that workshop. So there are 4 workshops during the day, one in French by Etienne and the other one in English. So you can see that there are different topics, but really, really good workshops that will bring you to try new things for 2 to 3 hours online. So be sure to book your seat. Places are limited, so be sure to check it out and join us tomorrow to extend the CloudFirst experience.
One thing it's really important for the workshop, it's free. It's fully free. You can sit and enjoy.
Yeah, all the event is free.
Yeah, all the event. Et si c'est gratuit, que ce soit les workshops ou les sessions d'aujourd'hui, c'est grâce à nos sponsors, à Microsoft, à SquirrelMind, à Reboot Conseil, mais à tous nos autres partenaires, Boogler, Microsoft Innovation Center de Mons, Sense of Tech, le DevApps, le Mug, et je ne vois plus le dernier. Merci, je ne le voyais pas. Mais aussi à tous nos partenaires, parce qu'en fait, on n'est pas que tous les 3, on était aussi une équipe, comme, pour que la sauce monte, comme l'a expliqué tout à l'heure, pardon, pas Frédéric, mais Philippe. On était 6, on a été rejoints par la charmante Charline, qui vient nous aider à faire le MC tout au long de la journée et qui va venir être dans la track 1, mais si vous voulez voir des sessions de qualité, c'est dans la track 3 que ça se passera.
You're the worst.
No, track 2 is the best.
Track 3.
Okay.
That's I think for me.
Yeah, that's it for us also. So, Charlene, you want to add something else before we go?
I just can't wait to start. And we have people waiting already and just waiting for us to begin. So how come we go into the different track? Just be sure that you don't miss the session you want to see. You'll be sorry if you miss it. So make sure you see all the little schedule that we made available for you guys. Make sure you send all the love through the feedback, through Twitter and all social media accounts. That will mean the world to us, and that will make that experience even better for everybody. So we'll see you in a bit, and have a wonderful experience.
Exactement. Comme Charline l'a dit, vous n'avez aucune...
track 2 and other tracks.
Yeah, no, only on track 3. Comme Charline l'a dit, vous n'avez aucune excuse pour rater aujourd'hui de CloudFirst, la première édition.
Ouais.
On va vous demander toute la journée de partager votre expérience avec nous toute la journée. On sera là pour vous écouter et pour vous accompagner.
Okay, so let's go. C'est parti.
C'est parti.
Hello, everyone. I hope you're fine and you managed to find your way through YouTube. As you probably saw, we experienced a little technical problem on our live platform. This is the first edition, so we're still learning. So hopefully you find your way to the track 2. You're on the right track. And to begin the day, we were thinking that what's a better idea than going back to the basic. What does cloud natives mean anyway? As you are on a conference fully dedicated to cloud native architectures and solutions. So we are welcoming Grace on the track to start the day. So we are really happy to have you here with us, Grace. Thank you for coming.
Thanks for having me.
I've heard you worked in a very different field before becoming a software developer. Can you tell us a little more about it?
Yeah, so I didn't do the traditional route into software dev. I was a biologist specializing in tropical fish,
Okay.
Which hasn't really come into my job very much since.
Okay, nice. Okay, so we will not talk about fish today. Actually, we can find time for that later. But yeah, let's go to the topic I'm interested in today. Okay, I give you the stage, Grace. It's all yours.
Thank you so much, and thanks for having me. It's great to join you all this morning. I'm so excited to kick off this conference. So yeah, I'll be talking about what does cloud native mean anyway. So we're going, as I said, right back to basics. What does it really mean for an application to be cloud native? So my name is Grace Jansen. I'm a developer advocate at IBM in the UK, and I sort of specialize most of my time within the Java and JVM ecosystem around sort of cloud native technologies. So without further ado, let's get started. So let me just grab the screen. Here we go. So what is cloud native? What does it really mean? So for this, I went and had a look on the internet at some of the sort of most prolific and sort of most common software or companies that offer technology that they claim to be cloud native. People think they have this common understanding of what cloud native sort of really means. And a big part of this seems to be microservices. And this crops up again and again, as we'll see in a minute. But this year in particular, there's been sort of growing over the years, there's been this idea that perhaps microservices aren't necessarily the panacea that they were previously believed to be. So I think it's a good time for us to sit back and think about, does this term really have to include microservices? And what does this term really mean? For some people, they sort of think about things like Spring Boot, for example. But specific technologies like this can't be the definition of cloud native, because others can build cloud native applications that don't rely on, for example, Java. They can build it with JavaScript applications, no problem. So it's not about a specific technology, it's about something else. What is that something else? So taking a look at different companies that sort of sell software that's cloud native, I took a look at 3 different examples on the internet, and we'll take a look at them now. So the first example I came across is VMware. So if you're not familiar with VMware, they're the company behind sort of VMware virtualization, other products like Tanzu Kubernetes platform, and things like Cloud Foundry and Spring Boot. So they have a very long history of being in the cloud native environment. So what did they say? Well, their definition is very interesting. They don't necessarily refer to it as a thing, but rather an approach. So they say it's an approach to building and running applications that exploits the advantages of the cloud computing delivery model. And actually, when you go further down the document that's linked in the slide here, they actually go into sort of different cornerstones that they believe cloud native development needs to incorporate. And that includes DevOps, continuous delivery, containers, and interestingly, microservices. And this is what we're sort of questioning. Is this inclusion of microservices in that cloud native definition essential or explicitly linked with cloud native? Looking at a second example here, we've got Microsoft. So Microsoft have quite a large document that defines cloud native. I just picked out a few key points that they go through in this document. So they sort of, at the beginning of the document, they highlight this sort of cloud native is about speed and agility. But these are more values that we want to achieve through using cloud, but it doesn't really tell us about what cloud native really is. However, I picked out this graphic from that document, and in this graphic, it sort of has similar cornerstones to the VMware definition we just saw. So in there, we've got things like containers again, we've got backing services, so other things that you find available in clouds, automation, which is kind of a combination of what VMware had described as DevOps and continuous delivery, so that automation side, modern design. So in this case, they drill down on the 12-factor application design. And then again, we see microservices. So microservices is cropping up once more. It's included, and you can see here, they also say specifically in their document, cloud native systems embrace microservices. So similarly to VMware, they identify microservices also as a key part of cloud native, which is kind of interesting. The next definition I went to was Red Hat. And they're quite interesting because in their definition, they actually start out with quite a strong statement. So it's the first statement on this slide, which says, cloud native applications are a collection of small, independent, and loosely coupled services. And although they don't necessarily explicitly say microservices, their description seems to really heavily imply this: small, independent, and loosely coupled services. So it's kind of a byline of microservices. But and also in their diagram within this sort of document, they actually have, again, some cornerstones of cloud native. And you can see there in the right-hand side, top right, microservices crops up again. And it's interesting because all of these companies seem to have sort of a similar vein. It's about how you develop and how you deploy microservices. But does it really have to be microservices? Actually, it's interesting because as you go further and further down this Red Hat definition in this document, right at the end, there's this second sentence, and it says, you don't always have to start with microservices to speed up application delivery as part of cloud native apps. And this is sort of the first time I came across a statement or an acknowledgement that microservices didn't necessarily have to always be the answer or have to always be explicitly part of a cloud native application. And it was interesting that they'd sort of, at the very end of their document, come to this conclusion and come to the statement of, you don't have to start with microservices. They're not necessarily always the best solution to get value out of the cloud. Following on from sort of looking at vendor definitions, I then thought, who better to ask for a definition of what cloud native is than the CNCF? So in here, the CNCF's definition talks about sort of containers and service meshes, and also in their microservices. But they say that these exemplify the cloud native approach. What they actually say cloud native is just empowering organizations to build and run scalable applications in modern dynamic environments like the public, private, and hybrid clouds. So they don't necessarily explicitly say, you have to do containers, you have to do service meshes, you have to do microservices. They're just sort of technologies that help to exemplify this approach and can be useful when doing it. So what I took from these definitions is that whilst microservices are a really great way to take advantage of the cloud, along with technologies like containers, etc., there are acknowledgements sort of in this literature that there are other approaches that fit within this cloud native definition, and that it isn't necessarily sort of explicitly necessary to have microservices as the architecture form for your application when you're moving to the cloud. So let's take a look at sort of industry abstraction of sort of different application styles. So here's sort of a spectrum of architectural styles. So we've got sort of finer grain on the right-hand side and sort of less fine on the left-hand side of here. So we've got monoliths, macroservices, microservices, and functions. So cloud native is really about going beyond the core architectural style. It's how you deliver your applications and services. So if we have a look at the right-hand side where we see functions, so functions as an approach to sort of software delivery is absolutely, I think I can arguably say, the most cloud native thing you probably come up with. I say this because you could deploy functions on premise, but most people who deploy functions are deploying it in a cloud native environment because the whole point of functions is that they're able to pay per usage and pay per how many calls to the function are made. And that model doesn't really work if you're running services or servers on premise. You don't get the benefits because you're essentially paying for the hardware already. So functions sort of, although they still run on some sort of hardware that needs to be factored in, sort of in the cloud environment, they factor in as a pay-as-you-go model. And so it's a really sort of, it really takes full advantage of the cloud approach. As we get sort of coarser grained, so heading into microservices, little bit weird to call them coarser grained, but I guess they are compared to functions. We tend to have sort of, this is where the industry has been sort of trying to derive the value of the cloud sort of in this microservices area. So whilst there's been a lot of sort of notable successes of companies utilizing microservices like Spotify and Netflix, and they've gained a lot of value from this approach, it doesn't necessarily work best for everyone. There's a sort of continuity of different architectural styles. And actually, if you read some of the most recent Gartner reports and their hype cycle, microservices and functions are actually in the trough of disillusionment at the moment. And this is backed up by sort of stories of organizations who've tried to do microservices or functions as an architectural style and have unfortunately failed in that. There's a lot of concern right now about whether they are the right approach or whether it's just sort of people trying to copy other organizations when it's not necessarily right for their own. So there is a growing appreciation for other different styles of architecture that can still be useful in cloud native. Some of the early adopters of sort of microservices have been talking about something, a sort of relatively new label for this type of architectural approach, which combines some of those microservices together to be deployed as a number of sort of larger or coarser grained services. And they can be described in a number of ways. One of the most common is this term macroservices. So macroservices, as you can see in the diagram, we've got an example here where you can see sort of we combine some of those microservices together to make these slightly larger macroservices. So you have the services still being broken down into sort of deployable chunks with a set of services within them, but it's importantly not a monolith. So these are more like mini monoliths, but most importantly, they have really well-defined APIs around them, just like microservices do. Depending on your development organization or structure, this can provide a lot of value. And some people may prefer this for their cloud native applications. And then moving to the very left-hand side, we've got the monolith. Now, arguably, true monoliths are very hard to come by. Most of the time, we have examples where people are saying they use a monolith, but it's not a true monolith. They're using, say, external services, for example, or they have broken their app up in a little bit. So it's actually very rare to find a completely true monolith in production. But actually, the difference between the monolith and sort of macroservices, as an example, is that they don't really have these sort of well-defined API boundaries that are present in sort of all of the other architectural styles. However, theoretically, all of these can be built to be cloud native. And this is where it gets interesting. Some may be more obvious than others, like I described with functions and, say, microservices. But importantly, there is nothing intrinsic in any of these architectural styles that means they can't be built or created in a way that can be cloud native. And we'll take a look at how this is. As I said, there's sort of a growing movement away from this sort of fashion trend to just sort of follow this microservice architecture. And if you don't take my word for it, here are some sort of different quotes and tweets, etc., from companies globally, sort of saying the same thing, essentially. So we can see here how there's companies like Uber, for example, that have been vocal advocates of microservice architecture for a number of years, but they're now sort of switching tack, and they're now saying sort of what you build needs to be appropriate for your organization, and that doesn't necessarily always mean microservices. So there's a certain, like they're saying they've moved sort of from microservices to macroservices. And, you know, it might sound great to say, yeah, I've gone to microservices. I've got 600 microservices across 1,200 containers and I do 50 deploys a day. But we're not in the industry to compete based on how many containers we have or how many microservices we built. We're here to deliver information and value and stability to our user base. And microservices don't necessarily work best for all organizations or all applications, just like these companies have been finding. And the surveys also support this. So there's been some interesting studies done recently that suggest that this interest in microservice is actually declining. It's not a massive decline. There is still a huge interest in microservices, and they still are a fantastic architecture style for cloud native. But there is an interesting sort of growth in interest in things like monoliths and macroservices. So essentially, if you take a look on the left-hand side here, we've got the Jakarta EE developer survey, and this is the results from 2020. actually, if you take a look at the 2019, monoliths have grown from 12% to 25%. So you can see that increase in the interest in other styles of architecture. And then on the right-hand side, there's a sort of tweet poll here from my colleague Jamie, who's actually running a workshop tomorrow. So go and check out his Cloud Native workshop tomorrow if you're interested in that. And Jamie asked this poll of sort of, what are you interested in? What architectural styles are you working with? And as we can see here, although microservices is still quite high, actually monoliths and macroservices are both also pretty high up on the list and fairly equal. And in fact, considering macroservices is still a relatively new term, it's great to see that there's some really big interest in it at the moment and people are already working with it. So you can see that there is this trend to look at other architectural styles. And that's because many of the companies who perhaps tried and failed to sort of create a microservice-based application or perhaps transform their previously monolithic to microservices is this term, the distributed monolith. And so what do I mean by the distributed monolith? Well, this is when you have all the negative traits associated with distributed applications and all the downsides of sort of trying to use microservices and not really doing it correctly. So there are downsides to having lots and lots of microservices that you need to be deployed because, you know, if you've got your abstractions wrong or you've got your domain wrong, or perhaps your organization structure isn't set up in a way that allows you to set up microservices independently, your microservices are going to start becoming dependent on each other if you've not sort of clearly separated them, decoupled them, and provided those clear APIs. So you're going to have all the downsides of a monolith and all the downsides of a microservice and none of the upsides of either. So it's really important that we try and essentially avoid this potential pitfall of the distributed monolith. So creating what you think are microservices, but are really just services that happen to be distributed that still rely on each other and could cause potential failures. They aren't decoupled. So you've just created a distributed monolith. So this is the main sort of the most common failure we find when people are trying to move to microservices, and perhaps their application or their organization isn't well set up for this. So we talked about there being sort of a number of factors that can influence sort of the architectural approaches that we choose to use, for example. And here are some examples of those. So the arrows here sort of represent a sliding scale. So these are only tendencies. They're not sort of definitive statements. But these are some of the key terms that we need to be thinking about when we're trying to choose which architectural style will work best for our application. So you can see here we've got functions on the very right-hand side, and then we've got monoliths on the very left-hand side. And your own organization and your own application will probably fall in sort of different areas of these sliding scales for the different factors. So, for example, let's take a look at some of these factors and why they're important. So we've got things like delivery frequency on there. So delivery frequency of a microservice is likely to be higher than a monolith, not guaranteed, but mostly likely. And so, you know, there's benefits of a particular architecture style, but they also require investment. So if you can't invest in, say, frequently delivering microservices, then you might end up sliding slightly to the left-hand side to perhaps macroservices. If you don't invest in, say, automation technology, you're going to struggle to deploy more frequently as well. So it's, you know, what is your organization set up to do? What is the aim of your application? What tools do you have at your disposal to tackle each of these different factors? And this diagram can be really useful to plot your own organization and your own application to see, you know, where do the majority of these factors fall when I'm plotting them for my own application, and thus which architecture style is it probably most suited to. So we've looked at sort of the definitions from the vendors. We've looked at the definition from the CNCF. We've taken a look at how it doesn't necessarily link to an architectural style like microservices. There are many architectural styles that people are now using and a wide spectrum of them. And there's a growing interest in moving away from this sort of trend towards microservice and looking at other styles. And there's some sort of tools that we can use and factors to consider when we're looking at which architectural style is best for us. Where does this leave cloud native? Okay, so the industry has been evolving to a point where there's this great appreciation for different architectural styles, as we saw in the earlier slides, but people are only really focusing on microservices when it comes to cloud native. So let's take a look at sort of the reasons for cloud native and where this leads us for this definition. So why do we even use cloud in the first place? Let's go right back to the beginning. So there are three reasons, I think, three main reasons for investing in cloud. The first of those is cost. So why do we put our applications in the cloud? Well, clouds are essentially an outsourcing activity. So when you've got someone running a data center, you have economies of scale. They're doing it for lots of people, not just your own application. So you should be able to hopefully do this. They should be able to do this cheaper and pass some of those cost savings onto you as the client. So it should be cheaper than perhaps running your own data center. Also, this sort of cloud native infrastructure allows for dynamic flexibility of consuming cloud technologies. So you may be able to scale up or scale down your usage on demand. You don't have to provision enough in your data center for your sort of worst case scenario. Instead, you can just dynamically scale based on your usage. And ultimately, companies need to make money, and they do this by investing proportionally for the opportunity. So cost is a really big factor in this. And with cloud, there are essentially two aspects. You run it on the cloud infrastructure, and you can offset the costs with savings that you'd make compared to running it in your own data center because it's outsourcing. And running it on cloud infrastructure, you can convert some of your large capital expenditures to operational expenditures. So cost is a really big factor in investing in cloud with this sort of outsourcing of costs at a larger scale. The second reason I think is speed. Speed is another really important factor. It can be quite long in terms of cycles for getting new things provisioned if you're running your own data center, so you can support sort of a new application. Whereas when you're running it in cloud native infrastructure, you can provision in the cloud what you need when you need it. As long as you have the permissions and the finance, you can essentially provision as and when you need it. So really quick to spin up, say, new applications or any new sort of resource that you might need. And the last one is fashion. So you might not necessarily think about this as a potential sort of link in cloud native, but fashion is actually really important. So in some respects, we are a fashion industry. We have new technologies and new concepts come along. We get really excited and we want to follow that fashion. We hear about success stories and we sometimes jump on that bandwagon and try to apply these technologies and these concepts without actually fully getting an appreciation of why it perhaps worked for the company X and why it might not work for company Y. So maybe the way they work is different, or maybe the demands of their application are different. So fashion is a factor when we're investing in cloud and can potentially be sort of the downfall of applications when they haven't necessarily investigated whether that's applicable to their own application. So we need to be careful that we're investing for the right reasons. So we've got cost, speed, and fashion. So where does this leave us with cloud native? Let's get back to what this means. Actually, when I was doing my search, I found this definition by Paul Fremantle. And I actually really liked this one. It's from a blog post he wrote over 10 years ago, but I think this phrase really sums up what cloud native is, at least for me. And it says cloud native just means working well in a cloud environment. Yes, that's all your application should be trying to achieve. They should be working well in a cloud environment. And the way you go about doing that might be completely different from application to application. You are designing your application for a specific purpose in a specific way with specific technologies and patterns. And that's absolutely fine. As long as it's working well in a cloud environment, you're doing pretty well at switching to cloud native. So what I did is I took all of the definitions we saw earlier. So I took all the ones from the vendors, from CNCF, and from Paul, and I sort of took out the key words that they were mentioning as part of this cloud native approach, and I put them into a word map. And then I decided I was going to get rid of all the words that focused on the wrong thing. So focusing on specific technologies, for example, or architectural patterns. So I tweaked it up to sort of show what was really important from these definitions when you took out those sort of unimportant or perhaps bias words or technologies or processes. And this is what it resulted in. So these are really the important factors you should be considering when it comes to cloud native. So your cloud native applications, in order to work well, should be observable. They should be scalable. They should be resilient. They should have speed. They should be rapid. They should be loosely coupled. These are the key characteristics we should be seeing from cloud native. And this is what I think cloud native is really all about and what we should be striving towards. Not necessarily making it microservice or using a specific technology or using a specific product, for example. It's just about these factors and enabling them in our own applications. So how do we go about actually realizing these characteristics? So one great sort of technique that you can use that isn't vendor specific or technology specific or even like application architectural style specific is the 12-factor application methodology. So it's about 9 or 10 years old now, but it's still sort of a really great set of factors that you can think about to be able to enable these behaviors and characteristics that we want to see. As I said, it's technology agnostic, so it just talks about the key things you need to do in order to work well on the cloud, not necessarily how you go about actually doing them. So there are lots of different approaches you can take to enable these 12 factors. So let's take a look at an application and how these 12 factors sort of apply to that application. So we're going to take a look at each of the factors and where they come within our own application. So we have a fairly basic sort of architectural diagram of what an application could be like. So we've got things like image repos, artifact repos. We've got our public or our private cloud here. So we've got our app talking to perhaps other apps and other services within that public or private cloud. So other services it might rely on. So let's go through mapping this to the 12 factors first. So let's take a look at what this looks like. So if we lay the 12 factors over this diagram, you can see where each of these comes into play. So you can see that sort of this, where we've got the code base and the build, release, run, and the dev prod parity. We've got the application with its process model and the concurrency where we're scaling out through processes and the fact that they're disposable. We've got how to handle dependencies, for example, and port binding and backing services. We've also got externalized configuration, so configuration that perhaps changes between environments. And we make sure that this is outside of our environment, because then we can inject it in instead of having to rebuild our application at every stage. So we've also got telemetry where we've got logs, which enable us to understand what's going on within our applications, and administration factors, so admin processes, so that we can administer our application through discrete admin tasks. So you can see here how this basic architectural diagram enables you to see where each of these 12 factors comes into play. And actually, if you're interested, there is actually a sort of an extension to this 12-factor app methodology to 15 factors. So if you're interested in that, there is a whole free ebook you can read on how this has been extended and why. We're just going to focus on the 12 factors for now. So as I said before that the 12-factor app methodology is actually a really great way of sort of enabling the behaviors and the characteristics that we saw in that word map that we took from all those definitions of what cloud native really means. But how is this actually the case? How does 12-factor enable this? So we've mapped onto our application the 12 factors. Now let's map on those characteristics. So here are those characteristics. And actually, when we look at the 12 factors and we go back to the qualities of cloud native, we can see where they start to link up. So we've got things like backing services, dependencies, port bindings, and config, and they're all about, they enable us to be loosely coupled, to completely decouple the aspects of our applications, so they're not sort of almost going into this sort of distributed monolithic type scenario, I guess. We've also got things like the process model, which is all about scalability. Logging enables us to have clear observability within our application, to really see what's going on. The code base, having sort of build, release, run, having that dev prod parity is all about being able to rapidly deliver into the cloud in a way that enables us to be sort of resilient as well. That dev prod parity, especially because dev prod parity is really all about enabling our development, our testing, and our production environments to be as similar as possible, so that we're not coming up against potential sort of failure points or challenges or bugs that we didn't see in either of the other environments when we deployed to prod. So enabling that resiliency as well and that robustness. So you can see here where we're enabling a lot of these characteristics. So if you are able to follow the 12-factor application with whatever technologies is best suited to your own application and whatever architectural style is best suited, then you're going to end up creating cloud-native systems that are rapid, scalable, observable, loosely coupled, resilient, robust, that work well in a cloud environment. And that's really what cloud native means. So let's take a look at potential technologies you could be using to enable this. So here is just some sort of fairly generic technologies, a lot of which is open source, that you could be using for each of these different sections within your application. So as I said, these are just examples. You don't necessarily have to use these technologies. As I said, this is technology agnostic. So depending on your application, choose the best technologies for your own scenario and your own application. So we've got things like triggering builds based on sort of Tekton or Travis or Jenkins. We can put our code, for example, in living sort of Git repositories like GitHub or GitLab or perhaps an enterprise Git repo. We've also got to think about testing. So we might have perhaps JUnit testing in there or microshed testing. Actually, if you're interested in microshed testing, I believe that will be part of Jamie's lab tomorrow, his workshop. It's essentially where you're able to test within a container. So it enables you to get that test environment closer to production. And it's a really fantastic open source tool. So check it out if you've not heard about it already. So we can use those. With the dev prod parity factor, it's going to be ideally, perhaps you do some testing in a containerized environment. So that's where it comes in, that dev prod parity. So enabling, with microshed testing, enabling that test environment and that development environment to be as close to production as possible. For your repositories, you might be using perhaps a mirror of Maven Central. For your artifacts and for publishing, you might go to a Docker registry somewhere, or you might be pulling things from Docker Hub, for example. Then when you get into the actual cloud environment, commonly you might be using Kubernetes, for example, although there are other service types, and there may be things that you do in terms of the way you design and deploy your application to suit the different application runtimes. Here in this example, we're just using Kubernetes, and we've got the container, our application in containers here, as you can see. And then lastly, for things like telemetry or monitoring, you might like to use things like Elasticsearch, FluentD, Kibana, and you can have a stack that essentially enables you to create your own customized dashboards, have alerts, and so on, to help you sort of better understand what's really going on within your application and also within the broader system as well. So you can see here that these are just potential technologies you could use, many of which are open source, so check them out if you haven't already. So interestingly, let's take a look at this. This is just a cloud native instantiation. Now the difference between this and this is the title. So we've just said that this is now a cloud native monolith. And interestingly, the technologies don't change. So note that the only thing that's changed on the top of this slide is literally the title. So this is an example of the fact that it doesn't really matter what your application looks like under the covers. That's your choice. Build the type of application that best suits you, that will work well in the cloud. The important thing is actually that when you're building your application, whether it be microservice-based or monolithic or macroservice or function-based, that the actual application logic itself is, and the way you've designed sort of the dev process and the development of your application is cloud native, utilizing tools like this and following the 12-factor application. Okay, so we've looked at monolith. What about microservice? Again, the only thing that's changed in this slide is the title. It looks the same. The qualities are the same. The technologies we're using can also be the same. You know, it's not about, is it based on microservice or is it based on a monolith? It's about utilizing the characteristics we talked about. So being robust, resilient, loosely coupled, scalable, rapid, all of these different characteristics, enabling those characteristics through things like 12-factor app methodology and through open source tools and technologies that you can utilize, like the ones listed on this slide. And it doesn't really matter how you build your application. In fact, if we take a look at perhaps multiple microservices or multiple macroservices, or even this could be multiple monoliths, we're still saying the same thing. We're still seeing these same technologies used, the same sort of diagram you can see here. We're just showing that this could essentially be multiple different either microservices, macroservices, or even monoliths, or even functions working together collaboratively in your application. So hopefully, in summary, if we take a look back over what we've covered throughout this entire presentation, what we've shown is that cloud native is just about working well in the cloud. It's not about a specific technology. It's not about a specific architectural style. It's just about building the right style of application in a cloud native way for your own application. It's about exploiting the cloud delivery model for faster time to value and cost optimizations. And it's about engineering your application regardless of architectural style, for cloud technologies and delivery by utilizing the 12-factor app, by utilizing the right and the most suited open source or proprietary tools and technologies that are best suited to your own application, to be able to create a cloud native application and cloud native sort of system. So microservices are important, and I'm not saying microservices are, why is everyone doing microservices? It's the wrong thing to do. Absolutely not. Microservices can be a fantastic tool to use, but the point I'm trying to make in this presentation is that they aren't universally applicable, and they aren't specifically required for cloud native. So just consider the fact that microservices might be right for your application, but let yourself consider that they might not as well, and that's totally okay too. There's still a way of being cloud native with other architectural styles like macroservices, for example, which are becoming even more popular, or even monoliths. You need to do sort of your due diligence and understand your application's needs, your business needs, and your organizational capabilities in order to choose the right architectural style and the right technologies to be able to build the best cloud native application you can. And I would suggest definitely utilizing the sliding scale diagram if you're unsure about the architectural style that would work best for your own application. So this one here, utilize it, plot your own application and see where you fall on this scale and see which application architecture might be best suited to your specific situation. So I've got some useful resources if you'd like to go about sort of taking a look at this afterwards. So we've got some really great articles written here about sort of how to modernize your Java applications and how to choose things like the right Java runtime. And also we've got some interactive labs here, which Jamie will be using in his workshop tomorrow, if you'd like to take a look at them as well. They're utilizing something called Open Liberty, which is our open source application server. And we've actually created sort of these cloud native guides to take you through technologies that you might want to utilize or tools you might want to use, like microshed testing or Maven or Gradle or Kubernetes, several other different tools. And it's essentially interactive lab online, so you don't have to download anything locally. If you'd like to check that out and have a go at some of these technologies and essentially try before you buy or try before you essentially invest in them. So you can try these out, have a go. Once you've decided your architectural style for your application, see which tools and technologies work best for you. So hopefully I've sort of made you think, hopefully I've made you consider what cloud native really does mean. And through attending the rest of the sessions within this sort of cloud-focused conference, hopefully you'll get an idea of perhaps the architectural style that will best suit and the technologies and tools that you could be utilizing. So thank you very much for listening to me. If you have any questions that I don't answer within this session, please feel free to reach out to me. My Twitter handle is there, and you can reach me anytime on Twitter.
I was on mute. Thank you very much, Grace. Yeah, also don't forget to share on Twitter, as you can try to learn some sticker pack. And also that we have a feedback platform, so we can go to feedback.thecloudfirst.io to give your feedback on that session. It will be very valuable for us and also for the speaker, I know that. Grace, we have a few questions if you want, as we still have some few minutes.
Yep.
So first question is, when microservices are more tightly coupled, does it lend itself to a microservice approach?
Absolutely, yeah, I would say so. So when you've got microservices that are really tightly coupled, it's perhaps sort of an indicator or perhaps just a warning bell to say, this might be better suited as a single sort of macroservice, slightly bigger macroservice with a wider context. And that way you're enabling yourself to make sure that every single microservice is decoupled, because if you, as I said with the distributed monolith, once you start having services that are tightly coupled that you're trying to distribute, you're going to start getting those negative sort of connotations with the distributed monolith. You're going to be getting those, you're not going to be getting the advantages of microservices or macroservices. So yeah, I would definitely say, look at whether your services are tightly coupled. If they are, perhaps consider macroservices. If they're not, then you can go down the route of microservices, but carefully consider that when you're trying to break down your application.
Okay, great. So we have another question. Is it valid to consider creating a monolith for the cloud from scratch?
This is a great question. So this is an interesting one because people sort of, when they're building applications from scratch, for example, there's this sort of negative view of going straight for a monolith. If your application is small and you don't need to break it up into microservices or even macro services, then a monolith is perfectly fine. But also, if it's quicker for you to develop and deploy your application as a sort of monolith and then break it down into microservices, you don't have to take that all at once. So you could, develop your application as a monolith, maybe deploy it, see how it's working, and then afterwards look at where the different contexts are for the different microservices that you could break it down into. You don't have to get overwhelmed at this thought of, but I need to make microservices from the get-go. That's totally not the case. Go with whatever works best for your current situation, and you can always change it afterwards. You can always break it down further, for example. So I would say, for sure, even if you're building an application from scratch, it doesn't matter what kind of architectural style you're using. Use whatever works best for you at the time.
Yeah, it's better to iterate than to overcomplicate the whole thing from the beginning.
Exactly, right? And just get stuck. So.
Yeah. Okay, great. Is microservices another name for distributed monoliths? If not, how do we avoid distributed monoliths?
Okay, so they're not the same. They can become the same though, so you have to be careful of that. Just like microservices, macroservices can potentially become distributed monoliths, and that's because this term distributed monoliths is essentially the way that we're describing, the downsides of a monolith. So having tight coupling together, having dependency, but also having to deal with this distributed nature of macroservices and monoliths. And so they're not the same thing, but they can become it if you're not careful. The way to avoid it is by making sure that you have completely decoupled the different components of your application, whether that be a microservice or a macro service, and ensuring that you've got really well-defined APIs for each of those. So that's sort of the main way to avoid it. There is lots of helpful tips online of people who have perhaps gone down the microservices or the macroservices route and ended up with a distributed monolith. They've got plenty of helpful tips for you to help avoid that situation.
Okay, great. And last question, I think. What top tip would you give for architects and developers that are working with architecture type of use? And for which architecture type of use?
Yeah, sure. So my top tip would be, don't let fashion dictate your choices. Don't seriously, it might look amazing to see these big organizations. And remember, they are big organizations like Spotify and Netflix doing really well and having all this success with microservices. Most of the time, these organizations are much bigger than most other people's organizations. They've got far more resource to put into this sort of architectural design and far more they've got usually a longer experience within the sort of sector or within what they're doing. I would say, look at them. You can idolize them, but don't let it dictate your choice. Your choice should be based on, what resources do you have available? What's your organizational structure? What are the needs of your business and your application? And you should be choosing your applicational and your architectural style based on that. And as I said, utilize the sliding diagram if that helps you. And there are other factors that you can add to that. So if you think of a factor that's not on the diagram, add that factor and use the slider to figure out where you fit on it. So definitely, try not to let the trends and the fashions and these sort of buzzwords dictate or influence what you're doing. Try and keep to those factors and what's best for your own application and scenario.
Yeah, that's true. As a developer,
it can be hard.
You always need to deal with the hype. When you
Absolutely,
see
that
something
hype cycle,
new and exciting, you want to try it. Yeah, but you have to.
And I would say, there's no harm in trying. There's absolutely no harm in trying, but try in a test environment. Please don't just shove it into your production and expect it to work.
Yeah. Okay. So thank you very much, Grace. As you said in your session, during your session, you talk about a workshop give tomorrow by Jamie. Yeah, by Jamie. So be sure to take a look at the workshop. You can. There's also some tickets open, so you can still book your seat. It's free. So take a look at the website. Be sure to check that. Places are limited, so don't wait too much. And okay, so we will take a 5-minute break. Thank you, Grace. So we'll take a 5-minute break before the next session, and we'll continue for that day of cloud greatness. Thank you, guys.
Thank you. Bye. Bye.
Hi everyone, welcome back. For that next session, we'll continue talking about architecture and make a focus on reactive architectures and how we can rethink them and use them on cloud-native solutions. For that talk, we are really proud to have here David Leitner, live from Vienna, Austria, because it's a European conference, for that very first edition of the TheCloudFirst. Welcome, David.
Hi.
How are you?
I'm perfect. I'm fully motivated after this fantastic music. Yeah.
That's good. Okay, David. So the stage is all yours.
Cool. Hope you can hear and see me properly. We will talk about reactive architectures today. So first of all, whoever heard about the term in general? I'm not sure if we can do it with the comment function. So usually it's quite nice to understand a little bit the audience, but in remote everything is a little bit different. So I try to do the talk in a way that I give an introduction to the most important aspects of what is reactive in general, what are reactive architectures, what are the principles, and what should we rethink in some situations. So this will give us a short overview about the topics I will cover in this talk. But first things first, my name is David Leitner, as mentioned already. I'm from Vienna. I'm working there as a coding architect for a company called Square Solutions. So the job title is intentional. So I do a lot of architecture, but I really try to keep my coding skills up to date and do a lot of programming with the teams itself. So do not get distract, so to say, from the hands-on things, and to really discuss the architectures then in detail and help also implementing them. So what is reactive actually? What is this all about? It seems to be the latest and coolest and greatest new buzzword in town. But actually, we see a lot of different tools and technologies jumping on this bandwagon of building reactive systems, of supporting reactive paradigm and supporting the way of coding in a reactive way. So we have here just 3 icons I just randomly took from the internet. The first one is React. So obviously based on the name, it has something to do with reactive, right? We have the project Reactor from Spring, which was introduced to enable Spring to build reactive systems by using the Spring ecosystem. And then we have the icon of the reactive extensions, which enable programming language which don't have native support for reactive tool sets to build or to programming in a reactive way. So with all this said, programming in a reactive way or building system in a reactive way is nothing else than designing and programming upon asynchronous data streams. So to understand this a little bit in detail, we need to first understand what are data streams. And this maybe sounds obvious to most of you, but I still see a lot of people which do not fully understand the concept of streams, the power of streams, and where they're actually coming from. And if we take a look at the very simple example, I always bring this also at university when I teach my students what does actually reactive architectures and systems look like, and the core fundamental ingredient for all this is streams, then I always explain it in a very simple way so that I understand, so I think that everybody can easily follow and understand it. So we have 2 axes, we have space and time, and if you think very abstract about programming, then you have different ways to store data. You have different data container types, and the simplest one is a value, right? It has a getter and a setter. This shouldn't be that much of an using for most of you, I hope, yeah. And if you move right into space, you usually have something which is called a collection, which is an iterator and a generator. So it stores not only one value, as the value does, it stores multiple values. So we have collection support in actually all programming languages we see this day natively. But if we move up in time, so if we move from a synchronous way of thinking about data collection to an asynchronous way, we have on the left-hand side a promise. And the promise is maybe not so familiar to everyone anymore, but the promise is actually something that, as the name already tells us, that promises to bring us some value in the future. A single value which will not be provided synchronously, like by a getter or a setter, but it will be resolved somewhere in the future. And if we now complete this picture and say, okay, something which is plural, which has multiple values, but is not synchronous like in collection, is asynchronous like a promise, it becomes quite naturally where the stream is located in, right? And the stream is nothing else than an asynchronous data container which can emit data over time, where we never know when will it be finished. We never know how many values do we get. We never know when will we get those values. But ultimately, we will get them over time. And in comparison, we get multiple values instead of where in the promise we get just one. And in comparison to collections, we will get them asynchronous in comparison to get them in a synchronous way. And for those who are not so familiar with reactive extension and reactive programming, that's actually what reactive extension is all about, right? Reactive extensions bring these reactive data containers into programming languages which don't have native support for this way of thinking for this kind of asynchronous data containers like streams and promises. So we see this, for example, in IXJava now being used quite often in new customer projects. Of course, IXJS natively supported by Angular, used quite often as one of the reactive extensions for JavaScript. But what does this all mean now? Yeah, now you understand what a stream is. Now you understood, okay, reactive programming is all about streams, but what does this really mean? How does such a program look like, right? And again, I have a very simple example, and I think it helps a lot in understanding what reactive programming is all about. So if you think of this code snippet here, 3 lines, counter is 1, doubled is counter multiplied by 2, and then we set the counter to 3. Now the question is, what is the value of doubled, right? Well, unfortunately, or I wouldn't say unfortunately, but the value of doubled is still 2, even if we set the counter to 3. So if we want to update doubled, we need to reevaluate it again. And that's a big criticism reactive programmers always bring when we talk about traditional programming languages, where they say the relation between counter and double in this situation is very implicit. It's only available in the mind of the programmers. And the programming language should support us to make this bounding between doubled and counter more explicit. And there are very theoretical white papers and blog posts about this topic where people often talk about the destiny operator, where they say, okay, let's introduce a new operator which works in a way that we, for example, have here an arrow, so that doubled will be directly bound to counter, and whenever counter changes, this will have a direct impact on the value of doubled. So in a more explainable way, this all works with streams. So if we think about this example, what is actually happening under the hood is that counter is not a single value anymore. Counter is a string, and it has an initial value which is 1. And what doubled is actually a derived stream. So we take the existing stream and put a stream operation on it, in our case map. So we take a stream, map it, and get another stream. So in our case, we just multiply all the values of the existing stream by 2 and get another stream which then contains the value 2. And if we now update the counter, all we do is actually we take a new value and put it into the counter stream, and this will automatically also update the doubled stream by introducing a new value there. And if we assert this now, okay, doubled will be 6. So this is again very theoretical. Let's take a look how this is actually implemented. So as I said, reactive extensions are very popular, especially in the JavaScript world. We see them, of course, in Angular as they come natively with them, but also more and more in React and Vue. And in a reactive extension way, this would look like this. We would have a new stream, new behavior subjects, kind of a special stream you can think of with an initial value of 1. And then we have doubled, which is just a transformed stream from the counter stream where we apply the map operator, the stream operator, and say, okay, each value, please multiply by 2. And if we change the counter, we emit a new value. And actually, in this situation, it's 3. And then we know that doubled will be 6, even if we do not actively reevaluate this, this new stream. And more modern programming frameworks or more modern web frameworks especially bring the idea of the very theoretical destiny operator I showed you before very close to how it was actually showed in white papers a few decades ago already. Where Svelte, for example, uses this post prefix operator where we can put a $sign in front of a variable, and based on this it will be a reactive variable. Based on this it will be automatically bound to counter, and whenever counter changes, double changes. So in a nutshell, what we do with reactive programming, we make it a shift to an asynchronous streams that propagate change. So whenever we do something, we actually propagate change to stream, and whoever is interested in the stream starts to observe this change. And that's a big difference to imperative programming, where statements were used to change a program state. So we triggered from a caller directly a receiver. So we decoupled in a reactive way the caller from the receiver by introducing the concept of streams. And we also changed the way how we communicate between those different actors. So we kind of move from a pull-based to a push-based paradigm, but more on this later. Let's take a concrete example. Let's check something out like an email client, yet another email service. You can think of it like a Gmail or Outlook client on web. And we see here a lot of information. First of all, we see how many new emails we have. Then we see a list of emails, and ultimately we see how many emails we in general have. And in a traditional way, you would think of this, that you say, okay, if I want to reload my emails, I have a reload button. I click on this reload button. This goes to a controller. This controller actually holds the current list of emails that are available. We will go then to an HTTP client and say, okay, give me a REST client. Based on the REST client, I receive the new list of emails. We see, okay, there's a new email available, obviously. We go to the UI elements that need to be re-rendered. We say, okay, here we would have now 2 new emails. Here we would have now an additional email in the list. And here we would now show 5 emails. This is how in a traditional imperative way you would find a programmable solution for the given task at hand. If you think this problem, which is still very simple, in a reactive way, then it would look a little bit different. First of all, I guess you wouldn't have a reload button because you don't need it. You would have a stream, and the stream would contain all the emails which are currently available in the system for the specific user. And what you do then is that all the UI elements that are interested in emails, however they are interested in, would just subscribe to this stream. So in our situation, the count of all the emails just says, hey, give me the email addresses, and then applies a stream operation on top of it and says, take the stream, transform it, count it for me, count all the elements in there, and we will have the number 4, hopefully. And then we move on and say, okay, cool. I do the same thing for listing all the emails. All I do is I collect all the emails within the stream. I map them so that we have a single line for each email, and I will just render them. And for the new email, I do the same thing. I go to the stream and say, hey, give me all the emails, or filter all the emails which are new, and then count them again. And if we get a new email, we would do it differently. We wouldn't ask directly, hey, please give me all the new emails we have, pull for them. We would get them pushed. We would use something like a WebSocket client that pushes us new emails once available. So once a new email is available, this will go into the stream, and all the UI elements who subscribe to the stream will be automatically updated, so to say. So again, we move from a pull-based design to an asynchronous push-based design. That's the fundamental idea of reactive programming. So I hope, even if it was a very short intro, that most of you understood the idea of reactive programming. But you will now say, okay, I'm not here to understand reactive programming because the title talks about reactive architectures. So let's start to talk about reactive architectures. Well, I will talk about it in a minute, but as usually, the concepts don't change. And that's the same thing for reactive programming and reactive architectures. where people always ask, where does reactive programming end, where the reactive architecture starts? Do we need both? Do we need reactive architectures if we do reactive programming, and so on and so forth? But in a nutshell, all we do is that we move the ideas of reactive programming onto a higher level of architecture. But the idea to build up systems with streams is totally the same. It looks totally different, as we just show on a software design level, as it would then look later on a software architecture level. So what we do is we take the concepts of reactive programming and move them up to a system architecture and hope all for the best that this actually works. But if we talk about reactive architectures, we also need to touch point the reactive manifesto, as it's a very important kind of concept in the world of reactive systems. So the reactive manifesto was written by a bunch of people, and usually it confuses people quite a lot, because if you scroll down, you come to this picture and people don't understand it usually. So it's very hard to grasp for them. And I try always to find a way to make it easier to understand, because it's a very essential part of reactive architectures from my point of view. But if we talk about architectures, let's really talk about architecture first. Yeah. Because we are experts in software engineering, don't have a common understanding about terminology, don't even, sometimes talk about the same thing if we use the same words. And this question, what architecture actually means or what architecture actually is, I guess is age-old as software architecture itself. And we all know the common definition from Parent Wolf that says the main subsystem in the systems and how they are connected together. Ralph Johnson then later said, okay, the shared understanding of senior people within a project, because he understood that, software architecture is not so much a technical discipline, it's often more a social discipline. And then Martin Fowler with his famous, the things that are hard to change, whatever they are. So I have my own definition of what an architecture is. And for me, it's very closely bound to the idea of non-functional requirements. And for me, the only right definition what non-functional requirements are actually is written down here. These are those requirements which make your software non-functional if you do not consider them. So I like the trend that people start to phrase non-functional requirements actually essential requirements, because they say they are essential for our software to work. So we should also treat them like this. And we all know the non-functional requirements. They're sometimes also called the illities of software, because they all end with illity, like maintainability, accessibility, adaptability, extendability, usability, scalability, all these illities of software. And what software architecture actually is that we take all these non-functional requirements and business requirements and decide if they are important for our system. Is availability important for our system? Yes, it is maybe. Okay, then let's move the dot to the right-hand side. But we always need to understand that this will have an impact on other non-functional requirements, because we all know the cup theory. If we move the availability to the right-hand side, this will automatically lead to a system which will not have that high consistency as if a system wouldn't be that highly available. And the same is true for many other non-functional requirements. Usability usually has an impact on security, and so on and so forth. So we just actually, as architects, move the dots from the left-hand side to the right-hand side and try to find the right trade-off. So architecture is actually a trade-off of selecting the right non-functional requirements that fulfill our needs best. And this trade-off changed a lot over the last years. So if we look back to 2010, the internet had about 1.4 billion users. In 2020, the internet has 4.7 billion users. Facebook itself has 2.8 billion users. YouTube has 2.1 billion users. So a single website may have twice as much traffic as the entire internet did a decade ago. And that's amazing. Of course, this has a big impact on the non-functional requirements we have on our software architectures, on our software systems these days. And this brings us back to the Reactive Manifesto, because the Reactive Manifesto also starts with the non-functional requirements. They say, we provide a couple of non-functional requirements you will get if you follow the idea of reactive systems. First of all, you will be easily to scale. Second, you will be very responsive, so you will always be able to respond to your users, to your customers. And last but not least, you will be very easily to extend. So if these non-functional requirements are important for our system, maybe reactive architectures are a good fit for our problem at hand. But this needs to be decided then based on the given context, of course. But what's interesting is that people found out if a system needs to be responsive, actually it needs to make or have two things. It needs to be elastic, so in a way that we can scale out the system instead of just scaling up the system. And it needs to be resilient, which means that if part of the system doesn't properly work, the overall system still kind of responds. And what's even more interesting is that people found out, okay, those two things which support our system in being responsive are actually driven by the central idea of building our system in a message-driven way. So if we build our system in a message-driven way, this will automatically lead to the fact that we build elastic and resilient systems, and this will pay into the idea of building a responsive system. But let's go a little bit into detail to make this a little bit more understandable what I actually mean by this, or what the reactive manifesto actually means by this. Yeah. So let's touch point elastic first. How do we make a system more elastic by going into the message-driven integration patterns? So let's assume a simple example, microservice A, microservice B. Microservice A is talking to microservice B. Very simple. I guess you see this in reality every day, an application architecture like this. But for the current use case at hand, it's enough. Yeah? So if we have microservice A talking to microservice B, and we want to scale out because we want to be more elastic so that we can always respond to, for example, higher demand of user requests. So we spin up a second instance. Then we have the problem that microservice A suddenly has to decide, okay, do I go to instance A? Do I go to instance B? Do we have kind of a locator in between or load balancer? Well, if we would go with a message-driven integration and introduce a stream or a message queue in between, this problem wouldn't even exist because microservice A would say, hey, here's a message, put it to the queue, and whoever is interested will start to subscribe to this queue and will start to operate on this message. So we will naturally support the fact that we can elastic scale out our system architecture. If we talk about the resilience of a system, then things look very similar. If we again talk from microservice A to microservice B, and maybe microservice B has high latency, maybe microservice B doesn't have its best day today, maybe it's not motivated, whatever. If this microservice B doesn't respond, or it does take a lot of time to respond, this will also block our microservice A as we talk synchronously between microservice A and microservice B. And once it's responding, then ultimately we can send new requests. But in the meantime, the whole chain, the whole waterfall, of course, so to say, is blocked. And again, we can solve this problem easily by just introducing a queue or a stream in between, by just introducing a message-driven concept for integrating those two systems. Because microservice A will send a message, and then it's done. It can operate on new things, it can do other things, because it stored the message in the stream, and it knows that at some point in time somebody will pick it up and can send additional and further messages, even if the previous message wasn't processed successfully yet. And microservice B will then pick up a message, will send it back, and microservice A will at some point in time be able to consume it. And we can solve both issues, because maybe if we really have such a high latency in our microservice B, it would make sense to scale it out, right? To have multiple instances. And this idea of being elastic and resilient by just applying a message-driven integration pattern or a message-driven integration style between our services is quite powerful. And it supports basically two things: back pressure. So as I said, if a consumer is slower than a provider in consuming data, then we need somebody in between who takes care that the provider will not be blocked all the time. And this is what we tend to call back pressure support. And on the other hand, by decoupling the provider with the consumer by a queue or a stream, we achieve location transparency. So the provider doesn't need to know anymore who is the consumer. And this leads us to the fact that we can easily scale out the customers. So again, the same sentence as we've seen for programming is true for reactive architectures. We move from synchronous pull-based architectures to asynchronous push-based architectures. So let's take a look at the history of microservices, so to say. In the beginning, we had a couple of microservices, usually a web application, Angular, React, Vue.js, Svelte, whatever, framework of the month, what you prefer. Yeah, it doesn't really matter. And this web application goes to microservice A and says, hey, give me some data. This one goes to microservice B, this one goes to microservice C, and at some point in time, microservice C returns data to microservice B, and all this goes back to the web application. As mentioned, if the latency of microservice C is very high, this will have an impact on the whole chain of requests, which we usually would like to avoid. But this was kind of the first generation of microservices where we see a lot of synchronous integration without back pressure support. So people started to want to solve this issue and started to isolate these bottlenecks by queues. So we introduced queues and said, okay, we can kind of isolate the bottlenecks by integrating them in an asynchronous manner by introducing queues. And if the answer takes long, it will not have an impact on the rest of the system, and the rest of the system will not be blocked. This was kind of the second generation where we started to use partially asynchronous integration with queues, and people realized, okay, first of all, there are interesting technologies to do this, like Active and QRabbit and QApache Qubit. We see a lot in this kind of second generation of microservices. But people started to realize, okay, we need more and more queues. So we started to build queues for each microservice integration, so for each communication between the microservices. And people started to say, okay, let's maybe take a different approach. Let's say we have a web application. This is talking to a backend for frontend or some kind of facade microservice. And this ultimately talks to a stream. And it just pushes the message from the web application into a stream. And then we have a couple of microservices. And those microservices subscribe to the stream. They are interested in the stream. So they say, give me the information, give me the messages which I want to know. So for example, if a new payment is triggered, microservice A starts to subscribe to this payment event. And if the payment looks valid, it writes back, okay, this is a valid payment, we can execute it. And the microservice B, who is responsible for executing payments, maybe says, okay, cool, I will execute the payment, and it will send back if the execution was successful. Okay, a successful execution message. And microservice C, who maybe just does some analytics, says, okay, cool, I will pick this up. I will update the analytics in the background and will send back, okay, the payment was not fully executed. Everything was successful, and we'll write it back, so to say, to the web application, and it will show, okay, the payment was done. So we moved from this classical synchronous integrated microservice to fully asynchronous and stream-centric microservice architectures. And we realized actually that we have different technologies to do this. We have Apache Kafka, we have Pulsar in comparison to AMQP or RabbitMQ. They allow us to persist state, at least for a while. And this led to the idea of people to say, okay, if we can persist state actually on the stream, right, then all the events actually kind of represent the current system state, which is a kind of interesting idea, which led us to the idea that we say, okay, let's say we have the stream of transactions, and it makes sense, David, 100 euros, makes sense, Maria, 70 euros, and David sends Maria 25 euros. Then if we take all these events and kind of combine them, we actually have the system state, which is saying that David has a balance of 75 euros, Max has a balance of minus 170 euros, and Maria has a balance of 95 euros. And this is what we tend to call event sourcing. And this idea of event sourcing is not new. If you ever worked with a bank, you know that all banks are built up on the idea of event sourcing, because if you would go to your bank and say, hey, hello, I'm David, my balance is wrong, I don't have 75 euros, I think I should have 85 euros on my account, and they will tell you, or if they will tell you, okay, we have in our database a flag which says, or a column which says that you have 75 euros, yeah, deal with it, then you wouldn't be satisfied. You would expect that they tell you, hey, David, you got 70 euros from Max, and then you send 25 euros to Maria. That means that you have 75 euros on your account. Sounds Sounds valid, doesn't it? Then you would maybe accept it, or I guess you would have to accept it, right? Because many domains like financial or insurance companies work anyway in their core domain or in their logical existence in an event-sourced approach. So we have this 100% reliable audit log by introducing event sourcing, and this could be a very interesting approach for many situations or for many business cases. So what we actually do is we say, okay, we move the persistence from our microservices to our stream, and we tend to call them the stream, not stream anymore, but event store. But it doesn't really matter. It's just a stream which persists events over a very long time. And with this idea of having microservices which don't have persistence on their own anymore, we usually say, okay, we don't need microservices anymore. We can go with simple stateless functions, which we tend to call lambdas these days. So we moved from stateful synchronous microservices to asynchronous stateless lambda functions. And this is, so to say, the current or last generation of event-sourced microservices with function as a service. But it doesn't really matter if we think of a stream now with a stateful microservice, or if we think of stateless lambda functions with a stateful event store in the center. That's not a big difference. But what we can see here is that we are happy to stream here between all our backend systems. But we see here something on the web channel side where we have HTTP, and HTTP is a great piece of technology, but from this perspective, it sucks because it's synchronous, right? It is based on the request response idea. You send a request and get back a response. It's very hard with classical HTTP to send from a backend to the client and say, hey, here's a data changed. You didn't ask, but I tell you, hey, it changed. And of course, with WebSockets, we got possibilities to also support kind of streaming there. And a very popular technology, that's why I explain it now so prominent in these areas, of course, GraphQL. I guess most of you know GraphQL. Mainly it's seen as an advantage in comparison to REST because it supports consumer-driven APIs. So in GraphQL, you can describe exactly which kind of data you expect from a server. You can say, I need this and that fields and those relations. And this is usually seen as the big advantage of GraphQL. Of course, it's a big advantage. It can be a big advantage, but you can also achieve this by building consumer-centric backend for frontends. That's okay. I don't say that this is not a big enough advantage, but GraphQL. But I don't see the ratio for exactly going for only this feature to GraphQL. Another advantage we often hear is native schema support. Again, it's nice, cool, great feature from GraphQL, but we also have it with Swagger in REST. But what really makes GraphQL to a game changer from my perspective that it supports streaming natively. So you have three things in GraphQL, right? You have a query to ask for data like a get in REST. You have mutations to update, delete, and create data like put, post, and delete in REST. And then you have a third thing, you have a subscription. And this one looks exactly like the query, but instead of being a find and forget thing, you subscribe to a specific resource. And whenever this resource changes on the server, you will get a notification by the GraphQL server, so to say, that some of the resource information you're subscribing to has changed, and you as a UI can then react on this kind of change. So we support naturally in GraphQL to not only doing classical synchronous queries, but to also go in an asynchronous subscription way where we will always get notification whenever one of those to-dos in this example, for example, changed. And this is fantastic because if we now introduce GraphQL here instead of our classical synchronous web service, we have end-to-end streaming. So we can really stream from end to end. So we really move from a fully pull-based architecture in the traditional way to a fully end-to-end push-based architecture. And maybe it's not fully clear what big advantages this brings. So I try to come up with two real-world use cases which make a little bit clearer why push-based architectures can be such an interesting or such a powerful tool for system architectures these days. So due to COVID-19, the business of many companies or many domains or business areas has changed. I think it's not a promise that, I guess, COVID-19 was the biggest driver for digitalization in the human history, right? So especially for insurance companies, it got a little bit more different, because usually you go to your insurance agent and ask him if you need a new insurance, and go to the office and do it there. But due to COVID, this was kind of hard these days. So of course, insurance companies try to find new ways to solve these issues, and we did a very interesting kind of project where we actually really could utilize the full power of reactive systems in a way that we said, okay, let's say we have an insurance agent. Here's a laptop, here's a PC, and on this PC he has his software running, where you, for example, call and say, hey, I need an insurance from a new car. So I give you the car brand, I give you the building year, I give you the car model, and based on this information, you are able to calculate the insurance rate. And we build this in a reactive manner. So we build it kind of like this, with a GraphQL server, with an event store, and with Lambda functions. So whenever the agent updates something here, it will actually trigger an event. It will send a mutation to the GraphQL server, and here it will then be persisted that currently for user XYZ, the car brand, the build year, and the car model is selected as it was selected. But this is not really a big change. This is not a big achievement. But what is a big achievement is that, on the other hand, the client was able to sit with his iPad or with his phone and say, okay, I would like to see what you're currently doing. Yeah, I can talk to you, but I would also like to see what you're doing, and I would like to verify if the things you're typing in are correct or are actually fitting the expectations I have. So the customer would also have a web application, which is again connected via a GraphQL client, via a GraphQL server to our event store. And whenever the agent changes something here, this will automatically trigger the event on the event store. This will maybe trigger some of the backend logic to update it to another event. And ultimately, the subscription of the GraphQL will be triggered and will send an update to the customer without any F5 or refresh button or whatever, right? Because the customer will always see exactly the state in real time as the agent sees it. And afterwards, the customer can say, yeah, that sounds good. What you selected here, this is correct. Let's jump on to the next step. And the next step, the agent talks about coverage. So also the client will see the coverage. And you can, for example, move the coverage, and the client says, hey, let's move it from 70% coverage to full coverage. What would it cost? So that the agent can easily move here the slider to the right-hand side, and it will actually then increase the coverage of the system or the coverage of the current insurance for this given car. And automatically, the customer would see, okay, now the rate has changed from 200 to 250. And if it's still fine, yeah, then let's sign it digital. Let's close the deal. Let's get it done. And these are really interesting use cases for real-time integration, for real-time synchronization, which customers currently or very often expect from us these days. We also see this in the financial industry, where people are coming to the bank office and say, hey, cool, I need a loan. Okay, bank clerk is working on kind of on an internal machine and gives the customer an iPad and says, hey, check what I'm doing here. If we increase the loan rate, or if we increase the time in which you pay back, this will have this or that impact. And you get directly live feedback for what the customer actually expects and what he actually wants. So this idea of supporting real-time synchronization between multiple channels without any kind of polling or refreshing, by just moving from pull-based to push-based, is a fantastic concept, which can help us in many situations if we need a system that acts in a real-time manner. Another example I brought you, resilient banking with projections. Well, this sounds a little bit fuzzy in the beginning. Maybe it's not fully clear what I mean with this, but I will explain here in a second. So I think 5 or 6 or 7, even 7 years ago, we did a research, or we worked together with a bank which did a research on what is actually the mobile banking usage. And this was a really interesting research, because we found out that 93% of all the users are actually just showing the balance and showing the latest transactions. That's what they do. So maybe if you remember how often you opened your mobile banking app, just check the balance, check the last transaction, everything was okay, and you closed it again, then this will maybe sound familiar. So in 93% of all use cases, the user just wants to have this functionality of his mobile banking app. 3% are to initiate a new payment, and all the other 4% are all the fantastic other features we built over years into our mobile banking apps, which are actually used in 4% of all the use cases, right? So having the possibility to show transactions and the current balance is key. It's key to have a good customer experience, and the user always expects to have this working. So even if maybe payment doesn't work, he still wants to see the balance. He wants to see the latest transaction. So we need high resilience in the system, as we've seen in the Reactive Manifesto, that message-driven architecture supports us in doing so. But how do we really do this? Well, again, let's assume we have a web banking channel for our web banking users, and we have kind of the same architecture with the GraphQL server streaming and microservices and beyond. And whenever, for example, a new transaction is triggered, it can be triggered by multiple systems. It can be triggered by a core banking system. It can be triggered by a different channel. Whoever creates a new transaction, it will end up in the stream. And our GraphQL server subscribes to the stream. And what our GraphQL server has then in addition, it has a so-called projection. And what are projections? Projections are actually very simple things. They are read models for a specific client. So what the GraphQL server does, it says, okay, I'm interested in transactions because my client is interested in transactions. And you know, transactions are usually very big business objects in the concept of a bank. So we just say, okay, we take this data we need for our web use case and store it. So maybe we just need the date, the description, the receiver, the sender, and the amount. So all the other fields we throw away, and we store this stuff in our projection for the web banking. And whenever the web banking asks for data, or when it gets anyway pushed by subscription for new updates, it goes to the projections and fetches the data always only from the projection. So we send data by subscribing to the central state, hydrating our projection, which means actually filling the projection with data, and the client then only reads from those projections. So there's this age-old saying in software engineering that there are only two core issues in computer science: cache invalidation and naming things. I can tell you that's wrong. There are only two core issues in computer science: unused potential of reactive systems, and naming things still exists, of course. But if you go into this direction, you will never have a problem with cache invalidation, because the projection will always be updated based on the transactions which will land in the stream, and you will never have to go into this pool-based cache invalidation, because whenever you read something from this cache, you will know that it will be updated, because every update will be pushed to your projection. And one tool that's very interesting, and one technology to just also mention the technology here, is Hasura, which is kind of a GraphQL server with a database included. So it's a perfect fit for going into this projection architectures. And before somebody asks, of course, yeah, we still have the off by one error by side of naming things and unused potential of reactive systems. Yeah. But if we take this idea of projections a little bit further and say, okay, we also have a mobile client channel now who has its own projection, and maybe it is still interested in transactions, but maybe not in the description anymore, or maybe not in the detailed description anymore. So it will maybe build the projection, the read model, in a different way. So it always builds it in a way how the client expects it. And I guess the mobile client will expect transaction in another visualization than the web banking usually does. So we are very fast in reading data from our projection, because they're already provided in a very consumer-driven way, in a way how our consumers, our channels actually expect them. But in addition to this, we have a nice decoupling of our system, because actually for reading transactions, as we've seen in the use case before, we just need to go to projections. We just need to go to the projections for our specific channel, and we could burn down the whole backend and still we would be able to fulfill 93% of the use cases a user expects from its mobile banking to show balances and latest transactions. And this goes directly back to the core idea of the Reactive Manifesto, where we said it supports us in building resilient and elastic systems by just following this idea of message-driven systems in most situations by introducing streams into your software architecture.
David, sorry to interrupt. We are running out of time. I don't know.
2 minutes left.
Close to the conclusion. Okay, right.
Yeah, I'm nearly done. Thanks a lot. Yeah. So this stuff is cool. Yeah. honestly said. But of course, as always, keep in mind that you think twice. If reactive architectures really fit your problem at hand, aka your non-functional requirements. Because what is true for architectural styles in general is, of course, also true for reactive architectures. Because architectural styles always buy you options. And reactive architectures buy you mainly resilience, real-time capabilities, elasticity, and extendability. And the important part is here that they really buy you those things. That's the important word here. They buy you options. And you always pay them by complexity. You don't pay them by money, but you pay them by complexity. And that's important to understand. So maybe, just in case, but maybe you should start with an asynchronous integration and then move on to a reactive system whenever it's needed. I hope this was useful. Thanks a lot. And if any questions pop up afterwards, I think we ran out of time now. Feel free to contact me via Twitter or via email.
There's your Twitter handle on the screen. So yeah, feel free to ask your question. Thank you very much, David. That was really, really great. Really crystal clear. Actually, we had some questions, but we'll send it to you by Twitter or something.
Yeah, perfect. Sorry.
Thank you
for taking
more time. No
yeah.
problem. That's okay. We have a pretty busy agenda, so that's why. Thank you very much, David. So everyone, just a 5-minute break, and we come back with the next talk where we will talk about it was about data warehouse solutions on the cloud and the new battle that is happening on that new battlefield. So be sure to be there on 5 minutes. Thank you, David.
Sure. Thanks a lot for having me. One last thing, maybe, for those who are interested in those topics, as you do with this conference now, we also decided to move a couple of our trainings online and make them available for free. So one which could be interested in this audience is, of course, Kafka, where we will go into detail about what I discussed now on a very abstract level in the usage of Kafka. So if anybody is happy to join us there, I mean, it's mainly driven by the Viennese community, but we will do it now online and it will be held in English. So feel free to jump in. It's free and it will give you a good introduction on Kafka, on the concepts we've seen now in a technology agnostic way.
Okay,
thanks a lot.
Great. Thank you. Welcome back. Welcome back to the best track of that event. So we're here with Johan. So welcome, Johan, or Johan Ludwig. I don't know how I must call you.
Both names are fine.
Okay, okay. So Johan, I've heard that you're quite as good as talking about databases than teaching others how to bake gluten-free food. That's right?
Yep, it's true.
Okay, and I've heard that you've done this for a long time.
Yeah, it's going on 13 years now.
Okay, okay, great. So maybe you will be able to share some good recipe at the end on Twitter.
Yeah, people can always reach out to me on Twitter if they need anything.
Yeah, okay, great. Okay, but once again, it's not the topic today. Okay, so you will introduce the new battle that is currently happening between data warehouse solution on cloud platforms. So, okay, I will let you the stage. It's all yours and you can go on.
All right. So, battle for the cloud data warehouses. First of all, yes, my name is Johan Ludwig, lead solution architect at Capgemini. I'm also a Microsoft MVP. And you can find me on Twitter if you want. Intolerance, again, gluten-free foods, so food intolerance. Let's talk about data lakes and data warehouses. So setting the agenda leading up towards this new battle that is happening. Then the battleground, we'll look at the different opponents and the outcome of the battle. I'll do some analysis on the different solutions and try to declare some winners, though it's not a clear-cut thing. Sorry, I just got a delivery of fresh coffee, so I take it. So enterprise data warehouse. At least those of us who have been working with databases and data warehousing solutions have been working around with this for a while. It's been there since 1988. It has evolved over time, of course, with more hardware, some more techniques in. But mainly we see three different approaches. You have the dimensional approach by Kimball. You have the normalized approach coined by Inman. And then you have the Data Vault. Now you are in Data Vault version 2.0, which is a more open source approach to data warehousing principles. The data warehouse is subject oriented. So unlike operational databases, it looks at the subjects of the enterprise. And that's where we have data normalization coming in. It is integrated. So the data found within the data warehouse is integrated between the different systems across the enterprise. So you need to enforce naming standards, variable encoding structures, and so on. It is time variant. So while an operational data store looks at the day-to-day business of or running of your business, data warehouses looks at changes over time. It's non-volatile in that normally you do not change anything. You try to rather insert a new row and then use the time scale to show the changes that have been happening over time. And it is summarized. You are looking at aggregate features. Even though you can drill down to a granular level, it's still quite summarized. And of course, the data warehouse is structured. It's schema on write data. It's a relational databases. And it stores historical data that needs to be transformed before being shown. And typically, you transform before you store it into its final stage. And this setting is very good for business decisions, though it struggles a bit with more ad hoc use. Because it is made for business decisions, it has very high data quality focus, and it has to have exact numbers, which leads to a very long development lifecycle, which again has enterprise data warehouses having a quite bad reputation for being costly and long-run projects. So, as the other side of this story, when the data size is starting to grow, relational databases, we're starting to feel strain of this, as well as, again, we are struggling with delivering the time to market that the business needs. So around 2011, the data lake was coined. It tries to answer some of these pains in the data warehouse. In one of the V's of big data, I prefer to just mention 3. There are 4 or 5 depending on which marketing department you're talking to. But volume, variety, and velocity of data is something that the relational databases and the data warehouses were struggling with coping. The typical data lakes you can see are normally the raw data lake, so you just land everything as is inside a data lake, or the layer data lake / business data lake. And that has some more principles that they adhere to. First of all, you land the data as is with no modification. So you have a raw layer as with a pure raw data lake. You encourage line of business to create point solutions through the data lake, through the raw layer and out to their line of business. You let the line of business decide on the cost and performance of their problem, which means that IT and the data department or BI department can concentrate on governance of the critical points only. And in a business data lake, the corporate view that the data warehouse represents is just another line of business view. And unstructured information is still information, so it doesn't it doesn't matter if it's in a document or a CSV file or if it's in a relational database. It's information, and it has to be stored. Though never assume that the lake contains everything that the business have. Though this rule is maybe the most neglected rule of them all. Scale is driven by demand, so you can scale both down and up. But in the basic form, data lake is a repository of data of some sort. It's a storage account. Whether that be blobs or files, images, you can store all that in a data lake. It is by nature schema on read, so you don't care about what form that data comes in until you start reading from it. And it can contain a relational database as part of data lake if you want, and of course unstructured data. And you try to store all the data, even though, again, principle 7, do not assume that it stores everything. And the raw layer of the data lake, no transformation. Transformation happens up in upper levels. So you transform only from raw layer to curated layers. Typically, you might have 2 to 3, so a staging layer maybe, and then a fully curated serving layer afterwards. And there are various use cases and various users on the various layers of the data lake. Though a data lake is great for trends and ad hoc analysis. It's great for data science projects. And because it looks at the trends and ad hoc, there is a lot shorter time to market for development cycles. And this also enables self-service and data science in a whole other way than the traditional data warehouse has done so far. Of course, if you think on you want to store all the data that you can, you run into the danger of a data swamp. There's too much data there, you don't know what you have, you don't know what to use it for, and in the end you lose control over what the data lake is for. So cloud data warehouses were initially a response to the challenges faced by traditional relational databases. Again, too much data coming in at too high a speed and with too much variety. Let's look at different ways of handling a relational database with these challenges. So what they introduced was a massive parallel processing. So you distributed the relational databases across several nodes and had the controller node to distribute the processing. It's still a take on an enterprise data warehouse, though. So it's it has still the same kind of development techniques and time to market problems that the regular data warehousing faces. But now that we enter the new battleground, and of course that is the cloud. So the take of the contenders on the battleground is, how can we merge the data lake functionality and the enterprise data warehouse, because both solutions are needed in an enterprise. You have come up with solutions such as the logical data warehouse or virtualization. First was named for Gartner, virtualization, things like TIBCO or Denodo. But into that mix, the cloud vendors, the hyperscalers, as well as some pure players, came with new solutions. And these opponents are, first of all, you have Microsoft Azure with its Synapse Analytics play that was launched not too long ago. AWS has for a while had Redshift. Mind you, I forgot to say that Azure has always had the SQL data warehouse, but that has been repackaged. AWS with its Redshift, now in 3 different tiers. Google Cloud with its BigQuery. And then you have Snowflake which again is not hyperscaler such as the three others, but is a pure player delivering only Snowflake. First of all, let's look at AWS Redshift, and it is a massive parallel relational database based on PostgreSQL, and the data storage is columnar, and it looks at distributed databases again from a massive parallel point of view. So what is a distributed database? Well, you take a controller node, and then you have several copies of databases with each a separate node for the compute of that database. Typically, then you want to distribute the data between all these database copies within that cluster. And the different distribution types that you find in Redshift is distribution by key, distribution by all, so you just dump everything into one node, or an even distribution. It's more of a round-robin approach. So it has three different versions of or brands or generations of databases. You have dense storage, the DS2. Then you have dense compute, DC2. And again, these are mainly the same, but the dense compute tries to increase the compute power to solve some of the issues they had with the DS2 first. And then last year, they introduced RA3, or Aqua Advanced Query Accelerator. So Redshift Aqua Advanced Query Accelerator, RA3. Slightly different architectures on these. So the DS2 and the DC2 versions look mostly the same. They have a leader node, and then they have compute nodes, and within these compute nodes, they have slices of data within them. So this is what a typical cluster looks like. Now, in a Redshift architecture, the compute and storage nodes are combined. So it means that it's an always-on capability. You can't pause it without removing the data, so to speak. And some of this is then what they try to answer with the RA3 version. So you still have your leader node. Then you have your compute nodes. And then underneath, you have managed storage, which is SSD disks dedicated to each cluster. And then for cold storage or archive storage, you can then dump data into S3 buckets in this as well. Into the mix as well, AWS launched Redshift Spectrum. And Redshift Spectrum is a way of combining the data that is in the relational database with data that resides in a data lake. So you have your S3 buckets as storage. Then you have a data catalog, which is an Apache Hive bed store. And then you have a set of clusters, compute clusters, called Redshift Spectrum nodes that Redshift can talk to, that brings that data into Redshift as external tables. So it means that you can query your data lake with relational techniques. So it's just like querying a SQL table, but you call them an external table instead. And then you can build materialized views on top of those files that you've been querying, which then pulls that data and makes it available at a shorter time to market than just by reading from directly from the file. Though you can do that as well. It just has a small lag to it. Snowflake is a cloud data platform and not a database solution, if you look at their claim set, and we'll go through that a little bit later on. It is a pure ANSI SQL approach. It doesn't have any of the PostgreSQL or the T-SQL dialects. It's pure ANSI SQL. It is also columnar, and it has separate computes called warehouses or virtual warehouses. And again, that means that storage is separate, but it is shared among the different warehouses. You have compute nodes that shares a single repository of files. And it is allegedly maintenance-free, which means that you don't need to have a DBA that maintains indexes and so on, though you still need to take care and think about things like partitioning. So the Snowflake architecture looks something like this. You have your single storage resource, then you have your compute nodes, and you have your common services on top, which is again authentication and access control, infrastructure manager, query optimizer, transaction manager, and security. It has a single layer of metadata repository. I have not been able to clarify if that is a Hive metastore or something else. It's trade secret, I guess. The compute resources that I mentioned earlier, the virtual warehouses, also come with the cache. And then, of course, the storage, as I mentioned, underneath. And then you have connectors to all the main clouds. Sorry. In a Snowflake environment, you have dedicated warehouses per use case. So it's a very flexible approach. You dedicate your different compute clusters or compute nodes. For instance, one for ETL or one for data loading. Then you have one for syncing with the SAP data, for instance, or you have one that works with Spark data science, or one for reporting. It is auto-scalable, so it goes from, if you started out as X and extra small, you can set up the range that it can scale, so it can scale all the way up to 4XL if you want to. Of course, the price is increases at the same time, but it does scale. And it has an auto pause option. So you define when you set up a data warehouse, sorry, your virtual warehouse, you define at what time it should stop when it's not being in use. So it can auto pause after 5 minutes, for instance. It can auto pause after an hour. And you can even set it so that it can pause at scheduled intervals, which again means that you can dedicate warehouses per department. So when the finance department goes for lunch at 12, let's say, and the BI department goes to lunch at 11:30 or 1:30 or something, the data warehouse then stops because it has an auto pause option turned on. And while they are at lunch, you don't incur costs on that data warehouse because it's not being used. You load all the data into your central repository of databases, and when you then want to clone that data or use that data for testing or development, you do a simple clone. It's a 5-minute operation to clone a database and make it ready for test or dev environments. And that's typically also an approach that for use cases such as these, dev, test, QA environment has its dedicated virtual warehouse, which then only costs you money when it's actually being run for testing. Snowflake can also query over data lakes, so you can do external tables in the same way. And because it runs across all the different cloud providers, it lies close to your data. So typically, if you are running on Amazon in West Europe, you will need to go to London, I think it is, that has their connector. So you set up Azure in the UK, and then Snowflake is available for that region, or Amsterdam for Western Europe Azure, and then you have Snowflake available for you that way, and then you can connect that to your Azure storage. Likewise, that means that you can connect it as a staging table or a staging area for Snowflake, which also then works as a file share. And yes, I mentioned already external tables, and of course Snowflake also supports materialized views to reduce the lag of querying external tables. So this will look something like this. Again, everything, there is a maintenance service going under the hood in Snowflake, so you don't have to think about indexing, and in a lot of cases you don't really even need to think about partitioning, unless then your volume starts to get too high, then you need to look at these things in comparison. So why did I say that Snowflake is a cloud data platform? Well, it's because Snowflake is a lot more than just the database with the data warehouses. You also have the combination with data lake, as we mentioned earlier, that is part of it. Then you have data engineering using Snowpipes, which are small clusters, compute clusters that can connect to and ingest data, for instance, from event hubs. There is a data exchange within Snowflake, so you can share data with customers or with other Snowflake users and monetize on it. You can build data applications on top of Snowflake, and again, within the same ecosystem. And Snowflake supports data science using Python or R. So it is not just simply another massive parallel data warehouse. It is an ecosystem that is ranging across several different functionalities, and thereby we can call it a cloud data platform. Synapse Analytics, previously the service formerly known as SQL Data Warehouse, which was a massive parallel SQL server, runs on T-SQL, so Microsoft's dialect of ANSI SQL. And it is columnar per default, but you can also turn on row-based. And columnar in this setting is that you you treat data within columns instead of rows in a table, which leads to a very strong compression, and in certain use cases also a very nice query performance. Typically data warehousing loads with min, max, average, group by kind of functionalities. SQL Data Warehouse, now part of Synapse Analytics, has separate compute and storage with distributed databases. But it means that you can pause your compute to save cost on off hours, though it does not have an auto pause option. You can, though, schedule PowerShell or run Azure Automation Runbook to pause it for you at schedules. So again, same kind of approach like with Redshift, has a cluster and then spreads across typically 3 to 6 copies per cluster. Distributes with a partition key, again like Redshift, you can get familiar with that. So dump all data into a table in one single database cluster, or node, sorry. Or round robin, again, same even, it's the same kind of approach as Redshift has. Microsoft has then traditionally worked in this kind of setting. You have your data warehousing solution, so massive parallel processing to serve data warehouse queries for machine learning or Power BI reporting or something. Then you transform that data using Data Factory and Databricks, and you store data in a data lake as well using Azure Storage. What they've done with Synapse then is bundle everything together. So you have replaced Databricks with Azure Spark, and Data Factory now are pipelines within Azure Synapse, but it's still the engine that the same engine running underneath. But it then also connects seamlessly with Azure Data Lake Storage. It also has serverless SQL pools, so you can query files directly from a data lake and spin up a serverless SQL to look at the data in a structured SQL-like way instantly. It uses a technique called Polybase 2 for queries against all external data sources. Again, very much the same as the competitors have. You can query against external tables, but with some additions. It does run against all the relational databases as well, such as Oracle, Azure SQL Server, on-premise SQL servers, Teradata, and so on. And Azure Spark, don't know exactly the reason why they chose to go for their own brand, probably because they couldn't get Databricks to align on their way of seeing things, but they are using Azure Spark instead of Databricks as part of the Synapse pools, while still offering Databricks as a first-line service within Azure. And of course, you have Data Factory and Power BI. So it has a built-in connector directly to Power BI. And even though you need to open up Power BI Desktop to create the data set in the beginning, when you then publish that to Power BI, you can start developing and refining your reports based on that data set within Synapse. And everything that you can do is being delivered to you in a single workspace, which is the Azure Synapse workspace, which means that you can do Spark queries using Python, R, even Spark.net, which was released last year. You can do develop your data science models there. You can query data lakes. You can load data, transform data into your data warehousing solution. Everything from one single workspace, and that can be shared with, between teams and between the different kinds of users. Google BigQuery is serverless, which means that you don't have to think about sizing or distributions or how you how to post and schedule things. It's on demand when you need it. It is also ANSI SQL, and it has separate compute and storage, and you do pay for the compute and storage separately. It is also columnar in approach. Again, that is a very nice way of getting good compression on the storage of your data. You pay per query and not for the dedicated capacity, as I said. So you only pay when you actually run the query through it. And you pay for storage separately. You also pay for ingesting data via streams. It is optimized for wide tables, which means that it is very good if you're looking at a lot of a data warehousing solution where you have lots of columns in a table, so 100, 200, 300, 400 columns. The more joins you get, the more data you push through the query, and the more you pay per the query. So that's why I say that is optimized for a wide table data warehousing solution. And yes, it does support streaming data as well as batch. But again, it charges you a separate fee for ingesting data via streaming. So this is architecture of BigQuery. Last year in September, they also launched BigQuery Omni, which is a new multi-cloud functionality that was enabled by Anthos, which means that you can run BigQuery in Google Cloud, but you can also run BigQuery on AWS or on Azure, as long as you're using Anthos. I'll also mention briefly Databricks Delta Lake, which is coming in. When I was writing this, they hadn't launched their SQL for analytics service yet, But Databricks is coming into play as another cloud data warehousing or cloud data platform solution that you should take a closer look at later on, though I haven't considered it as a contendant in this space right now, but it is worth looking into. So, analysis on the functionality side, all opponents superficially resemble each other. They query the data using some kind of a SQL dialect. Most of them also support data science or big data kind of languages such as Python or R. So it's easy to start using them, very easy. They also allow you to query against external data, again, marrying or trying to bridge the gap between a data lake and data warehouse relational database approach. But only BigQuery against Cloud SQL, but only Synapse offers connection to other relational database systems as part of that package. And when you're running Redshift Spectrum, that incurs an extra cost on the Spectrum service on top of your normal regular compute powers or costs on the Redshift clusters themselves. All of them are scalable, but Redshift only offers 2 different scales per version. You have small and large, and that's it. There's nothing in between. So you can't really scale them in between when you need to. They are dedicated. And in this setting, BigQuery is considered serverless because, yeah, it's as scalable as you can get. You don't even look at or think about the size. You just think about the size of your cost or your credit card bill in the end. For loading data in, all of them support external ETL tools. But when you are looking at how to load that data in, Redshift and Synapse SQL pools need design decisions up front on exactly how to distribute that data. So dimensional tables as an all distribution, fact tables as an even distribution, but should you have key or round robin? So you need to think about it more when you're designing. And BigQuery needs to be designed to avoid those joins, again, to reduce the amount of data that is being pushed through the compute. Snowflake doesn't have these kind of constraints, even though, yes, you should think about partitioning after a while. It's not as set as the others are, and it's a lot more flexible. All of the contenders offer different browser-based query tools. So you can go into Azure Portal and query your Synapse pools, or you can run browser and Snowflake to query that data there. All of them offer APIs, so you can use client-based and then external tools as well. But if you're just looking at the browser-based tools, Synapse has by far the richest workspace for full development, end-to-end. And Snowflake is in many ways, right now, it's still in preview. The version that is in production is subpar. It's a bit old-fashioned, but they do have preview functionality that looks better. And hopefully they will put a bit more focus on that as well now that the contenders have, such as Synapse, have given a lot more thought into that. When it comes to speed, which is in many ways very important when you're considering these things, and all the vendors say that they are the fastest. They can point to research that supports their claim, but really, it depends. It depends on your usage patterns. It depends on the size of your data. It depends on if you're looking at the caching mechanisms. in the end, its speed is not what you should select your cloud data warehousing solution for. When it comes to availability, Synapse was just released in November. Snowflake is worldwide, but again, it has fewer data centers per region, which might be a problem for people like me in Norway, or if you're in Sweden or Denmark, and you want to run GDPR data. Does the Schrems 2 judgment bring any problems or challenge to you by moving that data into Amsterdam? Probably not, because it's still within the EU. But there are considerations like that with compliancy. That means that Snowflake does struggle in face of some client types, typically public sector. Redshift is also worldwide on all the different AWS centers available, though the latest version, RI3, is still rolling out. I didn't check before this session, but last I checked, it was not available in all regions. BigQuery is also worldwide available on all the data centers that Google have all over the globe. When it comes to pricing, Redshift has varying prices per version, but then per tier, so again, small and extra large, or small or large, sorry, as well as separate pricing for Spectrum. Snowflake prices storage per gigabyte and then compute per second, and then the price according to node size at the compute time. It's possible to learn how to calculate and plan your cost, but it is a bit it's a bit of a learning curve to understand how exactly how they build these things. And compute per second, compute per minute, perhaps is a more justifiable approach or claim to that. But it is very flexible, and you can scale / control what how you pay. Synapse has also the auto scalability up and down on the SQL pools. It has serverless options. It has Spark cluster selection, so you can control the pricing within each different component in Synapse, and it does bill separately for compute and for storage. And BigQuery also prices for storage, streaming inserts, and per megabyte passed through the query. And again, that is why you want to have as few joins as possible to make sure that what you push through the query is as minimum volume as possible. Other things that might be interesting to look at is in last week on Ignite, Azure launched Synapse Link. No, sorry, Azure Synapse Link, I'm mixing two things here. Azure Synapse Links and Cosmos DB Analytical Store was launched in November, and that is the possibility of connecting to a relational database, or sorry, they call it a relational database storage, or at least from an operational database approach. You can use a seamless integration without having to think about ETL between Cosmos DB, if that is your operational data store. Cosmos comes with an analytical store, which is a columnar format that syncs on a change data capture kind of syncing, and Synapse can then just integrate seamlessly with Cosmos that way. They say it's real-time analytics combined. It's not. It's 5 minutes syncing interval. So there's a lag of at least 5 minutes, 5 to 10 minutes, which means it's only near real time. It's not real time. And then you have what I was starting to say. Last week they announced Synapse Pathway, which is a nice play on competitors in that you can use Synapse Pathway, which is an auto code approach to translate all the code within a relational database system such as Teradata or even Redshift, so that you can pull or migrate your existing data warehousing solution from AWS or from Teradata or on-prem solutions into Synapse in a very seamless and automatic fashion. Mike mentioned that there are other vendors, such as my own company, that have created solutions like that also for Snowflake as well as for Synapse. And I guess there are more of these coming as well. So we're talking about data warehousing solutions, but a lot of them also call themselves data platforms. And yes, Snowflake can be justified to be called data platform in the cloud, but still none of them lack or have the data governance or trust domains in focus.
Ron, sorry to interrupt. Yeah, I know we started a little bit late, so you will have a little few minutes, but I don't know if...
Yeah, I'll speed it up. So it's,
okay, thank you.
Yeah, AWS has Glue, but it's only when you're using Glue for ETL. Data catalog, yeah, version 1 was shitty, but Purview came in, was launched in preview in November, and that does seem to have some promise for Azure Synapse. And of course, there are third-party tools. Let's skip. In conclusion, if I have to choose one of them, I would say Synapse has the broadest approach if you're looking at it from an enterprise setting or from going in from a workspace setting. It has a lot to offer, and that with Purview coming in as well, it does seem to mature into a full data platform the next year or so. If I'm just going for the cloud data warehouse on speed, I would choose Snowflake. It handles whatever you throw at it, XML, JSON, whatever it ingests it, and makes it available to you to query. AWS, for certain cases where you're already on AWS and you don't have a huge need for advanced scaling, Redshift is fine. BigQuery is a bit of the strange kid on the block, so in sort of way. It's not really a data warehousing. The pricing of this scares the shit out of me, but it's still blazingly fast. And if you're approaching this from, again, I know last time I held this session, I had people coming in with data warehouses with huge wide tables, were struggling in a relational database system, and BigQuery would be a perfect match for them. So in this kind of way, there are no clear winners, but take a look at it from these different angles that I mentioned here. And with that, any questions?
Okay, so first, thank you. Especially in that conclusion, actually, you answered two of the questions we had about when would you choose BigQuery. You answered that question, and also in which scenario you think Redshift is the best option. So actually, we had that two questions you answered, so that's fine. Just another question to finish. What about the data lake house?
Yeah, apart from the fact that I hate that term, it is Databricks' approach to the same thing. I think it's still too much of a marketing hype, but what they have so far with their Delta Lakes and their SQL for analytics, it does come into consideration. I would say if you don't have any kind of data warehousing solution right now, have a serious consideration about Delta Lakes and Databricks.
Okay, great. Thank you very much, Ron. And so we are taking a little break, and we'll talk about IoT in just 5 minutes. So be sure to take a break, bring a coffee, and we'll be back. And don't hesitate to ask Johan. You can find we can find your contact on our website if you want to reach you for any questions.
Yep.
And thank you. See you in 5 minutes. Bye-bye. Hey everyone, back from that 5-minute breaks on track 2 of the TheCloudFirst. We welcome Marco Dalpino on stage. Hi Marco, it's nice to have you on stage. I know you're very active in community-driven events, and all along the years you specialized in organizing one very important part of that event. Can you tell more about this?
Yeah, usually I've been asked every time to be the organizer of the catering, usually, or find the good places where to eat. That is not usually that's the easiest way, the easiest part for the events, and so I have this kind of knowledge around.
Okay, nice. That's good to hear. Probably you ask you for help on the next TheCloudFirst.
Yeah. I can write a sort of guide.
Okay, nice, cool, very cool. So you're here to tell us an IoT story.
Yeah.
So let's do that.
Thank you. Okay, so first of all, thank you all for attending my session today. And what we are going to talk about, we are going to thinking something that is not probably different from what you are looking here at this conference, because here the title of the conference is The Cloud First. And what I will talk about is something that we get back to the edge. So going back from the cloud and going on-prem, on the field, wherever. But I try to have a better explaining of that. First of all, who am I? Okay, and oh yeah. Just before to mention, remember to tweet about the event, because you have the great opportunity to receive all these nice stickers, and you can win that. So, who am I? I am a cloud solution architect. I work in Microsoft. I'm also engaged as already said, I'm also engaged with the community activities, and I organize several events wherever in Italy or outside. I place my contact, and I repeat that at the end of the session if you want to have to get in contact with me directly, just to ask a question or have express your opinion and say something. Okay, let's start. From the point of view of my CEO, the CEO of Microsoft, Satya Nadella, we understand that we're going to, in the world, we are going to build platform that involve an intelligent cloud, and we also do as Microsoft, but there are also other solutions somewhere. But that need to have a relation with an intelligent edge. And it's what actually Microsoft is going to do in the last years. Because if you think about of the cloud, you can understand very clearly that not everything of the things that we use, the things that we get in relation to, don't have the possibility to be strictly connected to the cloud, or have a continuous connection to the cloud, or in some cases have the possibility to send a lot of data, or high bandwidth connection, or there are some different cases. For this reason, we as Microsoft, we built a cross a cross environment opportunity and proposal. I try to showcase that very, very quickly. Starting from the rightest part, what you see there is the possibility to use our data center for the public cloud that we obviously own and manage all around the world, where we can have a complete offer of services and infrastructure to build high scalable and also very powerful application, not only for the IoT, but also for managing data, for managing AI, and also managing machine learning algorithm and procedures. But obviously, as I already mentioned, there is the need to, in some cases, to shift these power and also distribute this power and the possibility to use some kind of services, not only from our data centers, because obviously they are we have a lot of data center, but obviously they are not covering very closely all the country and places around the world. And in this case, we are we have started to offer some solution that can offer some part in full or selectivity with selectivity part to the edge. These are the two solutions you see here, that is named Azure Stack Hub and Azure Stack Edge. As you see below in the logo and also in the small description, you see that each of one is offering some kind of the services that we also have on the public cloud, but in a smaller or limited way. That's it's obvious, because we cannot get all the data center functionality inside in a smaller appliance or device. Going one step on the left, there's also another opportunity that we named Azure Stack HCI. I go a bit in deep after to describe better what it is. That also is another opportunity. And finally, going to the last two pillars, what you have on the left, the extreme left side, we have two kind of offer that is again is strictly related on what's happening on the edge, on our sensor, on our machine, on our implant, on in our cities, in our cars, for example, or in our appliance that we have in our kitchen, for example. And those last devices are something that is very much closer to the device, much closer to the things of the IoT world. And is something that, as you see, it could be used just for very specific and small function. Okay, just this is obviously a very fast and generic description. I will try to do a bit in deep with the specific points that are needs. Okay, why make sense to go hybrid? The correct way to say what I'm talking about is going hybrid, because hybrid in the sense to have an opportunity, a platform that offer either the public cloud services, but also something that is closer to the customer, closer to the, for example, to the device, to our use case, let me say. Usually, the reason are something I already mentioned probably, but first of all, the connection. When we cannot have a continuous and strong connection between the cloud and our device installation whatsoever. When we have a specific regulation, lawful loyalty that we need to agree with, for example, some data that are very, we have to maintain inside our specific ecosystem, inside our company, inside our machine, and we cannot distribute outside of there, is sorry, another of the reason. For example, another one is when we have to speed up the development of some not only software but process of automation that need to be that need to use some high-level service that the edge platform can offer out of the box, for example. And also, why not also to give us the possibility to easily communicate, but also integrate and communicate between the edge and the cloud, just to sync our data, just to update information, or, for example, receive information and showcase information, for example, on the field. That's also one of the main reason. The Azure hybrid, the offer that Microsoft have for the hybrid is something like this. As you see, we have the let me say the hardware, okay, the very much solid part of the infrastructure that is the Azure Stack integrated system. In the center, you see Azure Arc is something I don't go to explain today, but just to generically understand what it is Azure Arc is an offer that Microsoft have on its cloud that permit to manage. It's a software, first of all, that permit to manage wherever you have on your deployment, either it is on the cloud, it is on-prem, it is on another cloud provider, because Azure Arc can manage also infrastructure and whatever services you have that are also deployed on other cloud provider, for example. In this case, you see from the small icon, I can describe just VMs, virtual machines, container, and two or more kind of different database solution, like, for example, Postgres, SQL Server, MySQL, whatsoever. On the rightest part, what we describe as Azure IoT is something a bit mixed, because the ecosystem, that the environment that Microsoft defined for Azure IoT is a complete suite of services that services, software, and in a smaller part also some hardware that is related essentially to the IoT. All the environment is dedicated to manage, describe, create ecosystem or architecture that can get data from the field, send it to the cloud, manage, elaborate that on the cloud, and then eventually get back on the edge, on the field. When I said going to the cloud, in this case, we can also use Azure IoT services not only for going to the public cloud, but also on the Azure Stack cloud. Okay. You can consider in this case Azure Stack platform essentially exactly as something very close or very similar to a public cloud data center region. Okay, go forward, and this is what the main pillar that we are going to see is Azure Stack. As I said, Azure Stack is something that is hardware essentially, and we have in our offer we have three main division: Azure Stack Edge, Azure Stack HCI, and Azure Stack Hub. What does that mean? Azure Stack Edge, as you can see, is in this picture is an appliance, a rack appliance, like you probably already see from other vendor, like for server that you place in your rack, in your data center, wherever. That specific hardware is completely managed by Microsoft. Okay, you can think of that as an hardware as a service. Just going to remember the way to go we have for the cloud. You can consider that you get an hardware as a service. In the center, you see Azure Stack HCI. I'm sorry, you see that there are very similar acronym or label that describe our product. It's something that in Microsoft we do very often. And so I try to be much clearer as possible just to let you know. Okay, Azure Stack HCI. What is? Essentially, HCI is the option to get in an hyper-converged solution. What is essentially a server that offers me the possibility to deploy VMs, container, or storage solution inside this server. This offer is coming from partner, not from Microsoft. and is something that we connect as all the Azure Stack ecosystem. We connect with our Azure portal, and we can manage from that. But in this case, the hardware is completely managed and invoiced and also assisted wherever from a partner. We have a lot of partners that are selling this kind of hardware. Dell, Lenovo, Fujitsu. There's all the main hardware providers. The third column, Azure Stack Hub. Again, in this case, Azure Stack Hub is something that is completely managed and sold from Microsoft. You can think about of Azure Stack Hub as a Azure data center region as a service. I try to explain better. You can, as an enterprise, obviously, because this product is not for, let me say, small business or medium business. Usually, Stack Hub is something that is targeting for the enterprises, this kind of companies. But what you get with Azure Stack Hub is essentially a complete one or more complete rack that represent exactly the same things you have inside a Azure data center. Okay, it's essentially the same that you get a piece of data center and you place it inside your data center or server farm, wherever. Okay, obviously, as I said, it's not for all because you need to have some kind of prerequisite to deploy Azure Stack Hub, but is something that is very useful in some kind of scenario. For example, when you have disconnected scenario, the main example I give every time for Azure Stack Hub is the cruises ship. Because when the cruise ship is departing from an harbor and going in the sea, in the open sea, and sailing to another harbor, but stay in the middle of the sea for a week, 2 weeks, or wherever the time they spent. Obviously, having connectivity with the cloud is something that became a bit costly, a bit very high in cost, and cannot be guaranteed. Also, if you need, for example, high bandwidth connection. And if we have application for, let me say, the cruises, for example, for managing the stock of the everything we use on the crew, on the boat, wherever, all the application for entertainment, for retail, or wherever on the boat, that obviously could have a lot of benefits to use services like we have on the public cloud on Azure. You cannot usually use that when you are traveling in the middle of the sea. That's the solution. You place the Azure Stack Hub and you can access a personal, let me say, data center, a personal region of Azure, but that is deployed inside your boat. Okay, let's go, because yeah, the time is running. Okay, going a bit in deep. As I said, Azure Stack Edge is something that you can consider as an hardware as a service, because the hardware that you receive is completely managed, pre-installed, and completely covered by the customer service by Microsoft. What you pay for that is a monthly fee, okay? And also when you get the first time, you have a shipment cost, obviously, but from that time and forward, you only spent a fixed a fixed amount per month that comprise everything, wherever services you are going to use on that hardware. The cool thing is that you can manage all you are going to deploy inside your appliance directly from the Azure public portal. And you deploy things and services exactly in the same way you do in a region of Azure, for example, Western Europe, Northern Europe, or West US, or wherever. And you don't have to mind about hardware problem, deployment, updates, whatever. If there are some hardware problem, there are a couple of rules, if I'm not wrong, about, for example, hard disk failure can be changed the hard disk. Otherwise, all the hardware will be replaced in total. Obviously, if you are managing to run solution that need to have a continuity in your service, you have obviously to have not just one appliance, but probably a couple of that, because if one of that is going down for some reason, probably you need to have up the second one to have a disaster recovery or continuous service that goes on. Another good point that expressly work very well on Azure Stack Edge is to run your application very closer to your customer or to your or where your application needs to run. Specifically, for example, for manufacturing plant or I don't know, inside your city to analyze data that are coming from sensor or from camera for the traffic, for example. In these cases, Azure Stack Edge is a solution that works very well. Why? Because you place all you get the application and put it very close to your user, and you remove all the problem that can be leveraged by throughput of the data, the latency of the data, or also the resiliency of your connection, because probably in all that case that your connection cannot guarantee to be up for 24 hours a day, for example. Another good thing is to have a specific hardware acceleration that you can manage directly close to your application. That is something very useful for specific scenario that I will showcase after. Another good point is to manage the transfer of a big chunk of data that usually you cannot manage from using the normal connection, because it gets you spent a lot of time, or in some case block your activity for other application. And the optimization of data transfer is something that Azure Stack Edge do in a very, very good way. Okay. Azure Stack Edge is offered in 3 different kind. The one on the left is the one I already showcased you, is the normal 1 unit server that is offered with 1 or 2 GPUs for if we need acceleration for machine learning. I miss to write there that there also the possibility to have a FGPU, an Intel FGPU offer on that. The other 2, the Stack Edge Pro R and the Mini R, are essentially solution for application that need to guarantee that the server could run also, for example, inside a car, inside a truck, around having still working in an environment with dust, with humidity, with high shocking. And all these hardware are guaranteed to continue to work also in weather or environment conditions that are not optimal. And as you can understand, is something that is very is targeted for very specific application, let me say. Okay. These are the hardware specification. You can obviously find that also on our site. More or less is what an hardware is built with. Okay, go ahead. Some use case, I already mentioned some of that, but let's try to go a bit in deep on the use cases where we can use and have the opportunity to utilize the Azure Stack Edge. First of all, the machine learning at the edge. Yeah, the first sample I get every time is consider your city, your smart city, that have the many cameras for the traffic control around on the road, and you want to manage to analyze the stream of this video just to understand when you have a peak in the traffic, or if you have some specific rules, for example, about the traffic, and you want to have only cars with electric cars, for example, or low emission cars that are driving, that are traveling in your roads. You can analyze that kind of streaming. Video streaming in real time and extract that kind of data. For example, if I want to know if a car is an electric car, I can read, for example, the plate of the car and going to the car registration protocol and see if it is an electric car or not. I also mention about the traffic count. If I want to manage to change the flow of the traffic, I can manage the traffic light to turn on red or turn on green, considering the change, for example, of the traffic. And this is something that could be very easily done with the use of Azure Stack Edge. You can say, but you can do it also using the public cloud. Yes, obviously. But in this case, you have to get all your video stream and put it all to the public cloud. And it's a huge amount of data that you need to broadcast to the cloud, and probably the bandwidth that you need is very high. You spent, I think, a lot in your equipment for the connection and transmission, and probably something that not every city could manage to have. A solution with Stack Edge is probably much much less pricey. Edge compute and IoT solution, again, is something that is very close to this kind of solution. Why? Yeah, I am in a manufacturing or building plant, and I have to manage the reaction to some specific action or movement from my machine in order to proceed in the process of production, in the process of what I'm doing in my site. Obviously, using the public cloud, we have a latency or connection problem that could manage to have to give us some problem.
Okay, so next, you may.
Sorry? There is something. It's okay? Okay. I continue. To manage your, for example, real-time application. Last but not least, the network data transfer from edge to cloud. As I already mentioned it, if you have, you get, for example, a lot of picture, image, videos around from the field, and you have to transfer this kind of data to the cloud for managing that whatsoever. And you don't have the needed bandwidth to go to do it in real time. Having Stack Edge could leverage this kind of problem using the different timing where you don't, for example, get all this information, and you can use the bandwidth and don't, let me say, don't get some damage to the function of your system, because if you are transferring a lot of data, you probably fully complete and saturate your bandwidth, and other applications that need to connect, for example, to the cloud cannot use it, and probably works poorly or bad or doesn't function at all. Let that get me a bit faster. These three use cases you see described here is exactly what I'm talking about. I go forward because the time is running. Okay. Again, this is something Esri is one of our customer that is essentially not only showcase but use on for real stack edge, and they use it also for application on the field. For example, for reaction on some fire or some earthquake or whatsoever. Okay, the transfer to the edge, I talk about that. This is another of our customer that use it. Okay, more or less is this. This is the summarize of everything. Okay, I leave you all these kind of slides just to completeness of what I describe you, because I have to run a bit faster now. Just a bit of a specification about the compute part. The compute part on Azure Stack Edge is something much closer to what essentially a server is, because the compute part is the possibility to deploy to Azure Stack Edge our platform for the IoT, that is named IoT Edge, or Kubernetes. You all probably know what Kubernetes is, the possibility to run containers on Stack Edge, and virtual machine, deploy virtual machine that do whatever you want, and you can personalize and customize your virtual machine as you want. Obviously, in a compatible way with the hardware you have, probably. That is how Kubernetes is working on Azure Stack Edge. What I want to emphasize is that you can manage all these directly from the Azure portal and also from Azure Arc, also from Azure IoT Hub. But just to leverage that, you don't need to have a specific knowledge of how to manage it, but is completely on the same level of what you are doing on the port. Okay, machine learning. Okay, here are the specifics or the hardware that we have on Azure Stack Edge, NVIDIA T4 GPU, and also Intel Movidius VPU for specific ML implementation. We implement inside this kind of VPU OpenVINO and another couple of ML image type. One is on X and the other is a TensorFlow. Okay. This one is the normal loop of generation and update of an AI model. I cannot go in deep in this because I don't have the time. Again, to the storage gateway. Okay. Again, we are back on what we said from the portfolio. Edge, HCI, and Hub, just to describe what are the specifics of Stack Hub, some other use cases, and here I have, let me see, okay, the time is almost up, so I have to go very, very, very fast. Some different kind of solution that can be managed considering different piece of our solution, just the cloud plus IoT, just the cloud with the stackage, just stack hub with the IoT. So some kind of solution that could be managed with getting different part. This one is a use case from our one of our customer that is for retail application. As you can see here, the machine learning permit me to understand without having to drive inside, so running inside my shop, where I don't have stock, for example, for that biscuits. Now, just a very, very fast mention of something that we presented at Ignite a couple of weeks ago is a new solution. The name is Azure Percept. That is actually a developer kit that is an hardware and software solution that permit you to place this hardware, connect the cable, and it run immediately in your Azure portal, where you can do things using the Azure Percept Studio. What is Azure Percept Studio? Percept Studio is a part of the Azure portal where you can create your own machine learning image, or you can use the other inference image that are already deployed already inside the device. Okay, I know that I'm very, very late and I'm running out. So I go very, very fast. If you want to try Azure Percept, is, as I said, in preview, in public preview. You can order that on aka.ms Azure Percept. Okay, if you want to know more about this, we can also have a chat out of the session.
Yeah, sure. You can connect on Twitter.
Yeah, absolutely.
Sure.
These are some
Marco,
resources. Yeah, I know, absolutely. I just want to remember that to give us your feedback, because it's very useful for me and also for the event, just to understand if we are going good or not. And also you have the opportunity to get some stickers. Again, this is on my contacts. And okay, thank you. Thank you all.
Yeah, thank you, Marco. And for the next session, we welcome Isidora Katanic. So, Izzy, I will welcome you on stage.
Hello, good afternoon.
Bye, stay with us to enjoy the session.
Absolutely, thank you. See you, bye.
See you. Hey, Izzy, so I'm fine, and you?
Very good, very good. Yeah.
Okay, so very good to have you on stage. It's a little different for that session, as you give a session with Holly Liman, which is based in Seattle. So due to the different time zone, it was really hard for her to join, as it's like 3:30 in the morning for her.
Yeah,
so
I know, right? I'm like, why is she not here? It's like, it's a very normal human time to show up for a conference at 3 a.m. in the morning. But no, I'm happy to represent the both of us. So like you said, it is a little bit special. We recorded our session together with you. So yeah, I would say
it's good to have you. So we will just launch that recording, so you will have all the session, and as if Holly was there live. And also just to let know,
she's always here, right?
Yeah, that you will be there to answer questions on the chat and on Twitter. So okay, thank you very much for that. Let's do it.
I'll be around.
Okay, so next, you may not know it, but TheCloudFirst is actually run by communities based between France, Belgium, and Luxembourg. And up next, we have dynamic duo Holly and Izzy, who are over 5,000 miles apart, never met each other in person, yet became very close friends through Twitter, and started their own video series named Heard in the Cloud, Heart in the Community. They are here at TheCloudFirst to tell us the story about this journey and hope to inspire you with what's possible with the power of community. So it's to you, girls.
Hi, thank you so much for having us here today. We're very excited to be here. So thank you to everybody at TheCloudFirst for having us, and also who is watching, listening, joining the conference. So yeah, after our session, if you liked it, make sure you submit your feedback. If you did not like it, also make sure to submit feedback, because we definitely also want to learn from you, and we're always looking for improvements. Then also today, sharing is caring. That's very important. So stay active on social media, tweet at TheCloudFirst.io, hashtag TCF21. And for each tweet, the organization will be monitoring the hashtag all day long. There's a chance for you to win stickers. And there are going to be 10 winners, so get your lucky chances. All right, so going off to our session. So today we're presenting Women in Tech, Head in the Cloud, Heart in the Community. And we're very excited to tell you more about our journey. So yeah, we will quickly introduce ourselves. I'm here with my lovely partner in fun, Holly Lehman. Yeah, so Holly, quickly introduce yourself.
Absolutely. So first of all, again, like Izzy said, thank you so much for having us. We are very excited to be a part of this event. Quick little note about myself to personalize the experience. I am from Las Vegas, Nevada in USA. Many people are shocked, but yes, there are some Vegas natives out there, and I'm one of them. Being that I was raised in Vegas, I have been in the hospitality industry since I could walk. I worked in many hotels, opened a hotel, and it was a wonderful experience, but it did also teach me how to become a program manager. So after 10 years of being in Vegas with my husband, we had our first baby, moved to Seattle, Washington, where my husband is from, and I ended up joining the tech world. I now am a program manager for the Azure Product Improvement team with Microsoft, and I am very privileged for that role that I have. Outside of my role at Microsoft, I am a mom of 3, I say. I have 2 little girls and a sweet little pup that's gotten me through 2020. Izzy, hand it over to you.
Yeah, thanks so much, Holly. Well, as you've already heard in the beautiful introduction, we are over 5,000 miles apart. Well, I'm based a little bit closer to where the conference is virtually taking place, right? So I'm in Switzerland. However, I'm born in former Yugoslavia. I've been raised in Amsterdam, the Netherlands. And I followed my heart approximately 3 years ago to a lovely small country, Switzerland. So I'm a recently awarded Cloud and Data Center Microsoft MVP, and I have a passion for all things community. And that's also why we're hosting the session today, to tell you about our story, how community brought us together, how we started our video series, and basically our entire journey. So if you're wondering what is Head in the Cloud, Heart in the Community, Holly will tell you more about it.
So to preface the beginning of this, like Izzy said, she has a huge passion for community, as do I. So from the beginning of my time in Microsoft, I have been having the privilege of running various communities for customer, MVP, and now partner. I run the North Star Partner Program for the Azure Product Improvement team, and as Izzy mentioned, she has recently awarded the MVP status because of her passion and involvement for community. So when Corona happened, we looked at each other and said, how can we take our passion for community and drive positive influence in this crazy world we live in now? And we used the benefit of COVID and not being able to travel anymore like we're used to. And we thought, let's virtually travel and highlight all these amazing humans in technology, share their passion, share the side things that they're doing that people don't even know about. We've talked to fashion designers, book writers, mentors, all these different side things that are happening. And we thought, let's find a way to showcase all of these amazing humans in technology from all sides of geographic location, diversity, inclusiveness, different technologies that people are working on, and Head in the Cloud, Heart in the Community was born.
Exactly, our community talk show video series. So how did it start from the very beginning, Holly? Tell us how the social media world actually brought us together.
So it's funny, I have a mentor who's become a dear friend who told me 3+ years ago, get on Twitter, get used to sharing your voice with the world. And I was so nervous. And now looking back, I'm so happy that I did. And I now see the power of social platforms. We have an MVP friend that we both share a friendship with, Sam, and he said, you have got to meet my friend Izzy. You would totally get along. Connect on Twitter. Well, then I found out that not only was Izzy absolutely amazing, but her fiance also works on Azure. So we got to connect and get to know each other. And we have become such dear friends, but like it was mentioned, we've never actually met in person yet.
And it started with fun.
That's right. So we had this silly idea to kind of tease some of our friends who also run a tech podcast called Patch and Switch. And we said, we're going to do a TikTok video, just tease these boys to do a TikTok back, which they've not yet done. But once we posted this, we realized that people were laughing. This video went crazy with people liking it, retweeting it. And we realized, oh my gosh, we have so much fun together, even virtually. And if we're having fun, we're encouraging other people to laugh either with us or at us. But they were laughing, they were engaging. And this was all during a time where we were missing the face-to-face with everybody. And this gave everybody a bit of virtual fun together. It really brought community together for us.
It definitely did. So yeah, so putting all the fun aside, I mean, of course, we're having lots of fun, but it also takes a lot of passion, planning, hard work to keep our video series up and running. So we're happy to share you our journey and basically how we started, how we're doing it, and so on. So yeah, we started with an idea. And from there on, we worked on branding, planning, execution, and so on, which we're going to tell you more about. So first of all was our brainstorming session. So we defined together, so what is our mission? What are our goals? What are our ideas? That's something that I would highly encourage anybody who's looking into starting their own podcast or a video series or to write a blog to have this in place, or at least to think about it, right? It will make the process a lot easier. And especially if you share the same mission and you share the same goal and you agree on the ideas, that will really help you to move forward. So first of all, to start with the branding. So our brand, if you go to our YouTube channel, we will share later all the details with you, of course. You will see hearts, you will see clouds, you will see pink, you will see purple. And those are, the colors, the signs that really resonate with Holly and myself. So we created, we actually had external help, right? From a professional who guided us, who created the logo, the tune, the intro for our video series. So if you're not creative yourself to create that, don't hesitate to look for help external to get your brand alive. Then once we had that settled down, we started to think about all the hardware and software, and Holly will tell you a bit about her part of that story.
So mine was a bit unique because unlike a lot out there, I wasn't working from home remotely. I had an office, I had everything that I needed. COVID happened. I happened to be in Mexico with my family, came home and was told, you're not going back to the office. So get one set up at home. And so for me, I took the time to set up what for me was the office that I needed. What I would say for anyone listening it doesn't have to be the standard office. We found that some people work out of their closet, some people work in their kitchen, some people like to go outside. Whatever it is, find a place that will get your creativity going. Then we realized that I had nothing set up. I had a laptop, that was it. So I set up my office, we got a router. I realized I was having all these connectivity issues because I wasn't hardwired in. Had I not had friends in the tech community to say, these are the reasons why this is happening, I wouldn't have a clue. So then I reset up my office all over again, hardwired in, and I've slowly been realizing that for what we're doing, I needed a mic. So we purchased a mic. I realized I needed, different webcam and different modems and cables and all the things to make what we're doing successful. Like Izzy said, I wouldn't know if I didn't lean on other people. So don't be afraid to ask. So whatever your creative ideas, whether it's coding, creating, writing, whatever it is, ask other people in that community what made them successful, because otherwise you're going to spend a lot of time and money that you might be able to just streamline by getting advice in the beginning. And so we had to think about lighting, location, time zones. So there's a lot that goes into whatever your creative idea or goal is. Really plan it out and execute it.
Yeah, so speaking of indeed planning, responsibilities and timeline, this is also something that we, I think pretty much defined upfront. And we looked at each other's weaknesses, each other's strengths. How can we help each other? How can we learn from each other? What are you good at? What are you good at? And from there on, we worked on our responsibilities. And so if you're working with somebody else in a team, whether it's one person or more, I think it's so important if you have responsibilities defined up front, so you always know who will take care of what and that person is responsible for it. So Holly and I have a very clear structure where Holly is responsible for let's say the pre-organization. So reaching out to our guests, confirming the date, having the recording set up and so on. And then, of course, the recording itself is a joint responsibility. And afterwards, I take care of all the editing work, all the post work on the series. So we have a very clear responsibility, which works perfectly for us too. We always know who will take care of what. And then, of course, a timeline. So we also defined upfront the cadence of our series. So we want every month, we want to have one video. A monthly episode. All of that, if that's predefined, it makes it a lot easier than if you just go and just whenever you have time or whenever you feel like it, you will do it. That will make it, I think a bit more complicated. So I would definitely encourage you to have responsibilities and a clear planning and then stick to that. That doesn't mean that you cannot change or learn or improve, but it is a basis to start. And then from there on, actually most important of our video series are our guests. So Holly, please tell us how we take care of that.
And I think this is so important because, again, it's a shared experience. Izzy and I meet, we talk about, so what are the guest structure that we want? And so for us, we think about geographic location because we don't want people just in the US. We want people from all over the world. So we think about location, we think about technology, we think about what are people in the community that maybe aren't as well known. How can we help showcase them? How can we pull people in that are known? Because we have to think about our building, our community, our brand. How do we get the word out? And so we think about how many male, how many female. We want to make sure it's within Microsoft, within the MVP community. And so there's a lot of things that we think about so that when we talk about diversity and inclusion, that is showcased in each month's episode.
Yeah, and then speaking of our guests, of course, every episode has different topics, has different stories, and also there you have to think, what is the message you want to bring across, right? So whether if it's your blog or it's your video series, it's your podcast, what is the message that you want to reach people with? So first of all, we always try to think of our guests. So what is important to our guests to have highlighted? Is it a book they released? Is it a fashion line they designed? Is it a code they've written? I mean, there's so much let's say, side hustles in the tech world, which we absolutely love to highlight, and also get to know, about hobbies and sidekicks from our guests. Secondly, where of course it's a talk show by the community for the community. So we also try to think what's relevant. So what is interesting for the community? What is currently important? We openly talk about topics such as Black Lives Matters, working from home during the pandemic, homeschooling your children, homeschooling a kid with autism. A lot of topics we love to openly talk about, not just the technology or the work or the career or how people got into tech, but also really the human side of it. And then lastly, yourself. So what do you find important? What's the message that is close to your heart and you want to get across? So you will often see that both Holly and myself were advocates for women in tech, more women in the IT industry, women to speak up, have their voices heard, equality. All those topics are very important, and you will find it back that we discuss it in our episodes. So yeah, just to quickly summarize. So think of your guest, think of the community, and don't forget yourself.
So this is near and dear to my heart because, like Izzy and I, we've already mentioned, we have been running events for the community for years. And so when we think about the impact that our events will have on the community that's attending, we have become very detailed in how we line up the speakers, how we arrange the logistics, what does the event look like. And at home, it's a little bit different. We don't have the ability to know when the garbage truck is going to arrive or when the FedEx delivery will be here or when a kid in the community knocks on the door or the dog barks or the kids jump in and say hi. And so we've had to learn there really are no ideal scenarios in this environment. And we have to be okay with the fact that sometimes technology, it's not going to always do you a service. Sometimes you're going to have issues with connections. Sometimes you're going to have these issues that arise, and you just have to learn to give yourself grace and kindness, realize what's in your control and what's out of your control, and learn to just flow with the imperfections that might come up.
Yeah, and actually we love little guests that pop into our episodes. So here's one Holly's daughter that comes with a peekaboo during a recording we did with Lori Potmeyer. We had one of our recent episodes with Jess Dotson, where her lovely little daughter walks in. So yeah, just to amplify once more what Holly says. Like all those little imperfections, actually we see as perfections, because this is exactly how life is, right? It's true, it's honest. This is exactly what moms currently working at home with their kids have to deal with. So embrace it, accept it, and it's totally perfect. Good. So as we are soon approaching the end of our session, we do quickly want to share our top 3 tips with you. So first of all, have fun. That's something that both Holly and I try to have for each and every episode. We have so much fun, not just during the recording, but the whole journey up front, right? The coordinating, getting the questions ready, preparing. I mean, it's really a lot of fun involved. And the more fun you have, the more you will enjoy yourself. Secondly, have the right equipment. So microphone, camera, lighting, if you're doing a video series, that will help you a lot better to get everything out there in the right way. And then lastly, I would really encourage you to prepare for every show you do, no matter how many episodes you've done before. If you've done 100 videos or if you've done 5 or 500, even the best speakers out there, they also prepare, right? So really, I would say prepare for every show as if it's the first one. And then Holly, what are your top 3 tips?
So I would say, although, Izzy and I are talking about our goal, which was to create a video series, whatever your goal is, remember it's your passion. And so if it's your passion, there's other people that have the same passion around whatever your topic is, and go with it. The other is your voice is important. When we started this, it is quite intimidating to feel like, what do we have to share with this community? But you know what? We've learned that because we have this passion, because we're having fun, we do have a voice that should be heard. And a lot of people, a lot of people want to hear it. So whatever your passion is, people want to hear about it. And number 3, don't stop learning how to make improvements. Like Izzy said in the beginning, we want good feedback. We want feedback from you where we can make improvements on our series. Take feedback from each other. Quite often, Izzy will ping me and say, hey, don't forget about this, or hey, did you see this? Or hey, Izzy, can we do this differently next series? And by learning from each other and learning from the community, you only better and mature, evolve whatever your effort is. And I would say it's never a bad thing to get good feedback. And lastly, like we've said, have fun.
Always have fun. Good. So so speaking of our show, Head in the Cloud, Heart in the Community, please follow our YouTube channel, subscribe to stay tuned. And Holly, maybe you quickly just want to highlight a little bit our guests we had on the show.
Yeah, so like I said, we talk to people from all walks, makes, location, because we do want to highlight the community in itself. So we've talked to people like you'll see Lisa Clark. If you haven't followed Lisa at the Edge, I would highly recommend to follow her podcast. We talk about fun things like Thready the T-Rex at Microsoft, how the T-Rex was born. We talk to a number of parents in the community to talk about what it's like to work in tech and homeschool kids full time. We talked to Lori, who runs the MVP community for Teams in Microsoft, to learn about what the passion she has for community. So there's just a whole gamut of topics and people that we interview because we want to make these series important for you, humanize the community, and share the passion that is so deep within this community.
Absolutely. So let's connect. We love to expand also our network. We love to hear from you. So you can find us on Twitter. We're both very active, sharing our stories, not just about Head in the Cloud, Heart in the Community, but basically everything. Well, not everything, but a lot we do in the community. So with that, both of us want to say thank you very much for having us. Thank you to the TheCloudFirst organization. And I'll give the virtual stage to Holly for her final words.
Yeah, we just want to say thank you to everybody that set up this event. And as you'll see, this is a pre-recorded session since it'll be 3 a.m. my time when this is aired. So if you have any questions on our show, advice on, how to get your goals going and running, please feel free to reach out to us on Twitter, DM us. We would love to connect with you and follow your journey as well as ours.
All right. Thank you. Goodbye, everyone.
And thank you. And also, don't forget to give your feedback on that session. Yeah, to have a chance to win your collector sticker pack and to give us the opportunity to have your feedback on it. And thank you once again, Holly and Isadora. It's really interesting. I see a lot of common experience and reflections between your journey and our own journey to build TheCloudFirst. And it's really good to see that the communities has the availability to adapt to that situation, to take that as new opportunities. That's really encouraging and really nice to see. So thank you very much, and we will continue to TheCloudFirst with a little break. Thank you and have a nice day.
Thank you.
That's weird. I doubled there.
So that's it for the last session of this morning. As we said, so Izzy is there live to answer your question on the chat on Twitter, everything you want. So thank you once again, Izzy, to join us live. So we'll continue with a little lunch break. Just an announcement for the next session on that track. We had a late minute change as the speaker will not be able to be there. So we will please join track 1 or track 3 for that specific time box, and we'll be back after with the next sessions. Okay, so thank you once again, Izzy,
Thank
and
you
let's
so much.
go for a little break.
Also, please extend our thanks to your whole team behind the scenes for organizing. It's been a blast. And of course, thank you to everybody who watched or listened to our sessions. And indeed, I'm available on Twitter, on the chat. So if you have any questions, feel free to reach out.
Yeah, and you can find all the details to reach you and Holly on our website. There's everything on your profile. So be sure to check it out.
Thank you so much. Enjoy the rest of the event.
Yeah.
Hi everyone, Microsoft is very, very happy to support this one-of-a-kind conference, TheCloudFirst. And this is not our only way to support developers and communities, isn't it?
No, it's not. And we are all part of the developer relations team here at Microsoft. And you may have already seen us at other conferences or events. We are here to meet you and help you familiarize with our tools like Visual Studio Code, Azure, .NET, and many others.
You can also find us on Twitter at msdev_f4. We are also there on meetup.com, where you can find lots of Microsoft communities that we support. And lastly, find us on YouTube at Microsoft Developer France. Also, if you have a second, have a look underneath the video at the link to register to our monthly newsletter. We hope to see you soon and enjoy the conference.
See you guys.
Bye.
Hi everyone, welcome back. I have a little announcement. As due to a late minute change, we are taking you to track 1 or track 2 as this session is cancelled. The speaker was not able to join us on time due to personal problem anyway. So we'll take you to track 1 or track 3 for even more fun and good stuff to learn. Actually, on track 1, you will have a design factor for decentralized edge application by Andrew Betts. So it's on track 1 in English, and in track 3 in French, you will have a strategy to move your data to Azure by Laurent Bugnon. Again, sorry for the inconvenience. We'll be right back in 50 minutes with Ben Forsyth to learn about strategy to secure your application in distributed architectures and workflows for the next session. Be sure to come back. And yeah, sorry for that. You can go to track 1 or track 3 for this session.
There we go.
Sorry,
No problem.
It was from previous session. So
Yeah,
here we are back on track 2 of the TheCloudFirst. Up next, we will talk about security strategy when it comes to distributed architectures and workflow. So please welcome Ben on stage. So welcome, Ben.
Thank you. Thank you, Philippe. I'm doing well. Thank you very much. So, well,
yeah, I heard that when you're not working with data on the cloud, you're an extreme surfer, sharing your time between surfing the wave in Oceans Beach, San Francisco, and riding fresh snow of Sierra Nevada mountains, right?
yeah, that's true. We just got some snow over the past 2 days, so I was really hoping to be up there, but
yeah,
got some other priorities this week. So
it reminds me how much I miss outside, actually. Okay, anyway, Ben, so it's your turn. So you're live. I'll let you the stage.
Okay, great. Thank you so much. Yeah, hi, my name's Ben Forsyth. I'm the chief architect for IBM Aspera, and I'm going to give a presentation today about securing content in the new age of distributed workflows. So I'm going to first start off with giving a little bit of background about myself, and let's see if I can operate all of this stuff. Here we go. Okay. Well, that's what I see is a little bit different from there. Let's hope it comes through a little bit better. As a chief architect at IBM Aspera, I lead what's called the core team. So we are responsible for developing the transfer program ASCP and the high-speed transfer protocol we call FAST. So it's with the ASCP program, we're able to do file transfers at multi-gigabit speeds over the public internet. We automatically, the way we do that is through the FAST protocol, which automatically adapts to.
Sorry to interrupt, Ben.
Yep.
I think you have maybe a problem with the screen, with the sharing of your screen. Maybe you can share it again.
Yep, let me try doing that. That's what I thought it
broken. Anyway, I don't know.
Yeah. Okay, let's try. Stop screen. One more time. Share screen. All right, screen 2. Let me know if that's a little better.
Okay, yeah, it's better.
Okay, great.
Thank you.
Okay, cool. Thank you, Philippe. Yeah, so we automatically adjust the speed based on network congestion. So you set a target rate generally, and then we go and we try to achieve it. So many of our customers are moving data from on-premise data centers to the cloud, cloud to cloud. They're doing mass migrations of data, of moving archives of data that were stored in an on-premise data center to cloud data centers. And we support all the major clouds, S3, Azure, Google, and we operate SaaS offerings inside of those clouds, as well as customers can deploy their own transfer servers in the clouds or on the data centers. So we try and move that light so it's not shining right in the background here. Sorry about that. It's sun hasn't come up where I live just yet. So there we go. Let's go to the next slide. Okay, so just a little bit of background about yeah, the sharing really looks bad, doesn't it? About the background of why we do what we do. So TCP has a sort of inherent problem as the delay and loss increase, the throughput decreases very fast. So that generates a problem where data transfer becomes unreliable, and that's really the problem that we solve. So it becomes slow and unreliable. So say you have a 10 gigabyte file, you need to transfer it. One day it might take 5 hours. The next day it might take 10 hours. It might take varying times throughout because of the TCP limitations and due to the loss and delay. So we solved that with the fast protocol, and it uses UDP to send data at the maximum speed. We automatically adjust, monitoring the rate at what the network can do, and we fill the pipe as much as we can. But then we're sensitive to delay due to queuing and other traffic, and so then we'll back off rates or slow down, depending upon what the network is telling us that we can do. So let me go to the next slide. I do want to point out that the way, I'll hit it on the next slide actually. So, and the way that we do the data transfer is the ASCP program works very similar to the SCP program. So what happens there is a client would initiate a transfer. This generally happens on a command line is one way. We also have integrations with web applications, which make this a little bit more complicated because there's more infrastructure needed, more security requirements, and different processes that happen. But I just stick to How is it still bad? Yeah.
Sorry. Yeah.
It's okay.
I don't know if you share the whole screen. Maybe you can share just the slide.
The slide. Let me try that.
It's better because it's really buggy. So we miss basically half of your slide.
Okay. So let me try that, and I will do the. I guess it's this one. I hope. Yeah. Okay.
Okay, we'll see if it's better because we don't see it immediately. Let's see it.
Yeah. Okay, sounds good. All right, thank you, Philippe. Okay, so we work similar to the SCP tool. So ASCP gets invoked on a client machine, and then that through SSH invokes an ASCP on the remote machine. Then some initial handshake and setup is done as part of that. So paths of files, ports, different options. The server replies with some configuration options, some security settings for data encryption, and then we start transferring over the UDP protocol. And as we proceed with the file transfer, we're sending a TCP message here and there to tell the remote side, like, okay, we're starting this file, we stopped this file, and then the remote side's able to put those UDP blocks together into files, and we write them to storage. So storage can be, as I was pointing out in the beginning, local storage on local disks, network storage over NFS or CIFS. We access that as if it were just local storage. Then we also support all the major clouds, and so we will call the cloud APIs to upload multi-part files and write to their storage. And for download, it's the same in reverse. We'll read from that storage and then write on the other side of the transfer. So that's the sort of basic operation of the ASCP tool that we have, and that I hope gives a little bit of background about how we're operating in it and what we're going to be doing in the cloud. So many of our customers are media and entertainment businesses, so they're creating, all the new content that we're seeing on television, and well, not quite movie theaters yet today, but soon movie theaters. back again, and they have pretty stringent security requirements. They need to protect those media files. The challenges they face is, the content is all over the world. They have people working obviously remotely, but then they have new content generated every day. Then that content needs to get processed by different distributors that may exist, different content workflow folks that are editing those files and touching them up, and redoing color and adding different effects and all this type of thing. So multiple authors, editors, storage all over the world. So because these files are traveling all over, there's higher chances for content to be leaked or compromised. And in addition, we hear in the news often that there's a new hack from this company, this customer, this organization has been hacked. And if you're hacked, you need to have some sort of protection. I mean, obviously against a hack, but if somebody gets in, you need to protect your data in a way. So the way that we'll talk about that is some of the mitigation techniques are encryption at rest and forensic watermarking. So with encryption at rest, there's two types of encryption at rest that I'll talk about, and that our product also supports. So we have a client-side encryption at rest, and in that scenario, the individual client says, okay, I'm going to encrypt this data. Here's a password. I'm going to share this file with someone else. And if they want to read the contents of that file, then they need to get the password from me. So there needs to be some way for that password to be shared between the two parties. So the fact that you need to share a password starts to create problems, because where are you going to put the password? You're going to put it in email, you're going to put it in instant messenger, you're going to maybe call them and read the password, and they're going to hopefully write it into the decrypting program at the same time that you're reading it to them, but maybe they're going to write it on a file that's not encrypted. They're going to write it on a Post-it note and stick it on their monitor, or something like that. And so that's going to create, a security hole right there, because you have this clear text password hanging around. So then the other encryption method that we support is the server-side encryption at rest. And with server-side encryption at rest, the end user who's sending the file isn't aware that encryption is even in use. And what they do is the server administrator configures secrets to be set on the files. And as they come in, the files are encrypted. So on disk, they're encrypted. And then as they leave, they're read off of disk, decrypted, and then sent back. And this works quite well, and it's to really help mitigate from content being taken. But if somebody is able to sort of compromise the let's say security of a user's bucket, and they're going to transfer the data with a tool that's going to call those the object storage APIs where the files reside. Well, the files are going to get decrypted anyways. So it really provides you with a prevents you from, say, somebody stealing the disk from somewhere. So then they have that disk and they wouldn't be able to read the data. But if they're using the native APIs that support this encryption at rest, then as files get read off, they'll get decrypted. So we have some techniques to help mitigate that, and I'll get into those a little bit later in the slides. The other mitigation technique that's out there that we support also in our on-cloud workflow is forensic watermarking. And forensic watermarking, what that does is we partner with another company called named Irdeto, and they provide the watermarking services, and we with IBM Aspera integrate with them when we have an on-cloud setup. And as somebody downloads a file, the Irdeto workflow kicks in, and it writes very specific information into these media files that uniquely identify each media file as being downloaded by the person that downloaded it. So each download does require some personal information that comes through the ASCP-based file transfer, and it's actually the web app that they're interacting with sets that information. That information's signed cryptographically, and then we use that to validate it's the person is who they say they are, and then we do the download with the watermarking. Okay, so a little bit more details about the encryption at rest that I was talking about before. So this is the client-side encryption at rest, and so the individuals who share and create the password, and really the idea behind that is that the individual who created the content and who is sending it is the owner. So they're the gatekeeper and controlling the access. And with respect to encryption, the methods that we use for client-side and server-side encryption at rest are essentially the same. We're encrypting the file using envelope encryption with keys that are generated by the user, and then the key generated by the user encrypts the envelope file, and then the actual data is encrypted with a unique key that gets generated at runtime. The client-side encryption at rest can be used with server-side encryption at rest, so you get kind of the double effect, if you will, double encryption. Then the issue really becomes with the client-side encryption at rest is owning the password. Who's going to make up a password that's secure? How's that password going to be shared between the two parties? And that's really the one drawback is that password needs to be shared, and there needs to be techniques that individuals use to share that. So that's our encryption at rest for client side. Let me go on to the next slide to go about the server side encryption at rest. As I was mentioning before, the server owner sets the password, and many object storage providers are actually providing APIs to do this already. So if you, by default, as you write into the cloud, you will the encryption password, excuse me, is set automatically for all the new content that's uploaded. And then many cloud providers give you the ability to use your own key and to pass that in as you're transferring the data. So so that it's your keys that are being used. The problem with that model, though, is if somebody is got access to your host, they're still going to be able to pull the data and get the content decrypted. So what we provide and work with is a feature that's called Bring Your Own Key, where we are going to be doing the encryption outside of what the cloud provider provides. So let me see if I can get to that slide and we can dig deep into that. Yeah. So we have a method, so bringing your own keys. So we'll integrate with, at the moment, we integrate with the IBM Key Protect. So that's a cloud service HSM that's available, and it stores keys securely for you. So the way our flow works is that we integrate with that Key Protect. So we authenticate against it using the IAM, OAuth based authentication. We make a request to get a new key, and that key gets wrapped, and then we use that wrapped key for the envelope encryption. So that's on an upload that will happen. So as we transfer the data from the client computer, it goes through this HSTS node here and then onto cloud storage. And this leg here between the HSTS node and cloud storage, we're doing our envelope encryption outside of hitting the cloud storage APIs. And then when we're done, we leave our envelope file behind. And inside of that envelope file, we have the actual encryption key that encrypts the file on storage. And then when we go to download that file, the request will come into the high-speed transfer server. We'll interact with the BYOK cloud microservice that we developed, and we will get the IAM role to be able to authenticate with the Key Protect. We'll present Key Protect with the wrapped key that we read from our envelope file. The Key Protect will unwrap the key and give us plain text, which will then be able to use to decrypt the envelope file. And then inside the envelope file, we will get the actual encryption key, and then we will decrypt the bytes and send them back to the client computer. So the advantage of this is we have the keys being secured by the HSM in the cloud. We also have rotation that can happen. So as the policy of the HSM says, okay, let's rotate our keys every, say, 30 days. We lazily support the decryption of an old password with the newer key. So this way you can rotate your keys, and we call it a sort of lazy rotation, so that as somebody reads new file and downloads it, and it was encrypted with say V1 of the key, we'll fetch V1, and then we will encrypt it with V2 of the key, and so that way the content gets password gets rotated lazily. We also do support the rotation of the keys in a more at one time, but then that is going to require some downtime. We are using the envelope encryption, so we won't have to re-encrypt all of the data, but you will have to re-encrypt all of those envelope files. So if you have hundreds of millions of files that you're storing, that can take some downtime while you're doing that. The other way to go about it, and we have some customers that actually work in this way, is they have policies in place where they are going to rotate their key on a kind of emergency basis. So they're under the impression that they've, or they're under the real impression, or, that they've been hacked in some way, that their key's been compromised. And so in that case, they want to actually destroy all the data on the cloud and remove everything and upload everything new, so that it's none of the content is available. So that's sort of in the extreme case, you know, rewrap everything and re-encrypt everything. So that's our bring your own key architecture, and that's how we're solving the server-side encryption at rest. The other advantage we have to this is we do have different algorithms that will add as you know, more security comes. For example, we're working with the team at IBM on quantum computing and having quantum safe algorithms available to do data encryption. So we're a little bit more responsive than maybe some of the cloud providers to roll these things out onto their clouds and make them generally available for everyone. So that's another advantage that we have against the default server-side encryption at rest. So let me see, I'm going to move to the next slide here. Okay, so a little bit about forensic watermarking, and then I'll sort of wrap things up. So as I mentioned before, forensic watermarking, it's used for piracy protection. Unique signatures are embedded in the file, and piracy can be traced to a specific person or entity, or identity, excuse me. So, for example, we have the case where you have a live sport or video on demand. That content gets created, the fingerprint gets created, and the watermark gets embedded into that file. So that's part of the preparation output setup. Excuse me. So that file ends up uploaded onto the cloud through the IBM Aspera cloud application, and so now that that watermarked, it's called a variant, a watermarking variant, it exists. So that's really in this preparation step. So once that variant exists, then I'm going to say share that content with other users, and they're going to download that content. So that's what the this next little portion is about, is downloading that content. And so that's where that fingerprint gets created. It gets dynamically embedded into the video file as it's being read. So the process is our ASCP client starts reading the data from the cloud service provider. We pass those bytes to a Erdetto cloud service that we're integrated with, and we transform those bytes with that variant file, and we write the watermark into the video file, and continue the download. Then once the file's downloaded, somebody would play the video, and they don't see any watermarking in the actual file. So the file doesn't have a watermark that actually shows up on the video file. It's embedded into the video content. So then, as the content creator, I'm looking to secure my content. I want to make sure it's all hasn't been compromised. So I can crawl the web looking for my file and try to detect it. And I can verify that the every file that is found is watermarked, and I can also find out who was the person that downloaded the file. So then I can take some actions to try to mitigate the loss of data, if there is loss of data. So let me get into a little bit more of how that architecture works, and then we'll wrap things up. So the way it works is the end user will update, will send data to the IBM Aspera on Cloud application. So that uses that ASCP tool that we were talking about. It will get stored on object storage, and when I submit that file, I specify that, yes, we want this file to be watermarked. So that's in the initial step and the initial upload. When we do that initial watermarking, the Erdetto service is called, and this variant file is created, and that is used as part of there's a single variant file that's created for all the downloads of that file that we are uploading here in step 1. So the variant, yeah, that's in step 3. So then after I've done the upload, that file is available. I notify the folks that I'm working with, or they find the file by browsing through the IBM Aspera Files app, and they say, oh yeah, this is the file I want to download. Great, I need to work on it. I need to add, fix up the coloring and add some new visual effects. So they will download that file, download that package, we'll call it. And as that's downloading, the Erdetto service is engaged. We read the bytes from cloud storage. We send the bytes to the Erdetto service. It transforms them, and we sort of stream the file, if you will, through the Erdetto service, through our FAST protocol, and then down to the end user that gets the uniquely watermarked package. So in this way, to sort of summarize things, I'll go to my last slide that says questions, is the way we are dealing with secure workflows is the encryption at rest on the server side, as well as the client side, but specifically the server side with the bring your own key, and integrating with the HSMs in the cloud. At the moment, it's IBM Key Protect, but we'll be working with other cloud providers to integrate with their cloud service HSMs that they offer. And then the other way that we're doing is with the forensic watermarking, which gives content creators the ability to secure their data by being able to track who has downloaded it, where that file exists on the internet, and mitigating anything that may come up if they find that their file's been used illegally, say. Okay, so that summarizes things. Hello, Philippe, and thanks for. Thank you, everyone. And if there's any questions,
Yes, yeah. I have a few questions,
okay.
and that's pretty good as we still have time, so that we're all good.
Okay.
Okay, so we talked about for the server-side encryption at rest. We will talk about the key rotation, which is really important as it brings really the security, and it's really important to have that periodic rotation. So how do you handle this key rotation?
So the way we do it is we integrate with the HSM and that has APIs that take the key rotation as part of their API. So if I submit a V1 of a key, then the HSM will respond back with the wrapped key for version 2. and then I can use that wrapped key to rewrap the data that I want to encrypt. So I'll get the V1 plain text returned. I'll get the V2 that I can use to wrap another key so that I can re-encrypt the data with the new key by presenting the old key.
Okay, and this is managed. So this is pulled by the service who will need it, or it's from the central service that will push it to the different services?
It is from the service that is hosting the keys. So that service that hosts the keys has REST APIs that when I pass certain key material to it, it accepts it and says, yeah, I have the matching wrapped key for this, and then it will perform the unwrap operation on it, which will give me the plain text key that I can use to do encryption. So then if I present a wrapped key to it that's been rotated, it will say, oh, hey, I'm going to give you version 2 or version, X plus 1 of this key. So now you can use that version of it to rewrap, to re-encrypt your data. But at the same time, I'll give you the plain text for the old key, if you will, so you can decrypt the data that you have. And so that's the process that it goes through. And we and the Key Protect API is providing that for us. So we're taking advantage of what is there. If you didn't have that rotation available at that time, it makes it very difficult. Because then it puts the onus on you as the customer to manage those keys on your own and have to deal with rotating them. And then how do you have to have many versions of the keys hanging around. And if you have hundreds of millions of files, then you have to have that downtime and go through and re-encrypt. So it's a nice feature that the Key Protect has the different versions of the keys and can handle the rotation for you. But nevertheless, we did have it come up in security reviews that they're like, hey, we're rotating and we're getting rid of this key altogether, and so that we want to, for data breaches and that kind of thing. So
okay, great. Another question is how fast I can run a cloud-to-cloud data migration.
How fast is the internet? So we've done demos of about 100 gigabits data transfer between the Amazon cloud and the IBM cloud. We did, I think it was from Amsterdam to the US East cluster, I think, which is in Dallas. In Washington, D.C. And so the way we do that is we can parallelize our transfers and use multiple machines. And so we can run transfers at very high speeds by parallelization and running multiple ASCP processes. And each one of those file transfers can go at up to 3-4 gigabits at a time. And so multiply that times the sort of infinite scalability of the cloud, and if there's enough content, then we can just get faster and faster. We just need more compute, and we're ready to go. Yeah.
Okay, we have another question, which is how do you crack pirated media with watermarking?
Yes. So with the pirated media, what you need to do, the one sort of drawback is it's up to you as the content creator or owner to find the pirated media. So you have to start crawling the web. You have to invest a little bit in knowing where this pirated media may end up. And then once you do that, then find the files, and you can identify them and see what they're, well, one, if they are watermarked, and then two, if they're watermarked, who was it watermarked by, and then take the steps to mitigate it. But yeah, you'll have to crawl the web, crawl the dark web, perhaps, and find where this content may be living.
Okay. And one last question. As it's all that security topics are really critical today, and as developer and also as architects, when we are working on our solution, building our architectures, it's always hard topics, as if you're not specialist in that, but you want to go deeper on that and try to learn things. Do you have for beginners some advice on where to start and where to find good resources on that?
For security, it's a journey, certainly, and there's always new things coming up. So for a beginner to get started in learning security, I guess, you can maybe start with just learning about file encryption and the different ciphers that are available, and reading up on the different techniques. So the technique that we use is called envelope encryption, and what that does is for example, the file that gets encrypted, you have a so-called envelope file that contains the actual key that encrypts the data, and then the envelope files is encrypted with a different key to encrypt the key that actually encrypts the data. So that's a starting point. So you could read up on envelope encryption and the different ciphers that are available. So the AES is, I think, would be the sort of typical standard cipher suites that are used today. The GCM variant of AES, so the Galois counter mode, it's called, is a newer version of the AES encryption that provides much better performance. So with security, there's always a little bit of performance hit. But the GCM mode, its performance is really good. And then if you're really bold, you can start reading about quantum safe computing, because with the quantum computers, the time to the raw computing power, I guess, that you're going to have, you can try hundreds of millions of combinations in seconds. And so reading about quantum safe computing would be, I think there's a lot of resources on that to kind of get started and learn a little bit.
We had an introduction on track one this morning.
Perfect.
But it will be available on the replay for those who haven't seen yet, so that's pretty good. Okay. So thank you, Ben. Really, thank you for your session, and thank you for joining us so early in the morning for you.
Thank you much.
I can guess it was hard for you too.
I didn't want to.
Now the best part is that you have free time to go enjoy the snow.
Exactly. All right. Thank you very much for that.
Okay. Thank you very much, Ben.
Okay. Bye-bye.
Okay, and so we are just going for 5-minute breaks, and after that we are coming back with a session from Shelby's Please, where we will talk about good recipes and good practices to shift left on production excellence. So be sure to stay there and just grab your coffee. We are back in 5 minutes. Okay, so we are back. So for the moment, Shelby didn't join the live, but we saw her on the Discord. So I think she will arrive pretty soon. So before she arrives, I can introduce her, and hopefully she will arrive very quickly. So okay, so I have a fun fact about Shelby to share with you. So that before being a software engineer, oh, okay, Shelby, you're here. Welcome.
Thank you so much.
How are you?
Good, good. Apologies for the brief delay.
Yeah, no problem. We saw you were connected on the Discord, so we pretty much know that you will arrive. No problem. So I was just saying that before going back to school to become a computer engineer in computer science, you lived in Tokyo actually, where you were. Yeah, you want to.
Sure, yeah. I
Yeah.
I actually studied Japanese as part of my linguistics degree in undergrad, and so after I graduated, I went and taught English in Tokyo, and I worked as a bartender. And so I got to practice my Japanese as well. And it was a really good experience, but I also learned that bartending and the conversation sort of one-on-one teaching lessons that I was doing, it wasn't how I wanted to make my career. So I decided to go back to school and study computer science. But I love teaching. I love talking to people, and so I ended up becoming a developer advocate.
Okay, great. So we are really glad to have you here. So you will give us some good practice and good tools to help us improve our service reliability and relieve all the stress linked to that. So okay, so I let you the stage. I don't know if you want to share your screen or something. You can go ahead. Yeah, sure.
There it is. There we go.
Yeah.
Great. So thank you so much. Welcome to Think Prod Up Front, Shifting Left on Production Excellence. And I'm Shelby Spees. I'm a developer advocate at Honeycomb. I'm really excited to be here today. Hello from Los Angeles. It's 5:57 in the morning. So good afternoon to everyone in Europe. So let's talk about how getting paid can be scary. More teams are putting developers on call for our services in production, which I think is really great. It's really important. It's the best way to level up as an engineer, and that production ownership is super important. It helps us build better services. But getting paid can be scary. It's hard to know where to start for debugging and investigating. Playbooks become outdated quickly, and our mental models are incomplete, especially because production is becoming increasingly complex. In the cloud native landscape, there's so many moving parts, external dependencies, emergent failure modes. Even though we've come a long way, and we have automation and tooling to help us with things that used to be manual and error prone, we've made our software services more reliable, and we've eliminated many of the catastrophic single points of failure. So we no longer have to wake somebody up in the middle of the night because a single host became unhealthy. But we're always encountering new problems because our distributed cloud native systems fail in these interesting ways. We can't predict them in advance. I call them emergent failure modes, and it's something that the reliability community and the resilience engineering community talks about a lot, is these unexpected, tiny failures that cascade together, sort of line up and bring down your entire service or degrade the whole experience. And so it's often not even the latest change or some isolated change, but it's maybe the latest change interacting with some change from 2 months ago or a change that only affects certain kinds of traffic, some subset of users. Or oftentimes it's like the ground shifting underneath us, some external dependency change, and now we have to scramble to update our API calls or configuration, things like that. And on top of that, a lot of our tooling is kind of inscrutable. They don't answer our questions. our graphs speak the language of individual hosts, but that doesn't tell us where in the code is introducing latency, which one of our microservices is having is increasing the error rates. It's much harder to narrow that down, and so oftentimes responding to incidents is like looking over here at this window, squinting at our graphs, looking at the spike, lining up the timestamps, and then going over here and querying in our log aggregation tool, trying to find some log that lines up with the graph that could possibly be related. And we end up going down rabbit holes, chasing down red herrings, doing guesswork, what I call armchair debugging. And so we'll roll out experimental fixes with little data to back up our hypotheses. And sometimes, a lot of the time, we'll introduce even worse problems with these fixes. And so even and the thing is, like, even when you recognize, you're like, I know that graph, that's telling me it's Redis. We don't often have the log granularity in production that would be able to back that up. So it can be hard to feel confident about the changes we're making. And we can't often improve on this situation, this firefighting, because there's always pressure to ship fast. It can feel like we barely have time to finish one project before the next deadline crops up. And so we can't invest in reliability, in paying down tech debt, in refactoring to make our code more maintainable, or making upgrades and like architectural improvements. Most of us are open to doing maintenance work, optimizations, or refactoring, but seems never to be dedicated time for that on the schedule. So because we're always fighting fires and dealing with interruptions, we're constantly in this reactive state. We don't get time to improve things. The seniors on our team are spread thin. They can't safely go on vacation. We lose trust with management, leadership, and the business stakeholders because our time estimates and roadmaps always go out the window. And newer team members are kind of kept out of the loop because seniors have no time for knowledge transfer. They're just always firefighting. So it's kind of painful for everybody on the team. And I've been in several of these situations where it's just, I either have to like pull teeth to get information out of the senior teammates' heads, or I'm the only person who could possibly solve this and I can't look away. But it doesn't have to be this way. If we think about production up front, if we approach our changes scientifically, we can do things, it can be a lot less painful. We can feel more confident, and we can have a better relationship, more trust with the business stakeholders at our company. I think that being scientific starts with releasing changes gradually with progressive delivery. For those who aren't familiar, progressive delivery is a process of releasing changes first to small, low-risk audiences, and then expanding out to larger and riskier audiences. And that allows us to pause or roll back if we encounter issues. And feature flags make that really, really easy. They allow us to separate deploys from releases and manage that blast radius of changes. And because it's a configuration, it doesn't require a deploy, we can flag flip and enable or disable specific code path. It only takes about 30 seconds to propagate across all of our environments. So it's much faster than even like a really fast deploy of like 10 minutes. And so when you have this tooling that allows us to limit the blast radius of changes, to be very intentional about our changes, that enables us to move faster. I learned a while back that many of the world records in racing and race car driving were set and broken after major improvements in brake technology. You would think it's like the gas technology, the engine technology, but no, the being able to brake more safely and slow down enabled drivers to feel more comfortable going fast, and turbo boost. I don't know anything about cars. Turbo boost their engines to go faster. And so when we add guardrails around our releases, it enables us to ship faster without waking everybody up in the middle of the night, without having to do firefighting all the time. Safety enables speed. And LaunchDarkly, which is a vendor who provides feature flag feature flagging service, and we use LaunchDarkly at Honeycomb. LaunchDarkly did a survey and found that teams that use feature flags deploy more often, release changes faster, and they also are more likely to have a short time to recovery because they're able to turn off that feature flag if it turns out to be an issue after releasing. But I think it's important to remember that velocity is only part of the equation. Without tight feedback loops, we're just quickly making a mess. So we need observability. Observability in software is the ability to understand or explain any state a system can get into, no matter how novel or bizarre, without deploying new code. This isn't about going in and changing a log level to debug in production, or going in and adding new timers around the blocks in your code that you think might be introducing latency, and then having to deploy that new metric. Observability is about the ability to answer new questions using the same data we've been capturing all along. And observability helps us solve these hard to debug problems, investigating production issues. Like most of the time, we're trying to answer this where question. Which microservice is introducing these latency and causing downstream effects, or which subset of users are having the worst time? Is it just like users who have a lot of large data attached to them that we're starting to see like performance issues in these N+1 queries? And so aggregated metrics and canned dashboards don't answer these. We need to be able to break down on new intersections of data. And so we can gain observability by capturing that context all the time with a lot of like detail in the form of key value pairs in these sort of data blobs where you can add arbitrary fields. You can add like, hey, maybe for my checkout service, I use PayPal and I use Stripe. Well, I should capture the payment service that I use. And so I include that, PayPal versus Stripe. And I can query and see like, hey, is PayPal having a worse performance than Stripe? Is it more likely to return with errors? Let's break down on that, because that, those are the kinds of questions we need to be able to ask. And so in order to be able to interact with all of this context we're capturing, we need tooling that supports querying in near real time, interacting with all of these fields in near real time, so that when you release a change or when things change like dynamically in production, you can immediately go query for it and see actual user traffic interacting in that change. And so progressive delivery and observability really go hand in hand. It requires some investments in tooling and some cultural changes, but it's really worth the effort because it allows us to protect ourselves from burnout with less firefighting, allows us to ship faster with more confidence, and you'll find that it enables us to have better conversations about the decisions we're making, which allows us to gain more trust from our business stakeholders. So at Honeycomb, we practice observability-driven development. And that starts with instrumenting as we code. For each change, we ask, well, how is this going to behave in production? How will I know it's working? How will I know specifically that it's not working, that's not going to fail silently? And so we add instrumentation for that. And oftentimes we'll go and observe before we even start making code changes. What is the instrumentation around this change already look like? What's the status quo? And then we can compare that to the new instrumentation we're adding and the new changes we're making. And we don't stop there, right? We lean on our tests to give us confidence long before the code hits production. You need both meaningful tests and rich instrumentation. And so I've already talked about feature flags. We specifically design for feature flag deployment. We intentionally factor our code to make it very modular and make our changes very isolated, to make it easy to both introduce new flags and also clean up our existing flags once we don't need them anymore because the change is finished rolling out to all of our environments. And so that's one of many, many good reasons to write modular code with few side effects. We use Circle CI to build on push for every branch. And here you can see this is an actual honeycomb build that we've instrumented to generate traces. So we don't only instrument our production code, but we've instrumented our build pipelines to send their data to Honeycomb, which has made it possible for us to find bottlenecks in our builds and tighten those feedback loops even faster. And that's how we got our build times down to below 10 minutes consistently. So once the build is green, we perform human review as well on every PR, even the seemingly trivial ones. That way we never need to question, well, should this get a review? How small is too small? We just blanket review all of them, and then we can be confident that we've covered our bases. Once the CI is green and the reviewers have approved a PR, we merge. We want each developer to push and observe those changes while the context is still fresh in their heads. And feature flags allow engineers to merge and test across environments on their schedule, and then they can work with our product team to roll out that change gradually to our customers. It also makes trunk-based development much, much easier and allows us to avoid many merge conflicts and rebasing. That whole just separating release, separating merge from merge and deploy from the release process really makes things a lot cleaner. And we use continuous deployment because deploys should be boring. I consider any deploy that requires manual intervention to be an incident. We should sit down and discuss how do we make sure, what happened and how can we prevent this possibly from happening in the future. I think any manual intervention in that case is worth discussing. And finally, we bring it full circle. We observe the behavior of our change in production using the instrumentation we added at the beginning. We check right away, and we also check a little bit later to see how it's behaving with real traffic and real users. And so our production environment, well, at Honeycomb, we have several different environments, but we deploy a single build, a single binary. The same code runs across all our environments. The only difference between the environments is whether our feature flags are enabled or disabled. And we also have user-specific or team-specific feature flags, as well as A/B testing sort of buckets. But we often will deploy things in certain environments. And so our production environment is where, not deploy, enable, excuse me. Right. So Honeycomb's 3 environments. Our production environment is where customers send their data in order to observe their own systems. And then we also have a second environment called dog food, where we send the telemetry from the production environment. And so, like I said, dog food's not a staging environment. It runs the exact same build as production. And dog food allows us to query our production telemetry the way Honeycomb users interact with their production telemetry. It helps us as a team build user empathy, and it makes it easy to test out experimental features. So we'll often enable feature flags in dog food for testing internally. And because we use dog food all the time, we're actually pretty good at testing it. And then we have a third environment called Kibble, where we send our telemetry from dog food. And so for those experimental features that we enabled for internal testing, that telemetry gets sent to Kibble. Features get tested for days or even sometimes weeks in production before being enabled for customers. And this is what we mean when we talk about testing in production. It's not about YOLO deploying a risky experiment to your biggest customers with no QA. Really, it's the opposite. It's a slow rollout process. Because we've separated deploys from releases, it allows us to reduce the number of variables with each rollout. So a big feature release is no longer blocked by a bad deployment. We've usually already deployed it days before we flip that feature flag and enable it all across production. So you can, this sort of very granular breakdown, for me, I'm a developer, I'm working on a new feature, and I'll often enable it. I'll merge the initial change wrapped in a feature flag, and because we care so much about continuous integration and continuous deployment, each of my PRs might be small, but they're all self-contained and I'm not going to break the build. So I can gradually build up my feature, enable it for myself in dog food, and observe that in kibble. And then, once it's solid, I can enable it for the rest of the honeycomb team, all my teammates, and observe how they're using it, and start to notice those weird, emergent user-directed sort of failures and errors and weird, awkward user experience things. And so then once probably simultaneously, while the honeycomb team is experimenting and testing it out in dog food, I've enabled it for myself in production because I want to make sure that there's nothing unique about our production environment that introduces some wrench into my code path. And so we actually do a lot of we've done a number of feature flag experiments and feature flag wrap changes on our infrastructure in our configurations. And that allows us to make sure that as we roll out infrastructure changes, that we can be confident that there's not something unique about production that throws an error. I don't know the number of times just something it's impossible to reproduce in your local environment or in your QA or staging environment. Sometimes you have to see it in production. So I enable it for myself, enable it for the internal honeycomb team in production. And we have our sales team has a demo data set. We have a lot of developers who have their own test teams in our production environment. And then we can enable it for beta testing purposes. We don't always do beta testing, but especially on our bigger feature releases, our product managers will work with customers who've asked to be included in beta testing. And then finally, by now we're so confident about this change that we can enable it across all of our production environment. So I don't know about you, but that's the opposite of YOLO, right? We're being very, very careful and intentional and being very scientific about each of these changes and looking and, like I said, isolating those variables. And I think this idea of working with our product teams is really important because the technical decisions we make don't happen in a vacuum. From our architecture to our data models to individual lines of code, each implementation detail is a design decision. And I think as software practitioners, we have a lot to gain from this perspective. It can be difficult to map our engineering efforts over to business impact. So how do we know that we're doing a good job? And sometimes it can feel like we never get the opportunity to work on the things that we feel are most important. We're boots on the ground, sharp end practitioners. And we, sometimes it can feel like, we really should, stop pushing these features and spend some time paying down tech debt or spend some time on refactoring because this, this part of the code base drives me nuts. And it's really, really hard to follow. And I waste a lot of brain cycles trying to make sense of it. And so, or sometimes we just see an opportunity to try a new language or technology and we feel really strongly about it. But any of these situations, we can be met with skepticism, right? People tell us, well, we need to think about the needs of the business. And so we need to be able to answer the question hey, if I want to try Scala or Haskell for, this new service, or if I want to spend a couple weeks or a couple sprints paying down tech debt, how does this drive the business forward? And so this is where service level objectives can be a huge help. Service level objectives, which are abbreviated SLOs, they represent a common language between engineering and business stakeholders. And they help us define what success means according to the business and help us measure it with our system telemetry throughout the lifecycle of a customer. And so we need to think about events that have customer impact that are in the business context. Excuse me. So events that are relevant to the business. We want to know whether the homepage loads quickly, whether user run for Honeycomb, whether user run queries return results fast, or probably our most important, that the data that customers are sending us that we're ingesting we want to make sure that it's stored successfully and quickly in order to get that near real-time observability. And so these are sorts of things that our product managers and customer support teams will often ask about. This particular user is complaining that things aren't loading for them. Is it just them? Is it that service? Is it their internet provider? Like how do we isolate this? And so because we're already capturing all of that context at runtime, we're collecting it all the time. We're able to measure good or bad on each of those things. And so then we defined a service level indicator, an SLI, to categorize our events into good and bad buckets. And so I missed a step. We set a threshold, for example, that your homepage should load within 300 milliseconds. And for each individual homepage load, the SLI determines, was it a good homepage load or a bad homepage load? Was it a good ingest event or a bad ingest event? And so that's for individual events. But in order to measure risk, we need to look at the overall, we need to look at the big picture. We can't just say we had a major outage on Monday, but we've had 100% uptime since Tuesday, so we're safe. Well, it's only Thursday. So our customers still remember that pain from Monday. We need to calculate, we calculate what percentage of events are good over some time window. At Honeycomb, we like to use 30 days, but we recommend at least 7 days and up to 90 days. And so we can, for that time window, what percent of our relevant events are considered good. And so the example SLO for Honeycomb's homepage loads is in the app is we want 99.9% of homepage loads in the past 30 days to be fast enough, where fast enough is that good or bad threshold that we've set. And so why 99.9%? Why not 100% or 99.999%? Well, a good SLO just barely keeps our users happy. It keeps our users just happy enough. Each additional digit at the end of our SLO is an order of magnitude more effort to maintain. And it's often not even worth the effort in situations where people are willing to hit reload. A little bit of buffering when you're watching a YouTube video or a stream, it's not the end of the world. And so your job and our jobs as engineering teams working with our product teams and our business leaders is to determine how many reloads or how much buffering is acceptable before users will bail and go to the competitor. And so what's nice about this is it allows us to budget how we spend the bad events, basically. Once we've defined our SLO, that remainder, that 0.1% for my 99.9% example, it allows us to spend those either on planned experiments like chaos experiments, or spend them on unplanned things like, an emergency fund, basically, an error budget emergency fund. And so, for example, if I'm serving 1 million total requests per month and I'm aiming for a 99.9% SLO target, that means I can have 1,000 events fail for those types of events for that SLO. And so just like a financial budget, right? The error budget gives us some wiggle room, which we want in case there's some problem like outside of our control. And that error budget is what tells us when it's okay to take risks. Error budgets don't roll over at the end of the month. It's like keeping extra cash under your mattress instead of investing it or putting it in the bank. You don't want to let your error budget go to waste. And so if you have extra error budget, that's the time to perform experiments. That's when you can release the chaos monkeys, or that's when you can start taking risks on, new technologies, new infrastructure, or major changes. But I think it's also important to think about when it's not okay, right? When we're firefighting, when we're being woken up in the middle of the night a lot, you shouldn't be You shouldn't be taking risks when your error budget is tight. And so if you've had a lot of recent customer-facing incidents, if your engineers are feeling burnt out and spread thin because they're getting paged so often, even if it's not directly impacting customers, this is a time to invest in reliability and paying down tech debt. And so now it's a lot easier to point because the SLO definition is an agreement. It's like a contract between the engineering teams who measure it and the business stakeholders who help define it. You can point to the measurement and say, hey, we're running out of error budget. We probably should slow down our feature development. And maybe invest a little bit more in reliability. And now we have the data to back that up, and we can say, hey, this is the best thing for the business. And so here's an example of one of our SLOs at Honeycomb for ingest latency. Like I said, we're ingesting the data that our customers send us, and we want that data to be available fast so that people can observe their systems in near real time. So over the month before I took the screenshot, we've been well above our target for ingest latency. But the interesting thing is the budget burn down graph on the right side. The steeper the line, the faster we're burning through that extra budget. And so we can actually see, depending on the steepness, depending on the slope of that line, if we're burning through the budget faster, well, we should probably alert somebody, right? There's maybe some issue that's cropped up that has caused an increased error rate or increased latency. And so if we're going to run out of error budget for the month in 4 hours, that's when we should page somebody. That's when we should wake somebody up. If we have 24 hours, maybe raise something in the Slack channel, and then somebody can investigate it in the morning. And if it's days, well, raise something in the Slack channel. We can open a ticket and get to it when we have a little bit of spare bandwidth. And so it makes it also helps us just really prioritize where we spend our time, because we can see how urgent each of our issues is. And so I know this is a lot of math. Maybe the math isn't super scary, but it's a lot of data and it's a lot of terminology, and it can feel kind of intimidating, like, wow, how do I even start? But I want to tell you that this isn't limited to, the Googles and the Facebooks and the Amazons of the world. Like every engineering team can do this. It's not off limits. And so I want to tell you that you can do this too. And you deserve to have tooling and practices that support you and help you prevent burnout and help you have a better business impact. And so start by dipping a toe in the water. There's a lot of instrumentation libraries have auto instrumentation for popular frameworks for HTTP requests, for database queries. And so you can start with one app or service. And I learned a while back, it's a good idea to start in the critical path, something that's central to your business, because there's not a lot of risk in adding instrumentation. There's not a lot of risk in adding instrumentation. It's a relatively isolated change, and it doesn't affect. It's something that you can test from your dev environment, and it doesn't have a major effect on performance. And then you can deploy a canary branch, or deploy to your staging environment. Just like, how do you want to be able to map the telemetry data that you're generating from dev and look to see how it's different in different environments. And what I love about this process, especially with tracing, is you start to learn. There's all this low-hanging fruit that's like, whoa, I didn't realize that we were querying this so inefficiently, or I didn't realize we were making that many calls to Redis. And so there's a lot of immediate improvements that you can make just from seeing like the shape of your data in across different environments. And I recommend trying out OpenTelemetry, which is a vendor-neutral open source instrumentation framework in a number of languages. And the tracing spec recently announced general availability. And so people have been using OpenTelemetry in production for probably a solid year and a half now, maybe longer. And so now we can say that the tracing spec is not going to change. The API is staying the same, and we're all of our instrumentation is all of these SDKs are hardening. So it's a really exciting time to try things out. Start with auto instrumentation and build from there. And so building is starting to add those custom fields, starting to fill in the blanks when you see a trace and there's some like, big empty spot and you're like, I don't know what's happening inside of this. Well, that's where you can go in and maybe you have some library code that's specific to your application, or you're making some third-party API calls that you want to wrap in spans. And so that's where it makes a lot of sense to start filling in the blanks. Another way to approach it is to instrument where there's risk, instrument where, like, as you make changes. It's sort of like the Boy Scout rule where leave things better than you found them. And you can sort of do that with your instrumentation. And when you the other nice thing about tracing is because you can have framework level instrumentation with tracing, it doesn't litter your code the way log lines or metrics, application metrics will. So it ends up being like a really nice ergonomic approach to adding instrumentation. And if you don't know where to start, I really recommend instrumenting your builds. It's probably the best ROI return on investment for like the level of effort versus like the you're going to get so much out of it because shrinking your build time gives you tighter feedback loops, and it makes your team just so much more productive. It's really the catalyst to so many other improvements. Time to the time between merging and your code being live is one of the 4 DORA metrics for high-performing engineering teams. The shorter the time that your code being live, the higher performing your team. And you can really start with that and build on it to just improve your whole team's productivity. So that's kind of all I have for now. I'd love to discuss and answer some questions. Reach out. I'm on Twitter. I'm very much on Twitter. And if you would like to download these slides, you can go to honeycomb.io/Shelby.
Okay, really nice slide, by the way.
Oh, thank you.
That was pretty nice. So yeah, this is really interesting. All the details you gave to reach that observability, it's really key to today's infrastructures and solutions. So, but the question I have is that imagine the case where you are in a small team. You see that it's key for you, as you already saw you have some problems, but it's hard to identify and have that clarity. So regarding the fact that I'm in a small team or I have a small bandwidth for that, how can I start improving observability?
Absolutely. So like I said in the last couple slides, starting small and building up, starting with just one core service, the place that either the best is often a good place to start. Or if you don't have anything else, you can you have access to touch. Like on my last team, I was a DevOps sort of infrastructure engineer, so I didn't get to go in and mess with the platform code as much, but I could go in and help make our builds a little bit faster. And so that's a really good place to start. But yeah, I would say just like see what auto instrumentation is out there, because you do get a lot out of the box, and it really helps to just like get over that first hurdle, because it's definitely a mindset shift going from like flat logs or from our metrics, time series graphs, to distributed tracing and to structured event data. So just starting with what's there, and if you're not sure, I actually hold office hours, so you can reach out to me, and whatever your team's trying to work on, I can help you find sort of the best way to get started.
Okay, great. Okay, next question is, how do I get my teammates to try out these new tools and approach?
Yeah, it's always a tough question, right? Because if you if you like hype it up too much, then people become like skeptical. So I usually, what I recommend is finding like pain points that's common on your team, that people are familiar with. And once you've even just trying things out, like in your dev environment or trying things out on like a side project, if you don't have approval to change it in your own in your work code bases, showing like, hey, remember that outage we had the other week, or remember that like bug you spent forever tracking down? Look how easy it is to find with observability. Or remember that time we had to like, wait 45 minutes for the deploy to roll out, and then there was immediately a problem that we didn't, anticipate, from our QA. And we had to wait another 45 minutes for it all to roll back, and we were just sitting there like biting our nails. Like, wouldn't it be so nice to just use a feature flag? And so putting it in context of like, what your team has experienced can really, really help with that.
Okay, great.
Mm-hmm.
Another key point of your presentation was that service level objectives, as we need to define good service level objectives and also track it and build our strategy based on it. So, but before defining, we need to define the good objective on that, and how can engineers get company leadership on board with that service level objectives?
So I was really excited about the SLO book by Alex Hidalgo, because it goes into a lot of detail about that. I think it was chapter 6. That's just like, here's your plan, and it's like step by step. Talk to engineering first, then talk to product, then talk to leadership, then talk to QA. It was a really, really nice breakdown. So if you want it in detail, I recommend taking a look at that. But yeah, basically just starting with if engineering is on board, because they it reduces pain, allows them to like sort of make better decisions. If your operations teams, if you're in an environment where like you have that sort of DevOps divide, right, which many teams do, even if they on the surface they say they don't, and so the people who are writing the code and the people who are responding to incidents, if all of them are on board, because now you're with service level objectives, we say, hey, developers can release whenever they want, as long as we have the error budget for it. And then operations teams can tell developers to stop releasing new features if we run out of error budget, right? And so that sort of agreement there, starting with that, is a really good place to start, because then you can take it to leadership and say, hey, I've already gotten our dev teams, I've already gotten our ops teams, and I've already gotten our product team on board, which product wants to know that, dev and ops is on board with it. And especially with another situation, this is really where service level objectives go so well with the progressive delivery, with observability. It's all part of this sort of new, like, modern approach to building software. We call it production excellence. And so getting several teams on board and sort of planting those seeds, dropping some articles in Slack, getting people to talk about it. If you have enough of that momentum, then by the time you take it to leadership, they'll be like, oh, everyone's on board with this. Let's try it. Like especially if you put it in terms of like engineers are going to talk in the language of the business, and the business will be able to talk in the language of engineers. And I think that is a big gain for a lot of teams.
Yeah. And also the the hardest part, when we decide, okay, we'll define our SLOs and we'll start working on it, base our plan on it. But when you're around the table and start to say, okay, let's define it, how can you start defining it actually?
Yeah, so there's two sort of requirements, and I like to think that at Honeycomb, we have an SLO feature as part of the tool, and we recommend people get comfortable with their code, learning the kinds of data that comes out of that, and getting really comfortable with querying, at least having the engineering teams become comfortable with querying and interacting with that data, because it helps you define sort of on the like service level indicator, what makes a good event versus a bad event level. It helps you define that more accurately and know like the kinds of data that you could define it with. So I think starting with observability and good instrumentation and learning what your tooling is capable of is really important. But then also just like what kinds of things should we define as SLOs? Ask your product managers. They know your user paths. They know like the core, we call them service level objectives, but really when you have like microservices, a single user path can have like many network hops, right? So it's not so much like, this particular bit of checkout microservice gets this really tiny SLO. It's like, the checkout experience and, the calling out to the database and calling out to like our payment provider and all of that stuff, making sure we send the email correctly and things like that, for example. And so putting it in terms of like that user path is really helpful. And so then you can, because you're familiar with your instrumentation, you can say, hey, I know how to measure that. And you can start working with that.
Okay, great. So thank you very much, Shelby.
Yeah.
So as you said, maybe if you're on your last slide, there's all the information to reach you. If someone else still have some question about it. So thank you for joining us for that first edition of the TheCloudFirst. It was a pleasure. And for all the attendees, don't forget to give your feedback on the session, as this will be really valuable for us as organizers, but also for Shelby as a speaker, to have your feedback on it, and you will have a chance to win your own tickets. Thank you very much, Shelby. And for us, we'll come back in just 5 minutes. You have 5-minute breaks to bring some coffee or some dessert. I don't know if you didn't have time before. And we are just back in 5 minutes for the next talk with Joel Lord. And welcome back on track 2 of the TheCloudFirst. I'm here with Joel Lord that joined us. Hi, Joel.
Hi.
How are you?
Very good, and you?
I'm fine. I'm fine. Okay, so before we start your session, you told me something interesting about you. Is that you studied astrophysics? You had a degree in astrophysics before getting to software development, right?
Yeah, exactly. Exactly. I actually studied computer programming a little bit, and then I worked for the government, and I hated that, like absolutely. So I decided to go back to school in astrophysics.
Okay.
But then came back into
Maybe
programming.
if you had continued, you may be the guy that drove the rover on Mars. Okay, so okay, about your session, did you know that Mario and Luigi has took a recommendation from plumbers to dev and ops engineer? So let them and Joel lead you to Power Up with clouds and pipelines.
Thank you. Thank you so much. Yeah, I'll be talking today about CI/CD pipelines. I'm guessing that most of you now are somewhat familiar with what CI/CD is. I'm still going to cover a little bit of that today, just so that we're all on the same page. But I'm specifically going to talk about cloud native CI/CD, and that is done with Tekton. And I couldn't help but to make an association between clouds and pipes, and so that kind of led me to a Super Mario Brothers theme talk, because why not, right? So I'm going to talk about Tekton CI/CD pipelines today. Let me just get out of the way for that. And here it is. And I'm monitoring the, no, it's on this side. I can't remember which side it is. This side? Yeah, that side. So I'm monitoring the YouTube channel discussions there. So if you have any questions at any time, feel free to interrupt me. I'll try to kind of take a look at that if there's anything going on. If not, there will be time for questions at the end. So feel free to just wait till the end. I'm more than happy to answer any of those. Before I get started, let me introduce myself. Hi, my name is Joel. I live in lovely and snowy and cold Canada. I wish I'd be in Europe right now. I am French Canadian. Donc, si vous avez des questions en français aussi, je peux toujours y répondre, pas de problème. So either way, French or English. I work as a developer advocate for Red Hat OpenShift. So OpenShift is a Kubernetes distribution for enterprises. And yeah, if you have any questions about OpenShift, I'd be more than happy to answer them. But that's not what I'm going to talk about today. So as I mentioned, I'm going to talk about Tekton. If you ever want to get in touch with me, Twitter is always the best way. I'm a big fan of Twitter. So that's Joel with 2 underscores. It's not obvious, and it's like the worst Twitter handle ever, but whatever, it works. So Joel__alert is always the best way to reach out to me. You can also see my Twitter handle there, and it's hidden by my Twitter handle, but use the hashtag TCF21 for a chance to win stickers. I'm a sucker for stickers, so I will definitely tweet. I already tweeted, so I'm actually, I probably have a chance to win some stickers, so we'll see. All right, so let's talk about CI/CD. CI/CD introduces ongoing automation and continuous monitoring throughout the life cycle of apps, from integration and testing phases to delivery and deployment. You can find out more about what exactly is CI/CD if you take a look at this link. I will share my slides at the end of this presentation, so you can actually go and take a look by yourself. But basically, what it is that it's all about automating some of the processes to make it more to make it easier for you as a software developer to produce value for your software. And originally, we've been talking about continuous integration, and that's typically, and the terminology is really vague, and people use it in a lot of different ways. But typically, when we talk about continuous integration, we really talk about automating the cycle, your inner loop as a software developer. I've been doing JavaScript for I don't know how many years now, over 10 years. Both front end and back end, and boy, did that language evolve in the last years. But there's a lot of if you're doing just about any major front-end framework, there's a lot of continuous integration that is already happening for you. So if you're building a React application, you've probably used Create React App, and that bootstrapped your whole project. It gave you all that tooling that will recompile your code every time you do a change and hard reload your pages. But it can also run things like all your unit tests pretty much every time you do any sort of change in your code base. So there's a lot of automation that happens there. But what we are looking at here is really the whole CI/CD pipeline. So this continuous integration, that's great, works well for your inner loop as you're working in your local environment. But eventually you'll want to deploy that code, right? You'll want to share that with the QA team, or you'll want to send that to your customers. And that's where continuous delivery really comes into play. So it's really about the processes of taking all that code, automating that process of merging that code into a repo, testing, linting, or doing all that stuff, and then building an image that can be used by other people. So you can automate some of that stuff. And by doing so, you can merge your code much more often, and that reduces the number of conflict that you could potentially have. So that can be very useful for that. And oftentimes we talk about continuous deployment. Oftentimes we kind of mix continuous delivery and deployment together, but sometimes we want to split them just to show how much automation we can do. And when we're talking about continuous deployment, then we're really referring to when you do a change, you save everything, and all the pipeline is automated, and it will actually go ahead and deploy that application into the cloud. So all of that process can be automated, and that enables you, if you have some sort of microservice architecture, it enables you to really deploy quickly and regularly. So as soon as you do a little change, save, everything goes into that pipeline, and automatically gets tested, gets verified, and can be automatically deployed as well. And then you can automate a bunch of processes there as well. You can, deploy a canary or do a slow deployment. So just 10% of your users will get it until you're satisfied with that, and then engage into the next step. But that gets really heavy into continuous deployment. But we're going to talk about some of the tooling that we can use to do that. And one of the tools that I really enjoy is Tekton. And that's because it's cloud native. It's a cloud native CI/CD that is available. It's all open source as well. And when we talk about cloud native, what is it that we mean exactly? Because cloud native is used in a lot of different sauces. So everybody uses cloud native nowadays, but what does it mean exactly? Well, in the case of CI/CD, what we're really looking at is using containers, keeping containers in mind, and having everything run inside containers. So really what we're going to do here is to make sure that each step inside of our pipeline is running inside its own container, so that it's reproducible and more reliable. We're also talking about CI/CD that would be serverless, and I'm not talking about Azure Functions or AWS Lambdas here. I'm talking more serverless in the sense of no central server that manages everything. So having everything inside your infrastructure and being able to run everything makes it a lot easier for you to manage all of your pipelines. So we're going to look at that as well, and mostly DevOps, keeping DevOps in mind, or DevOps practices in mind when you do your CI/CD pipelines. So making sure that you don't have, or you're not relying on a center of excellency. When I started doing software, and you might see there's a little bit of gray in my beard there, but when I started doing software, it was all about just writing the software and just shipping that to some people, and they would be in charge of deploying the application whenever they felt like deploying it, and that could cause some conflicts. So keeping DevOps in mind, making sure that your software developers, or you as a software developer, has access to your deployment pipeline and owning that pipeline so that you can actually manage that and make sure that your application is deployed in a timely fashion and regularly if you need to. And also being able to roll back, right? All right, so oops, where's my cursor? There it is. All right, so Tekton gives us all of that. So Tekton is the one that I'll be talking about today. There's a lot of CI/CD platforms that are available, but that's the one that I prefer, mainly because I think it has the coolest logo. So that's that's definitely a good sales argument, isn't it? So Tekton is a powerful and flexible open source framework for creating cloud-native CI/CD. So that's really what it aims to do. It integrates directly into Kubernetes, and it allows your developers to build, test, deploy across all the cloud providers. So it's really useful. It works on any Kubernetes cluster, so you can just take those pipelines, and of course, it's going to follow the Kubernetes syntax. So basically, you just take those YAML files, put them in any Kubernetes cluster, and it works out of the box. It will run everything inside containers as well, and it lets you have the ownership of your pipelines. So that's why you kind of have those DevOps practices in mind. Tekton will let you build a set of building blocks that are composable, declarative, reproducible, and cloud native. So basically what that means is that you kind of create some Lego blocks, and then you just use them to build your pipelines. And you try to make those little pieces and all those components as reusable as possible, so that you can use them across all of your pipelines, or even take that exact same pipeline, but simply change the parameter for your source code, for example, or the location of your source code, and then you can reuse the same pipeline over and over for all of your projects. So making sure everything is reproducible is also a big thing with Tekton. All right, so enough talking about Tekton, and let's just, well, not talking about Tekton, because that's what I'm going to do for the next 38 minutes or so. But let's jump into the topic. Let's look at some hands-on examples. So to get started, what you'll need is a Kubernetes cluster. So I've mentioned you can use any Kubernetes cluster, it doesn't matter. I'm going to use Minikube for my examples. Then you install the Tekton CRDs, and you will need the TKN CLI tool. More information, Minikube, you can find it at this link, and the Tekton CRDs and the CLI tool are also on tekton.dev. Just install that. It's a simple kubectl apply command. Everything is then installed for you, so you just can run it. All right, so let's take a look at all the different concepts that are used in Tekton. And I forgot, I changed the location of one of my slides. So we're going to look at the general architecture of a pipeline in like 5 slides. It should be here. But the first building block that you can use for building your pipelines is called a task. And we're going to look at an example. We're going to, what is the task that we could do here? Well, push the start button to start a Super Mario Brothers game. So, so that's what we're going to do here. We're going to build a little task that's going to do that. So Tekton objects uses the same syntax as a Kubernetes object. So you can see here we've got the API version, that's tekton.dev/v1 beta 1. It is still in beta. It came out of alpha a few months ago. It is getting a lot more stable, and it's definitely getting close to a official v1. We're going to create an object of kind task. We're going to give it some metadata. Just like any object in Kubernetes, you could specify any labels that you want. In here, I'm just going to use a name. We're going to call that task start game. And then you have the spec where the bulk of your definition goes. The spec takes at least one, the task spec takes at least one step. That's a hard one. So that's the one required thing. So steps is an array, you need at least one. And the steps are all the little things that you want to do as part of that task. So I'm going to do give it a name. So this one is going to be called press start. A name is not required. It's going to just give it a random name. If not, we're going to use an Alpine image, and then we're going to run a command inside of that task just to start the game. Now, let me just make this bigger. And of course, I've built a terminal inside my slide deck because, why not? So what I'm going to do here is to actually, oh, there it is. Perfect. So I'm going to create a file, 1.yaml, and I've got the Tecton extension for VS Code, which is absolutely amazing. It provides you with a lot of little features, but the one that I'm going to use right now is just the auto completion for tasks. So I've got my template for building a task. We said we're going to call that start game, and we can remove all of this. I said there's only going to be one step. There it is. And this step was called start game. The image will be Alpine 3.12, I believe I've used. And we're just going to say starting game. Starting game. All right. So that's like pretty much the most basic task that you could build. Has one single step, and it just uses bash to run something. So let's go ahead and apply this. Cube ctl apply -f, and that was called 1. That's why I made an alias for kubectl, because I can never type kubectl. 1.yaml. There we go. So I just use K, and I use Kubernetes a lot, so it's actually helpful. All right, so a game created, or task start game was created. So now I can use the Tecton CLI tool, which is called TKN. I'm going to look at some task. I'm going to start that task, and the name of the task was start game. And let's just start that for now. And you're going to see, so that task is started. So now it will actually download the container that I was. So it creates a pod, and all the steps are going to run inside that pod. And yeah, it downloaded the container and ran the command. Now we haven't seen anything, mainly because I have to take a look at the logs. So I can just use this command here, not this. And just not that either. All right, let's. I really like my terminal inside of my slide deck, but boy, does it never work like I wanted to. Okay, so there it is. So we can run the logs, and we should see start game. Error executing, so that's not a good start. But I know what happened here. I've used bash, and there's no bash inside Alpine image, so I should use sh. So let's go ahead and apply this again. And now we're going to run that task again. But this time I'm going to just ask to show the logs directly. So task, start game, and show log. So I'll see the logs in real time. So you can actually, as you run your pipelines or your tasks, in this case, you can actually see what's going on. You'll also notice that a task is kind of a template for task runs. I won't go into too much details here, but what happened here is that it actually created a task run, and that's where the actual execution happens. So if you ever have any issues, you can't figure out what's going on inside your task, you'll want to look into your task runs. All right, so it echoed what I wanted. So far, so good. We've got our first task. Woohoo! We are now officially experts in Tecton tasks, so you know how that works. So let's take a look at steps a little bit more. And I already mentioned quickly, but a task is composed of multiple steps. It has an array of steps, and you can have more than one. Of course, you might want your task to do more than one thing. So in this case, we're going to press start, and then we're actually going to select the number of players. So why don't I go ahead and open up my code editor again, if I can find it. And we'll just go and create a new file called 2.yaml. And I'm actually going to copy the content of this one because it's very similar. And I'll admit, my demos are a little bit Hello World-esque for now, but you're going to see where we're going with that. So let's add a new step. Oops, And that step will be called select players. We'll still use an Alpine image, but you could use a different image if you'd want. This is going to run into its own container, so you could use any image here. As a matter of fact, let's just do that. Let's just use registry.access.redhat.com/ub8/ub minimal. So that's the universal base image from Red Hat. And I'm never sure if it's UB8 or UB8 here, but we'll see, I guess. In this case, I'm going to use the bash command. So this one has bash installed. And for the arguments, I'm going to use pretty much the same thing. So -c and echo selecting players. Okay, so now I can go back to my terminal, apply this new file, -f, come on, -f2.yaml. And there it is. Okay, so I've just changed my task now. So task, no, TKN, task, start game, and show log. That should work. So now this time we should see all the multiple steps going on one after the other. So the steps are executed in order. And we should see that going on in just a few seconds. Come on. Anytime now. Oh, you know what? That's probably my... oh, no. It seems like it worked. It probably had to download the UB image. I think I've cleaned my machine recently. So you can see the name of this step, so you can really see what's going on. And that really helps if you have an error somewhere, you can track in which one of your steps the error happened. And it's also colored. If you don't have a color terminal, you can use the -- no color flag. Cool. So we've talked about tasks and multiple steps. Let's take a look at how we can make those tasks a little bit more reusable now. And we can do that by using parameters. Bonus point if you recognize this screen here. That's straight from my childhood. So let's go and take a look at parameters. And what we're going to do here is that instead of just outputting selecting players, we're going to use variable substitution here to output the number of players, or the one that was selected when we started this task. So I'm going to use my editor again. Where is it? We're going to create a new file. And we're still going to use the same one. Let's just create a new one, 3.yaml. And we're going to reuse pretty much the same thing. And this time, I'm going to add a params section inside of my spec. So I'll have one parameter, and it will be called players. And we can add a description just to make it more clear if somebody wants to look at our YAML files eventually. Number of players. And we can also add this will be a type string. You can also use type array, which is an interesting one, but I'm not going to cover today. And you can give it a default value if you want. Make sure that it's a string, right? If I would have just let one, it would have been a number, and that would not have worked. So I've got my parameter here, and instead of saying selecting players, we're going to say selecting params.players. So we're using variable substitution. So Tecton will be in charge of overriding this with the actual value of our parameter here. So let's go ahead and apply this file again. So 3.yaml, and that should get started. TKN task start game. And it should be somewhat similar once again, but there's one big difference here. You can see that it's asking me for the value of players. Now, I really tried to be fancy with my editor here, but it gives me this weird error with this 78R thing going on. So I can put in a parameter. I'll say we've got 2 players. And then, I always forget the -- show log, but it doesn't matter. Let's just copy this one. Copy, and let's just paste this in. Perfect. And that should give us the logs. And now we'll see that pretty much the same thing happened, but this time it said selecting 2 players, so I was able to get that value there. You could also use --use, no, not here, --use param defaults. I think I can never pluralize that one correctly, but I think that's correct. And of course, I need to do that show log. So it's going to use the default value automatically. So that can be useful if you have something that repeats all the time. Just, -- use param defaults, and it's going to use number 1. Or you could pass in the parameters as part of the CLI as well. So -p players equals 3 players. I know you can't play 3 players on the original Super Mario Brothers. And it didn't work. That's because I forgot the dash here. So that's going to add or inject the value 3 for players automatically, and it will just output selecting 3 players. There you go. All right. So I talked about tasks, but let's take a look at pipelines now. And this is the slide I was looking for. So this is basically the whole how Tekton works. So you've got this large pipeline, and the pipeline is composed of multiple tasks. Those tasks could be reusable if needed. And each task is composed of one or many steps. And then you can see how the order of the task will be determined. And we're going to take a look at that as well. To create a pipeline, you create another object. First, I'm going to create a second task so that we can actually use that. And you know what? I'm just going to copy that one right away so I don't need to type it all in. So, what we want to do here is to defeat Bowser. So we're just going to create a task to do that. And then we're going to create a pipeline. And the pipeline uses pretty much the same syntax. So API version, kind of pipeline, metadata. You can add a name and labels if needed. And then the spec. The spec takes at least an array of tasks with at least one task. So we're going to use the 2 tasks that we had. You can see how we can pass the parameters directly or hard code them inside of our pipeline to inject those values into our tasks. So that can be useful if you want to inject your GitHub repo URL, for example. Of course, we're not that fancy for now, so I'm going to go ahead and create my new task, 4.yaml. So that was the defeat Bowser task. And I'm going to go ahead and create a new file called 5.yaml. And that new file is going to be my pipeline. So once again, I've got my autocomplete on. We're going to call this Play Mario. Let's forget about resources for now. We're going to have an array of tasks. The first task will be called start, and it's going to be in reference to the task that was generated earlier called start game. That's another cool feature of the extension, is that it actually gives me the options to choose the tasks that I have. That task had a parameter, so we're just going to add params, name players, value 2, because why not? And then we need this second task. So that's a pipeline, so it can have multiple tasks. The second task will be called win, and it will be in reference to the task that we've created with the name defeat Bowser. And you can see here that it gives me an error because value is not accepted. That's because the task is not created yet. But as soon as I create it here or apply that file, it should be accepted now. So I'll go ahead and apply that second one, apply -f 5.yaml. And there it is. So now I can start my pipeline. So I can use tkn still, tkn pipeline. So very much the same syntax between tasks and pipelines. tkn pipeline start, and it's called Play Mario. And don't forget -- show log so that I can actually see the logs. And this time we should see the output of each one of our tasks and each one of the steps inside of those tasks. And you can see here the name of the task. And so win, defeat Bowser, battling Bowser, you won. And then we have the start task that started and selected the number of players and then eventually started the game. We can see that there's a little glitch here. So it didn't come out in the order that I originally wanted, but that's kind of normal because I didn't specify the order in which we want our tasks. So the task won't execute in the order. If you list a number of tasks, they'll all start simultaneously and run in parallel. If you want a task to run after another one, you need to use the run after option right here. So I can go ahead and just add that. And that's in a new file. We're just going to copy this pipeline And let's create a new file called 6.yaml. And this time I'm going to, whoops, this time I'm going to make sure that the second task runs after, and it takes an array. So that's important. So you could be waiting for multiple tasks to be completed before running another one. And it runs after start. So now I can actually go ahead and apply this file. And let's run this pipeline again. Pipeline. Whew. That was hard. Start, play, Mario, show log. And now this time we should see the task appearing in the right order. So we should see the starting, selecting players, and then eventually the win screen. Not a screen, but the win echo text. And there we go. So we've got the battling Bowser at the end in the order that we wanted. So far, so good. Perfect. So you can reuse tasks. You can make them in parallel, in sequence. It doesn't matter. And when I say that you can reuse tasks, you can actually reuse the same task inside of a single pipeline. So that's actually a very powerful feature that you can use. So you can take a look at this task right here. It's a task called collect. And what it will do here is that it'll take one parameter and it'll ask, what should I collect? In this case, we're going to collect coins, right? Mario collects a bunch of different things, coins and mushrooms. So we're going to be able to reuse that same task to collect those two different objects. And what it does here is it just runs this little bash script that will sleep for a number of seconds, random between 1 and 5, and just output collecting X number of objects. So, and then inside of my pipeline, I'm going to have my array of tasks. And in here, you can see that I'm using the collect coins task. So by default, it will use coins as a value. So it will output collecting coins. And then I can collect mushrooms as well. So I can reuse the exact same task. So I'm just using the task called collect. And I'm giving it a parameter here that will completely change the output of that task, actually. So you can use parameters to make sure that your tasks are reusable and you can reuse your code as much as you can. Now, we also want to make sure that they both run in parallel. We want to make sure that as soon as the game is started, both of those tasks start. So I'm going to use run after start for both of them. And then finally, I'll have the run after, the win task will run after both of those tasks have been completed. So one another cool feature about the VS Code extension is that you have this amazing pipeline preview that you can use. So you can see here that I have my start task, and after it's done, it will do both collect mushroom and collect coins simultaneously. And once those two are done, it will go ahead and run the win task. So let's go ahead. And now I'm running out of time, so I'm just going to copy because, yeah, I had them right here. I wasn't typing completely out of my memory. Right. Just copy everything here. And I'm going to apply 7.yaml. And that should take care of creating my new collect task and should take care of configuring my my pipeline. So tkn pipeline start play Mario show log. And that should start our pipeline. We should see the, press start, select the game or select number of players. And then we will see collecting mushrooms and collecting coins. And then we will see the final winning screen, defeating Bowser screen. So starting game, and we see that collect mushroom completed first because it only slept for 1 second, while collect coins slept for 5 seconds. But once those two tasks are done, then the final task is started, and we can defeat Bowser here. All right, cool. Another interesting thing is the task catalog. So as I said, you want to make your task as flexible as possible and as reusable as possible. And to that point, Tekton actually offers a catalog of tasks that are pre-made for you. So if you need to do something like git clone, look up hub.tekton.dev, and they provide you with a catalog of all the different tasks that you can use. And you can just, I'm going to take one right away. So hub.tekton.dev, you can go there. I'll need the git clone task in just a few seconds. So git clone, I can do install. It gives me the text that I need to apply, and then I'll be able to directly apply that with kubectl. Pipeline resources, one thing that I wanted to talk about, they used to have that concept of resources. I'm going to go real quick because, well, they're still in alpha. Basically, it was a way to input something into a pipeline, and then you would also have an output. I thought it was a really cool feature, but they're more likely to be replaced by what are called workspaces now. So we'll spend a little bit more time on that, but basically that's how it worked. So you had an input, you had your pipeline, and then your output at the end. They're now mostly replaced by workspaces. A workspace is a shared space that you can share across tasks or across a pipeline. So basically, what I'm going to do here is to just create a workspace, and then it's going to use that git clone task right here. It will pull down a repo, and in one of that repo, there's a level.txt file which has the level we're at in Mario, and then it can use the workspace right here by using variable substitution again, and I can output the content of that file. So I can now share some content across my various tasks. So I can go ahead and apply my git clone task that I had earlier. I believe I already have it in my cluster, but it doesn't matter. And then we're going to apply -F8. There it is. And then we can start this pipeline again. There you go. And I also created a persistent volume and a persistent volume claim so that I can actually share that volume on a PVC. TKN pipeline start level selector. And let's show the logs. So now it gets a little bit more concrete, right? We're actually using a true git clone, and we're going to clone some code. I need to specify the name of the workspace, which is level WS. I need to specify a subpath, which is none. This will be a PVC, and I believe the name of my PVC is TKN PVC. So that should start my pipeline, or start a pipeline run technically, and we should see the logs in just a few seconds. So it'll go ahead, clone our repository, and then extract the content of that file and output that as an additional task. So let's just wait just a few seconds to see if it goes quickly enough. Or else I guess you'll just have to trust me on that one. In the meantime, I'm going to go and get prepared for the next or the final step, which is right here. And I am going to apply the last one, the last pipeline that I have. And I'm going to start it right away because that one will actually take a few seconds. Deploy. And I'm going to explain that one right afterwards. Of course, I want to show the logs, so that will be helpful. There it is. So no, we're going to use a default value here. This is my username for Docker Hub. This is my password. No, it's not. And we have one workspace called code. It's a PVC, and we can reuse the same PVC here, TKN PVC. Okay, so this one is taking forever, so let's move on. So this is the real world example that I wanted to quickly show. So basically what you would typically do in a typical pipeline, clone your repository, perform your unit tests, compile your code if you have not a JavaScript application, if you have a Java or C++ application, build an image to be deployed on to your cluster, and then finally deploy that image to your cluster. So what does that look like? Well, that's the one that I've just applied into my cluster, and that's the one that is somehow stalled. So I'll just probably give up and hope that you trust me on that one. But basically what it looks like, your pipeline, and then it gets a little bit more complex, but all the code will be available afterwards. So you can see that I have all the parameters that I filled in. I've got my workspaces that are used. I've got my tasks. So the first one is, my git clone. Then I share that into a workspace. I can run my npm install, and then I will run npm run lint to make sure that all the code is valid, make sure to run all of my tests, make sure that all my tests do pass. If they wouldn't pass, it would stop right there and it wouldn't go to the next step. or the next task, sorry. But then if it works, I am running my build and deploy, which uses S2I to create that image and deploy that into a server. So it seems like it's stalled. So it's, yeah, you might have saw it. Well, just look at the recording afterwards. It was there. So it was actually doing that git clone. Not sure why it was so slow. So quick recap, Cloud Native CI/CD framework, Tekton, very useful. It uses steps, tasks, pipelines, and workspaces to build those pipelines. Hopefully, you leveled up with this presentation and know a little bit more about Tekton. And that is all I had. So thank you very much for attending. Provide the feedback. The should come up anytime now.
Yeah.
And yeah, that's it. Thank you.
Okay. Thank you very much, Joel. We have a very few questions, very quick. We won't take all the questions, but okay, let's say, okay, do you have any good resources with Tekton for someone who wants to start with?
Well, I'm glad that you asked, mainly because there is not a very good resource that I was able to find, apart from the official documentation on tekton.dev. But I know someone who's writing a book about Tekton.
Okay.
So it should come out in a few weeks, maybe months. But yeah, follow me on Twitter. You'll have more information there.
Okay. And another question is how I can integrate Tekton if I'm using GitHub or any other tooling suite such as Azure DevOps, for example.
Could you repeat that? Sorry.
If I'm using already using Azure DevOps or GitHub or any other platform, how can I integrate my build with Tekton?
That's a very good question. It really integrates about throughout Kubernetes. So if you're using Azure and you have Kubernetes, then you can easily integrate there. There's also this other thing that I haven't talked about called triggers, Tekton triggers, which will use hooks, and it will basically open an ingress and open some routes into your cluster so that you're able to use the GitHub hooks to directly trigger your pipelines and do all of that stuff for you. So that could be different ways to integrate.
Okay. Also, we have the question, is there a UI available for Tekton?
Well, once again, I'm glad you asked. Wow, you really have good questions. There is something called the Tekton dashboard, and I happened to start it just before this presentation. So yes, there is one. It's a project part of tekton.dev, and you can see here that I have all of my pipelines. I have each execution of my pipeline. We can see the results. So that last one that we never no, that's from another example, but you can see each one of the status of each one. So if something failed, you can actually go and dig a little bit and try to figure out what happened here.
Okay, great. And I think we still have time for another question. So how can I get my pipeline to start automatically?
Well, yeah, you would use Tekton triggers. So that's definitely the easiest way to get started. And then you can integrate with a bunch of things, but typically GitHub and GitHub hooks is the easiest way to use.
Okay, and the last one, do I need to host Tekton by myself, or is there any service?
If you need to what, sorry?
Is there any? Do I need to host Tekton by myself, or is there any service out there?
There is a few CI/CD pipelines that use Tekton under the hood. So Jenkins X would be one. Apart from that, I don't know of a good hosted service for Tekton. That's kind of really the mentality of Tekton, is being able to run this inside of your own clusters, which makes it easier to integrate with stuff, like for deployment and your own local image store or registry. But I'm sure it will come at some point. There will be a Tekton as a service.
Okay, that's it for the question. Thank you very much, Joe, for your presentation. It was really refreshing. And okay, you also have the credits.
Yeah, why not? All right.
Really
Thank you
nice.
very much for
Okay.
having me. It was a blast.
Yeah. Thank you. Okay, and we will switch to the next and last session just after 5-minute breaks. So be sure to stay there as we have Adrienne that will come to take the last talk of this day on track 2 and to close that day. So grab another coffee and be sure to be there for that next talk. And we are back for the very last session of this day. And we kept something special for you for desserts. Please welcome Adrienne on stage. Hi, Adrienne.
Hello.
So I'm sure you're really happy that we're talking about dessert for your session. And I'm not saying this only because you're a sweet person, right?
No, I don't think so.
Because I heard you really, really like dessert, and so that's also the reason why you have a cake on your name.
Yes, I would gladly trade any job that will pay me in cream puffs or donuts.
Okay, good to know. Good to know. Okay, so you're here to close that day with your session about multi-cloud clusters. So to share your experience on that. So the stage is all yours.
Thank you. Hello, everybody. Thanks for being here at the CloudFront, and thank you for staying until the very end of the day for you. It is bright and early for me, so I'm going to be full of energy right now. But I'm Adrienne Teka, and I'm a Senior Developer Advocate for MongoDB. And today I'd like to take you on a journey through multi-cloud magic, or in other words, how do you leverage multi-cloud clusters in the real world? So just as a quick overview to make sure we know where we're going on this journey, we're going to start with, well, what is multi-cloud exactly? I know the term has been used in many different contexts, but I want to make sure we're all on the same page and the same path when it comes to this talk. Next, this will eventually lead us to what is probably the most common question right after hearing about multi-cloud is, well, do we really need a multi-cloud option? And then the bread and butter of this talk is the multi-cloud in the real world. So we'll discuss a few scenarios where there are multi-cloud clusters in production and see how they fit in many different kinds of scenarios and use cases. And then finally, at the end, we will set up our own multi-cloud cluster on MongoDB Atlas. And as before, this is the last session, so please take the time to tweet about this, not just this talk, but the conference in general, and you get to win a really sweet sticker pack. I might do some myself and just start retweeting a bunch. So, what is multi-cloud? And you don't have to think too hard about this, because what you're first thinking about and your first instincts are probably correct. At the simplest form, multi-cloud is really just any single architecture that uses two or more cloud providers. So if we contrast this to what we've had before, we first had the cloud, right? Just this overarching cloud. And this is probably the simplest scenario that most of us have started. I know that when I started in my last job on the cloud, we started migrating our CI/CD pipelines over to Microsoft Azure, and we started using Azure DevOps, specifically Azure pipelines. And so this is kind of where we all get our feet wet, right? We probably host an application on here, and we are on a single cloud provider. That's probably the most important part about this architecture. Also, with the cloud, there's this notion of a public and a private cloud. So public is something that I'm sure most of us has had experience with before. If you've ever tried the free tier on AWS or GCP or Azure or anything like that, you have used the public cloud. And this is just the shared resources that any customers of a cloud provider uses. Contrasting that to the private cloud is just a subset that's reserved for you, and it is only for your use. So it is completely reserved off for you only, and you usually pay a little bit extra for that. So with this notion now comes the next kind of evolution, which is the hybrid cloud, right? And this is where we combine both a private cloud and a public cloud. And what's interesting about the hybrid cloud is that these usually work together. They always work in tandem. So whether that's having a dev and test environment in the private cloud, or maybe your own on-prem data center, and then you use a public cloud for production, that's a very common way to use this kind of architecture. And so now we're back to multi-cloud, or now this is the latest thing that we're talking about and actually has been in use for a while, and we'll get to that in a moment. But again, it is just multiple public or private clouds. And up until this point, the reason we would use this, among the other things we'll talk about, is that usually we would take advantage of the isolation of each cloud's environment. And that's one of the largest differences between that and a hybrid model. So just to recap, that's the difference, right? In multi-cloud, you have up to 3. You might be using all 3 cloud providers, or you might be using 2 cloud providers that are private. Versus hybrid, there's always a mix of a private and public, or on-prem and public, or on-prem data center, private and public. So that's out of the way. We're on the same page about what multi-cloud means. Now we come naturally to the next question, which is, do we really need a multi-cloud option? Think about it. In June of 2019, there was a GCP outage. They called it the catch-22 that broke the internet. And what happened here was Google does this frequently, right? It was supposed to be a routine configuration change, a maintenance event that was intended for a very specific geographic region. And when that happens, Google reroutes the jobs that were running on those servers onto other machines. But because of what Google has stated in their root cause analysis, a cascading combination of 2 misconfigurations and a software bug that led to Google's automation software descheduling network control jobs in multiple locations. So this article made a very good analogy. If you want to think of the traffic that's running through Google Cloud like cars approaching a tunnel, the capacity effectively went from 6 tunnels to 2. So that resulted in the internet-wide gridlock during that outage. But it wasn't just GCP. AWS also had their outage. This one was in October of 2019. In this case, AWS explained that the event was caused by a failure of our data center control system, which is used to control and optimize the various cooling systems used in our data centers. So this control system contained third-party code, and this third-party code was what they used to interact with the different third-party devices in that center. So the third-party devices are fans and chillers and temperature sensors, and due to a bug in this particular third-party control system logic, it resulted in excessive interactions between the devices and this system. So it pretty much just became unresponsive due to the number of requests it was trying to make. And this, again, cascaded. Racks of servers were overheating, and a bunch of cooling systems, redundant cooling systems, failed in parts of the affected availability zones. And on, right? Google Cloud, again, had one in March of 2020, this time due to a significant router failure in a data center in Atlanta. And then, as we started to get into the pandemic, right around a year ago, this really started to test the limits of what the public cloud providers could give us. So as everyone started to migrate from home and lots more people were working from home, Microsoft Azure suffered some capacity shortages in Europe. It got so bad that they had to start introducing metering measures, which meant only the mission critical user groups or existing customers were prioritized, and there was not enough left to go around for anyone else. So if you're trying to use maybe a free tier or just wanted to try it out and play around, that was not going to happen. And just to give you an idea of the unexpected increase in traffic, Microsoft shared their stats for Teams, which is their video conferencing software, and they had about 44 million daily users. This generated about 900 million meeting and calling minutes on Teams, and that was in a single week. So that's a very, very big spike, something that was not expected at all, but it also is a true stress test. It really showed us the limits of what the public cloud can offer, and really shows that sometimes you can't rely, even though they try to say that, you know, they have service level agreements that they try to keep, or that we have a lot of coverage around the world, there are still outages like this that occur. And on and on and on, right? Azure had another outage in June of 2020, this time with some bottlenecks in the APAC region. And then the most recent one, which was the AWS outage due to the Kinesis data stream outage around November of 2020 of last year. So over the past 2 years, we like to think that, oh, outages are rare. Outages don't really happen. Outages are, they are very, very minimal. But as we have seen, that's not the case. Over the past 2 years, there have been an outage on all 3 cloud providers. So this means no cloud is spared from these outages. And that also means that these outages were sizable enough to affect a large portion of their customer base. So this is very important to keep in mind, and one very big reason why having a multi-cloud option makes sense, especially if you're currently only working with a single cloud provider. So this is one of the most common reasons, right? One of the things that you might think of right away when you think about a multi-cloud option. But there are a couple more that I want to discuss because I think they're just as important when you talk about a multi-cloud strategy. So this is the Setting the Multi-Cloud Agenda report. In June of 2020, IDG brought around 30 IT leaders from all kinds of industries to talk about multi-cloud. What are the problems with it? What are the challenges with it? What are the aspirations for it? How close are we to bringing it into our actual strategy in the current day? And a lot of the CIOs, TLDR, they all want it and they all feel that there is a large need. But there are 2 particular quotes from this report that I feel sum up exactly why multi-cloud is another ideal option. So the first one is from Gregory Scher from Fiserv, and he says, the main driver is what our clients are asking for. We have banks who have an Azure preference, we have banks who have an AWS preference, Google Cloud, and on and on. We don't really get to choose. And so this is very apt because if you are a business like Fiserv, so Fiserv is an American multinational Fortune 500 company and they provide financial services. So if you're someone like them, then yeah, you're going to have clients who have differing preferences. Some might be fully on Azure, some might be fully on AWS, and they're not moving anytime soon. So if you are only able to offer your services on a particular cloud, you might not be able to service this client at all. So having the ability to be able to offer and have your clients choose where you want to host your data and where you want to run your applications is a very, very compelling reason and a needed reason in a lot of industries. But it's not just the clients, it's also the devs, right? So Mohan Pucha of Aon says, we have to be native AWS because of their advanced capabilities in analytics. And we have to be in Azure because, frankly, developers love that ecosystem. And productive developers are probably the best thing. So this guy knows what he's talking about and understands that developers, as they're becoming more autonomous, as they are part of the larger architectural meetings and strategic meetings, planning out what is going to happen with the architecture of the systems that they're building, they know that one cloud is not going to be enough. And sometimes other clouds may be different from the one that they're currently on, may have some services or some strengths that they would like to take advantage of. And this is something that we need to provide developers. We need to give them that flexibility to be able to use the best tools for the job. So this paints a picture of, yes, multi-cloud is definitely wanted. You can definitely argue that it is needed in those particular cases. But now we'll see where it has actually been helping some real use cases right now. And so we'll talk about a couple scenarios of multi-cloud in the real world. And we'll start with some data residency type of use cases. So this one is for Canada. Canada has a strategic IT plan that they plan I think it's like every 5 or 6 years or so. They set a plan out and the policies apply for the next 6 years or 5 years, I believe. And in this particular plan, the most recent one, they have one policy, which is called the Direction for Electronic Data Residency. So this states that any sensitive electronic data that's under government control and that's been categorized as a protected B, protected C, or classified. So meaning if these types of information were to be exposed, it could cause harm or is personal information, then they need to be stored within the geographic regions of Canada. Now, there are a few exceptions to this. So if there are a few locations that the government of Canada has approved that are located abroad, they're usually something like a diplomatic building or a consular mission, but those are very rare. And so for the most part, most of these policies apply in that you have to keep data within the borders of Canada. Now, two specific provinces went a little bit more explicit with this. British Columbia and Nova Scotia says all public sector data, everything, public schools, public agencies, hospitals, all those kinds of things, they have to remain within Canada. Whereas Ontario says they've kind of just limited that to healthcare information. Healthcare information is the only thing that needs to be contained within Canada. And so when you think about these situations, all of their data is most likely stored in AWS Montreal. And the use case I want to talk about now is an emergency services company. So just like them, they are hosting their data in AWS Montreal because last time I Googled, AWS has 32% of the market share, so it's not hard to see why they might be on AWS. Now, AWS Montreal, only region there, the largest provider, so everyone's there. But what happens when AWS goes out? Well, you're out of luck because your application is most likely down, especially if this is the only cloud provider that you are using. And though rare, it does happen, as we've seen in the previous history of the last 2 years. So this was unacceptable, right? Anytime you have any kind of application downtime of any kind, that usually results in I'm sorry, I went to the next slide. I lost my train of thought. Anytime you have application downtime, that usually results in either financial loss or brand or reputation loss, and that's never good. And in particular, for an emergency services company, an outage is just unacceptable. So especially seeing the recent AWS outage, this did not make them feel comfortable at all. So hence the current slide now, they took advantage of another node in Montreal. But the thing is, that node was on Google Cloud. And for additional fault tolerance, they also added a couple nodes from Azure, a couple of regions. So first one is in Toronto, which is the Azure Canada Central region, and the Azure Canada East region, which is in Quebec. So now, in this situation, they have much more peace of mind because, let's say Montreal goes out, AWS, well, this is where GCP can step up and fill in the gap. And in case the entire region goes out, let's say GCP also goes out, well, now they are also protected against that because they have added the additional Azure regions to be able to fail over to. And this is a scenario that we see very, very often, especially for these kinds of data sovereignty and data residency issues. There are several other examples of this. The next one I'll show you is Australia. So Australia also passed some legislation that, this case, is a little bit more, lawful than just the policy, but they called it the My Health Records Act of 2012. And in this case, it's the same thing. They have a requirement not to hold or to take records out of Australia if they were personal health records. So if we take a look at Australia, if you are one of these healthcare operators who holds this kind of data, these are your options. You've got Sydney, and GCP has Sydney. AWS has Sydney. And that's it. So if you are trying to find a way to protect against a regional outage, you kind of don't have a choice, especially if you're using GCP or AWS. So it's the same situation. You're trying to make the best of all of the providers available. So in this case, what was used was the Melbourne region, which again, Azure has filled in that gap, and this is the Australia Southeast region. So now, if you were on the either GCP or AWS, you could now add the Azure region to add an additional layer of fault tolerance in case that region goes out. Adding to this, Azure also saw that there was a need for in-country disaster recovery, so they added 2 more regions in Canberra, which provides them yet another area that they can fill over to. And yes, Azure also has one in Sydney. So the point of this is that, again, at the time, there was only Sydney that you could really look at. And until you started to consider, maybe we should start using Azure, or maybe you were not wanting to use Azure at all, maybe your company wanted to be dissuaded from using that. Sometimes you may not have had a choice if you needed to have that additional availability. And so making use of the cloud providers' regions where they are available should only result in helping us keep that kind of higher availability for our applications. So those 2 are fairly, I would say, common. There are a lot of those in play already, and there are a lot of other countries that have similar data localization laws. There's some in Germany, I believe there's some in France for particular classifications of data where they need to stay there. And particularly for a lot of countries in Europe where there may only be one cloud provider available, this is again another scenario and use case where making use of other regions on other cloud providers makes sense. So enough about that, enough about the localization type of laws. Now we're going to talk about a couple use cases from clients. And so in this case, the theme here is the best of all clouds, but in a different way. Earlier, we talked about being able to be completely, offer higher availability, making sure you are protected against all kinds of outages. In this case, it's a little bit of that, but also being able to use what is the right tool for the job. And so in this particular case, this company had an application, which is some internal help desk software, and they were running this on AWS. And as they started to expand, they wanted to add this new feature, this recommendation feature, to their software. So after discussing it and planning it out with their devs, naturally, they kind of pointed towards GCP's AutoML tool. So AutoML, natural language, it uses machine learning to reveal the structure and meaning of text. And so they said, this is the thing that we need to use. This is what we want to use and is the best tool to use for this particular recommendation feature. So with this in mind, the next question is, well, naturally, we have to discuss how are we going to get our production data over to GCP, because we need that data to feed into our the analytics application that they'd like to build that is going to be using AutoML. And how do we do that? Well, there are a few options. And the first way, the most common way that we usually solve this kind of issue is we write custom code, right? We do custom scripts. But the problem here, I'm sure if anyone has gone through this kind of pain, is that anything that's this tightly coupled to something that's so unique, so in this case we would be building a unique data pipeline for this specific feature, it's never easy to scale. It's never easy to kind of refactor if we need to, or change or add upon. And so we know that this takes a lot of time and a lot of effort. And this is exactly the same thing that this client saw. There's a lot of effort due to testing, to ongoing maintenance, and a lot of monitoring costs. And even as devs, when we try to think of a solution for this, even if we try to automate the pain away, which is very common, there were talks of using something like Kafka, which can stream updates from one source to another, but it was still a little too much for this particular use case. It still required work to host it and to maintain it. It was another separate piece. So this option did not work. The next option that is usually considered is backing up and restoring. So again, this customer could take snapshots of their production data live and then restore it to their GCP database, where it could then be analyzed. This works, but the problem here is that in this kind of ETL process, you usually do this in batches. And so this again did not work for this particular use case because the analysts were constantly waiting for this new data. They were dealing with a lot of stale data because they had to wait for the next snapshot to be restored into the analytics application, and specifically the database that they were using to feed that application in AutoML. So in this particular case, something like a multi-cloud cluster was the best option for this particular client. So in this case, what changes here is that instead of having to deal with several other databases, they would use the same underlying cloud database, something like MongoDB Atlas. And what happens here is that now within this single cluster, in this single area, they were able to now designate where their operational and analytical workloads can be dispersed. So this particular case, what happened was this customer was able to essentially give the analytics application, the one that was using AutoML, the data that it needed by adding a read-only analytics node. So this is a specialized kind of node that is used and has been offered for a while in MongoDB Atlas. But what's interesting about this particular node is that it is made for these kinds of scenarios. It's made for complex or long-running queries or long-running operations. And the best part about this is that because this is part of this single cluster, the other electable nodes, aka the ones that can participate in elections and is running their production traffic, these remain untouched. So they are not competing for cluster resources. We know that with this separation, we know that the ones running on AWS are the electable nodes, are dealing with production traffic, and we know that the replica set that is on GCP is the read-only analytics node. So they are the ones that are only going to be processing the production data and feeding the AutoML process. And this worked out really well for this particular case. The next case that's kind of a little bit more experimental, but is still something that would be kind of like the holy grail if they were able to get it to the state that they want. But the idea here is that let's say you have some workloads that needed to be run. In this particular case, this client needed to fulfill orders. So that's the workload that they were able to condense down into parallelizable, I think that's the word, way to be able to split. You could split the workload over a bunch of nodes. And so what wanted to do was that wherever it was cheapest at the time for a specific cloud provider, they'd like to be able to send that workload over to the cloud provider that was cheapest at that time. And the idea here is that, you know, if Azure was the cheapest at that day and time, send the workload over there. Or once AWS has met their threshold of whatever that budget is for what the costs are that are okay with them, send some workload over there. And on, right? This would be continuous. So if they happen to change and fluctuate, and let's say GCP was the cheapest at the time, they'd like to be able to split, share that workload or send that workload over to GCP. So again, this kind of scenario, having something like a multi-cloud cluster makes it much easier to do because all three of the cloud providers would be in play. And whenever you wanted to share the workload over to a specific cloud provider, you just have to change the provider on your cluster and designate which one would be the primary cloud provider at that time. And that would make it much simpler to do and even make this kind of scenario possible. Now, along the same lines, a third kind of scenario for this is something with extreme cost optimization. So that one's also kind of extreme cost optimization, but this one is also similar, but for different factors. So in this particular case, there is an auto manufacturing company that wanted to they basically wanted to have negotiating power, leverage, right? And also for price. And what happened was they are currently running their production loads all on AWS. However, the last time that they spoke to both AWS and Azure in tandem. They talked to them at the same time. And what they would love to do is, let's say Azure offered deep discounts, which they usually do depending on what kind of workload they would be getting from a client. This client would love to be able to just say, oh, I got a really good deal at Azure. I now need to move everything over, and be able to do that at the flick of a switch. And so again, this is possible because if you are using something like a multi-cloud cluster that is available like MongoDB Atlas, you literally can just change the provider. So again, their primary provider would be AWS, but by going into Atlas and designating, oh, I need all of these to be Azure, now you can set it up so that they start migrating over to Azure and do that back and forth with no problem. So that kind of flexibility is absolutely key and compelling to why they would want to have a multi-cloud architecture, especially if you have the ability to migrate your data just as easily. So those were a couple client scenarios of why multi-cloud was definitely the ideal option and is used, and is certainly the option that they're looking at because of the different scenarios and requirements that they've had. But now let's talk a little bit about why developers would want a multi-cloud solution. And we kind of alluded to it earlier from Mohan's quote. But as devs, we want to use the best tools for the job, right? We know that every cloud provider is great and is the leader in something, but we know not one single provider is the greatest for everything. And so knowing this fact, we want to use the tools that we know is best. So as we've seen in the experiences that we've had and just seeing what is trending lately, we know that AWS Lambda and S3 are the market leaders when it comes to serverless functions and storage. We know that Google Cloud is the leader when it comes to anything with their artificial intelligence or machine learning tools, probably because of all the data that they have to work with. And as we alluded to in the other example, that client wanted to use AutoML, so they're kind of known as the leader in any of those kinds of tools. And we know that Azure is also a very beloved ecosystem for a lot of devs, a lot of enterprises. So for them, and maybe other places, that they like to use Azure Active Directory for authentication. They want to use the VMs and the DevOps tools that Azure provides. And so all of these are on different cloud providers, and we should not be locked into any single one, especially if we know that one of these particular tools is the best one to use. So having something like a multi-cloud cluster where we're just able to make sure that the data is there and working for us allows us to focus on just using these tools and makes it possible for us to use these tools without having to worry about, oh, how are we going to migrate the data over? How are we going to get it to work and cut over properly? Another reason why devs should be looking to this and are liking the possibility is that we're now even responsible for even higher availability and lower latency. So as I showed you previously with the emergency services company and the Australian situation with the My Health Records Act, we are required to be able to comply to these kinds of policies. But as we are an ever expanding company, a lot of companies who are becoming more and more global, well, we're expected to provide the same kind of user experience for all of our customers. And so sometimes that warrants the use of other cloud providers' regions. And sometimes that's the only way we'll be able to get that same kind of experience, that same low latency, because we need to use a node from one of these other cloud providers. And lastly, the biggest point about being multi-cloud or having a multi-cloud option is that as all of these new tools start coming out at us, the biggest goal now for devs is we're trying to become more cloud agnostic. The ideal goal is something like this, where no matter where we are asked to build our applications, that we're able to support them no matter what, whether that's client preference, whether that's the company direction on which cloud provider we're supposed to use, or if there are just tools that we ourselves want to use and is the best for the system that we're building. And so now we are coming to one of the last couple scenarios, and this theme here is to future-proof. So we've had higher availability situations, we have the flexibility for both client requirements and developer requirements, and now we come to the last most common use case for multi-cloud clusters. So this particular company, they wanted they're a procurement company, and they're currently built from the ground up and are fully an Azure system, right? Everything that they have is mostly on there. They started to rebuild the platform recently, and they, as a procurement company, they have customers who actually compete with some of the cloud providers. So a very common example of this is Walmart. Walmart, if you want to do business with Walmart and you're like a SaaS provider or something like this, you cannot be doing any kind of business on Amazon because they're technically competitors. So in situations like this, and it's very similar to this procurement company, they realized they had customers like this who said, nope, we're not working with Azure, we're not working with GCP or AWS. So in order to keep those customers and in order to, again, future-proof themselves as they rebuild this platform, they needed, again, the ability to say, nope, that's fine. We are able to migrate your data over to X cloud provider that is okay with you, or one that you are required to use. And so again, this is giving the customers the ability to choose where their data is stored. And last but not least, we come to mergers and acquisitions. So it's very similar to the future-proofing scenario of the procurement company, but we already kind of tried to do this in several ways. So again, a very common use case is there's a lot of companies who are most likely on AWS, and what happens is they get acquired by a European company. And a lot of European companies are very Azure dominant, so they're fully on the Azure ecosystem, and they need to kind of absolve that. They need to migrate over, essentially they have a cross-cloud migration that they need to do from AWS to Azure. So again, how does this happen? How does this usually happen? Well, there's option number one, which is custom scripting, but we all know why we don't want that, so we're just going to skip over that. Now, option two, so if you are already using something like Atlas, we do offer something called live migration. But the problem with this particular case, even in our own tool or service, is that you would first need to set up this destination cluster in Atlas, and there is some manual intervention involved. Well, the biggest thing that is kind of annoying to deal with this is that once that cluster has been set up, in order to properly test that you've cut over from AWS to Azure, you have to bounce your app and the connection string has to change. And that is really, to the point, is a big enough deal breaker for why this is still not the best option. So again, in this particular case, what would be the ideal option is a multi-cloud cluster. So you're already an Atlas customer, right? And in this case, by changing the configuration to be multi-cloud, what happens now is that this can migrate over gracefully. And how that does that is Atlas will do this on a rolling basis so that there's no disruption or downtime. How it does that is it will first start to migrate over two of the secondaries over to the new destination cloud provider. In this case, it's Azure. And then it will elect a new primary. And then it will fully migrate over the last remaining secondary. So now at this point, you have fully migrated over to Azure. And the best part is that it's all taken care for you since it's the managed database. It's all automatic. And it's also, there's no need for you to change the connection string or bounce your app. Because you are on the same cluster and multi-cloud cluster, that is no longer necessary. So that's one of the best solutions to how to do this kind of cross-cloud migration over very nicely. And so those are kind of the scenarios that are at play today. I want to put in a very big caveat that, you know, in these very specific scenarios, a lot of the reasons why this was able to happen is that a lot of these apps were either being rewritten so that they could take advantage of something like a multi-cloud cluster, or the application tier was already built in that flexible of a way. So I'm not saying that just because you bolt on a multi-cloud cluster that you're going to have this kind of flexibility, but it's a start. It obviously takes a lot of consideration to make sure your application tier is also built in a way that can take advantage of this. And to end with that, right before a very quick demo, we have the most important part. You saw that a lot of these cases, all of these cases dealt with the data. And I think this last quote from Brad Lewis from the think tank report sums it up very nicely. It says, if you want to have true portability of applications, obviously the data has to go with the application. And so we're going to do that. We're going to spin up a very quick cluster here. So I would have had a demo that is like fancy on an API. We just released API support for multi-cloud clusters, but literally just released it. So the next time we do this, I could probably do that demo. But for now, if you're familiar with the MongoDB Atlas, you'll see here, this is kind of the same to you, right? You would choose your region. Here it auto chose Google Cloud because I am based in Las Vegas. But in order to do multi-cloud, you would just toggle this. And now you have the availability to choose electable nodes, which are the ones that participate in elections. You have read-only nodes. So this is great for adding additional nodes in other areas where you want to get those hyper-localized local reads for lower latency. And then those analytics nodes that I was talking about previously. So let's just add this really quick. I'm going to do it what's called a 2-2-1 node distribution. So we'll do 2 nodes in the highest priority region, which will be Google Cloud Las Vegas. I'm going to add, let's do Azure. We'll do Azure California 2. So 2 nodes in a secondary region, which is Azure. And then we'll do AWS Oregon 1. We always do an odd number of nodes so elections work properly. And you'll see here, this is the highest priority. So this node, or the nodes in this region are going to be prioritized for this. And so now we're going to just quickly create this. And of course, since this is going to take a while, I already have one that has been created here. So you'll see once it has deployed, you'll have a primary, which is in GCP. You'll have your secondary nodes in Azure and in Oregon. And that is it. I'm a little bit over, but I want to thank you for staying with me. Salamat, that means thank you in Tagalog. And please, as before, if you like this session, check it out, scan this QR code. I'd love any feedback, all in feedback, always looking to improve. Thank you very much for staying with me till the end of the day, and you can relax now.
Yeah, thank you very much, Adrian, and thank you for that demo at the end, which finished the work for the day. Yeah. We just have a few questions for you before you leave. Sure. Do you have any further resource or tutorials on MongoDB's multi-cloud clusters to start to build that solution?
Absolutely. I actually wrote a tutorial for MongoDB's developer hub. So follow me on Twitter. I will definitely send that link out to the world.
Okay. Also another question is, what are some general best practices in a multi-cloud cluster setup for production readiness?
Yes, so as I alluded to earlier, there are these things called node distributions, but one of the best ways to do that is to always ensure an odd number of nodes that are deployed, again, so that elections are properly done, and also to try to always start out with the closest regions to you and then start expanding out. So having that availability to be able to go to other nodes is key.
Okay, great. So thank you once again. So To finish the day, I will bring my partner Arnaud on live. You can stay, Adrian, if you want, for the end.
Last session privileges, I guess.
Yes. So yeah, Arnaud, which was my partner in crime during all this day, as he was managing backstage and chats for all that very intense day of conference.
Yeah, I was in the shadow completely for the whole day. So it's really amazing to be just on stage, just to give you a few words. And really, Adrian, this session, really amazing just to finish this day with this session. I mean, with the Green IT, multi-cloud, I mean, it's going to be a huge topic for the next few years. So really, thank you so much.
Thank you. Glad to be here, and glad this was an awesome conference, by the way.
Yeah, thank you. And we want to finish with a all-around tour of everyone in the team first, because we are not just two of us. We were 7 actually, working hard to prepare that conference for you for months now. So we hope you liked it, really. And it won't be possible without our kind sponsors and partners. So first, by the way, our gold and silver sponsors that bring the money to make that possible, to make that even free for everyone. So that was really important from the beginning to us, to open that to the community. But also other partner and friends that help us in a lot of different ways, like Sense of Tech, which bring all the platform, the website, the live, the feedbacks and everything, and also the MIC, so the Meet, Innovate, Create in Belgium, which produced all that videos, and with the sound you had between sessions. They made that for free for us. It was a great help and it was really appreciated. And also for the amazing artists that made all that logo and all that beautiful visual. So yeah, it was a whole team, really an amazing work for months, an amazing journey. So we really hope you liked it, because last but not least, we want to thank you. We want to thank all the speakers first, because they trust us for the very first edition of that conference. So it means a lot. Thank you for all of them. And also thank you for all of you to attend the TheCloudFirst. We hope you liked it. For the last time, we ask you to go to give your feedback, as it's really important to us to know, because if you liked it, we want to know it, or even if you don't like it, because we gotta know if maybe we will do another TheCloudFirst next year. Hopefully you like it, but you can also say if you don't. That's okay. And also don't decide if you didn't manage to see all the sessions you wanted, because there are 2 sessions at the same time. All sessions will be available on replay after the event, a few days after, on the YouTube channel. So don't feel sad if you miss something. You will be able to see that after. Okay, this is it. I think we can close the event. Thank you, everyone. Thank you, Adrienne. And maybe see you next year.
Yes.
Hopefully.
Thanks.